Unless you want the music, you let us know.
Oh, the music! I think it's really nice. It's like a podcast. Okay. Can I get rid of this? Oh my gosh. Excuse me, do this. Okay, I'm going to talk. Great. Disaster response typically targets people who were directly hit by these events, but if there is trade, the cost of a disaster could be spread much more widely, such that their economic incidence differs from the physical footprint of the event. Intuitively, where we live and we work and we get our food from are not all the same place. So my workplace could be underwater, even if my home is not. And also there can be general equilibrium effects. So flooding in one location can affect prices and wages in another. In this paper, we're going to show this isn't just like theoretically possible, but it's quantitatively important. In particular, we're going to show that the losses you suffer from a flood depend both on whether you were directly hit and on flooding in the surrounding area. And we're going to argue that if you ignore this indirect exposure, you'll conclude that the impacts of floods are more modest than they actually are. You're going to misjudge how the costs are allocated across people. And then as a result, you'll misallocate disaster relief. We're going to build that argument in two stages. First, we're going to study a really large-scale flood and show that its incidence differs from its physical footprint. In particular, we're going to study the floods from Pakistan in 2022, which were really very enormous. To study this event, we're going to collect our own survey data, surveying 5,100 rural households 1 and 2 years after the floods. We're going to use satellite data to measure their exposure to flooding and separate this into two components: their direct exposure, so flooding kind of in a 1 kilometer radius around them, and their indirect exposure, which is going to be flooding from 1 to 15 kilometers. We're then going to use a recentered IV design to separately identify the effects of these two things on their economic outcomes. Intuitively, our design is going to exploit kind of deviations in flooding from its expectation. What we find is that if you only include direct exposure in your analysis, you're going to conclude that floods destroy homes and destroy crops, but have really only modest impacts on other economic outcomes, which was very surprising to us given how big these floods were. However, once we then incorporate indirect exposure into the analysis, you'll find that it's through this channel that you get increases in unemployment, increases in prices, and reductions in real expenditure. So in other words, just knowing whether someone's home and village was underwater is not enough to know how affected they were by this event. In the second part of the paper, we want to ask, if the incidence of a flood is different from its physical footprint, how then should we allocate disaster relief? We could do that by just taking our estimates from the first part, turning them into a welfare measure, and then using that to think about optimal aid. But we'd like to do this in a way which is more general and can help us think about floods in different contexts and different sizes and different economies. So what we're going to do is build a quantitative spatial model with trade and commuting, in which your welfare depends on market access, not just what's happening where you live. It's going to capture the GE effects of floods through trade and good markets. And using this model, we're going to be able to compute the change in welfare in any location as a result of a particular flood. We're then going to use the model to think about different transfer policies. So we're going to compare a planner who can allocate aid just to people who are physically exposed versus one who's able to think about targeting on the basis of this incidence. We're going to find that when they do this incidence targeting, they're going to improve welfare because they're going to send more aid to people who are flooded and in areas of widespread inundation. In particular, what we're going to then think about is the fact that the gains from this incidence targeting are going to be largest when the floods are really big. Great. So I'm going to dive straight in and tell you about our context of Pakistan. So in Pakistan, they had these huge floods in 2022. They were enormous. That year, they had the heaviest monsoon rain in 4 decades. 7% of the country was underwater. Many places were inundated for up to 7 months. And all of which is exactly why we really wanted to study this event, particularly because it's the kind of flood that we think will become more common as a result of climate change. Now, we're trying to study the impact of flooding on household outcomes and physical damage. So we needed 3 types of data. We need household outcomes, physical damage, and flooding. I'm going to tell you where we get each of them. So for household outcomes, we went to Sindh, which was the most affected province, and we collected our own survey data. So we started by getting access to an NGO administrative data, which covered all poor households in 6 districts of Sindh. So over here, the map is showing you this is Pakistan, the red outline is Sindh, and then the orange areas are where we had this NGO data set. We then randomly sampled 5,100 households from that data set and surveyed them 1 and 2 years after the floods. And we found the vast majority of them where they had been before the floods. From that data, the main outcomes we're going to take are going to be employment, consumer prices, and consumption. For physical damage, we got access to official data from the government of Sindh. So after the floods, they sent out the army to survey every single damaged property. So we have property level microdata on housing damages. This is a data set that contains 1.96 million damaged homes and their GPS coordinates. We then combine this with satellite images on building footprints in order to construct, like at a small area, the share of homes that were damaged. Then to measure damage to crops, we're going to use a classic proxy of NDVI, which is just measuring how green the land is. And then finally, flooding. So for our flood measure, we're going to combine satellite data from both the MODIS and the Sentinel-1 satellites. And we're going to construct an index which combines both the extent of the flooding, how long it lasted, and how deep the water was. So it's key that we're not just using a binary, yes, no, they were flooded. There was huge variation in the intensity of flooding in this context. So we wanted an index that would capture this. We construct this index at like very small hexagon levels. They're around 400 meters across. This is just showing you the index for one of our districts, Larkana. To give you a sense of the range, a hexagon in the first decile has basically no flooding. A hexagon in the median was 5% flooded in September, basically wasn't flooded anymore in December, and had a maximum depth of 0.2 meters. Whereas when we go into the top decile, it was pretty much entirely flooded in September, was still 25% of it underwater in December, and had a maximum depth of 1.3 meters. Great. So with this data, let me tell you about our research design. We are interested in running this cross-sectional regression. We would like to run the regression of outcome Y for household I on their direct and indirect exposure to flooding in 2022, and potentially a vector of controls. We're going to use district fixed effects. Before we can run this, I want to talk first about how we construct these exposure measures, and then let's think about endogeneity. So take this orange dot, who's going to be household I. We're going to define their direct exposure to flooding as the average flooding in a 0 to 1 kilometer around the household. Ideally, that would probably be 0 kilometers, but we want to allow for measurement error in GPS in exactly where we surveyed the household in the flooding data, so we're going to be a little more generous. And if anything, that's going to just make us think that indirect is less important than it is. For indirect exposure, we need to take a stance on which other locations flooding matters for household I. Pretty much any spatial model would say that closer locations are going to matter more. So we define indirect exposure as a distance-weighted average of flooding from 1 to 15 kilometers. We can't go much further because we start to run out of power, but that's going to be our measure. What I can tell you is that nothing I'm going to show you today is sensitive to small changes in these cutoffs or in the weights that we use. Great. So then endogeneity. The challenge that we have running this cross-sectional regression is that some locations systematically flood more than others. You can think of that being for many reasons. They have a rainier climate, they have rainier upstream neighbors, they're low-lying, they're closer to rivers, and all of these things you would expect would be correlated with unobserved things that might drive outcomes, such as agricultural productivity. So what we would really like is we would like some sort of variation in flooding, which is uncorrelated with these unobservable drivers of outcomes. And we're going to argue that we can isolate that by using Borosiak and Hull's recentered IV approach. Intuitively, we think that flooding is partly systematic. Wherever the rain goes, some locations will always flood. But then there's also some randomness, which is exactly where the rain happens to fall each year. It varies from year to year, and sometimes it's going to hit this location, sometimes it's going to hit this location. So what we're going to do is use a hydrological model to simulate the expected flooding in each location, which we can then strip out and just use the deviation of flooding from this expectation to construct our instruments. I'm going to tell you how we do that, and then I'm going to show you how we do that. So there's 5 steps. We're going to take 25 years of Pakistan's monsoon rainfall, use a hydrological model to simulate flooding under each year's rainfall. Then we can average across those years to get the expected flooding. We then take the prediction for 2022, subtract the expectation, and then this is going to give us this deviations at these small areas that we can aggregate up in exactly the same way to get an instrument for direct exposure and an instrument for indirect exposure. Let me show you with pictures. So it's not quite 25 years because they wouldn't fit nicely on the slide, but this is 25 years we're going to take 25 years of monsoon rainfall, and we're going to simulate this using a hydrological model. This is showing you the output of that model for one district, QSK. And you can see that some areas always are kind of lighting up more often in blue. We can then average this across the years to get the expected flooding in each location, and we can construct our recenter prediction. So we take the prediction for 2022, we subtract the expected exposure. This gives us the recentered instrument. This is the components of the recentered instrument. We then are going to intuitively take person I, average it a 1 kilometer around, then that gives you the instrument for their direct exposure. Do the weighted average from 1 to 15, that gives you the instrument for their indirect exposure. Okay, and the identifying assumption here is that this predicted deviation is uncorrelated with the unobservable drivers of outcomes controlling for district fixed effects. And a couple of things I can tell you to support that is that if we use lasso to control for all of the baseline variables that we have, it doesn't change our results at all. And also that our results are robust if we try to control for the variance of these predicted deviations. Great. So with that, let me tell you our results. So I'm going to show you results from one of two regressions. I'm either going to show you the naive regression where we just include direct exposure, or I'm going to show you the results from the joint where we have both direct and indirect exposure in the regression. My standard errors are going to be Conley. We are in process doing randomization inference, which is what we think we should be doing. And if anything, it suggests the standard errors I'm going to show you are a bit too conservative. Just quickly on the first stage, we have a great first stage. Our F-stats are really great. Each instrument really strongly predicts the associated endogenous variable. Okay. So firstly, to build confidence that our measure of direct exposure captures flooding like where somebody lives and that indirect exposure does not capture this, I'm going to show you that direct exposure causes physical damage and that indirect exposure does not cause physical damage, which is a really nice, we think is a nice placebo check of our design. So firstly, I'm going to show you that direct exposure causes housing damage. The way to interpret this coefficient is that a 1 standard deviation increase in direct exposure leads to a 0.25 standard deviation increase in the share of homes that are damaged. That's about a 6 percentage point effect. I can also show you this for crops. So if we look at NDVI in September 2022, which is when crops really should have been at their peak, it's right before harvest, we see that we have a 0.7 standard deviation reduction in crop cover. That's like a 26%. It's a very large effect. Then if we control for indirect exposure, you can kind of almost, they barely move at all. And if we look at indirect exposure does not cause damage to housing and doesn't cause damage to crops. Great. Now I'm going to move on to the other economic outcomes. Let's first look at our kind of naive results. If we just look at the impact of direct exposure on its own on some of these results. So what we find is that direct exposure doesn't seem to move employment outcomes. It's associated with a small increase in prices. This is about a 3% increase in prices that consumers pay, and a small reduction in real expenditure. However, if I then control for indirect exposure, these results kind of disappear. And what we see is this is all going to be really coming through indirect exposure. So if you have more indirect exposure, you are going to be much less likely to be employed by somebody else. And this is offset by a substitution into self-employment. Just want to pause on this for a second, because in this context, self-employment isn't people moving into like innovative entrepreneurial activity. This is normally thought of as people are trying to make ends meet, and so they're kind of doing a mix of different things. So we really think that this work for others effect is capturing kind of the real, real worsening of labor market conditions. So this is about, there are 9 percentage points less likely to be in paid work for somebody else, and it's offset by a 5 percentage point shift into self-employment. If we then look at prices, we find an 8% increase in the price index and a reduction in real consumption coming through indirect exposure. Great. So this really asks the question of, given these patterns, does aid reflect this pattern of effects? Like, does aid follow indirect exposure? What we find is that if you were more directly exposed, you are more likely to receive aid, which makes sense. However, if anything, indirect exposure, it's not significant, but if anything, this reduces the likelihood that you received aid, which is consistent with maybe they're trying to reach people who are directly exposed, but there's some sort of local rationing, or it's harder to reach people who are right in the middle of areas of widespread inundation. This really raises the question, which leads us nicely into the second part of, could we do better with disaster assistance? So this leads us to part two, when we're going to ask, if the incidence of a disaster is different from its physical footprint, how should we allocate disaster assistance? Now, like I said, we're going to try and do this in a way that allows us to think generally about different kinds of different economies, different types of floods, big floods, small floods, very concentrated floods, really dispersed floods. We're going to do this in 3 steps. We're going to write down a spatial model with trade and commuting. We're going to add in the planner's problem, and then we're going to characterize and calculate welfare gains from optimal aid. Okay, so let me tell you about the model. The model is basically, we try to keep it as simple as possible. It's Eton Quantum with commuting and some housing. So there are N locations, each are home to L workers. They have a fixed place of residence, but they can work and shop anywhere, subject to iceberg trade and commuting costs. There's a continuum of goods which can be produced in any location using labor and land. Each location might differ in its average productivity and also in its idiosyncratic productivity for each of these goods. Markets are going to be perfectly competitive, so goods will be priced at their unit cost. This is going to give us the normal trade, that people are going to source things from the cheapest place to get them, so it's going to give us the normal trade shares. You're going to purchase more from locations that have higher productivity, lower costs, and which are closer to you. On the labor side, people get to choose where they want to work. They mostly are going to care about wages and commuting costs, but they also have idiosyncratic preferences, which gives us these nice normal commuting shares where the share of people that commute to a particular location will be increasing in its wage and decreasing in how far away it is. If those were all of the components of the model, welfare would just be this. It would effectively be their real wage, which depends on their market access. But we're going to add one more thing, which is that people are going to have a non-tradable endowment of housing. And we're basically putting that in there for accounting reasons so that we can look at the impact of housing damage. Great. So what is a flood in this model? In the model, we think of the flood as doing 2 things. Firstly, it destroys housing. So it's going to lead to a reduction in the housing endowment. And for now, we've assumed that this has no GE consequences. So exactly what shuts that down is we assume it's non-tradable and they can't reinvest in it. So this destruction of housing is just going to be localized to the people who experience it. They also are going to reduce average productivity in a location which is flooded, which you can think of as isomorphic to taking some of the land out of action. This is going to have GE consequences. These are the main GE mechanisms we focus on. So when you reduce average productivity, that's going to increase prices and reduce wages in the flooded locations. People's exposure to those changes are going to depend on their pre-flood trade and commuting shares. So the change in welfare experience into first order is going to depend on the change in wages in every location, weighted by how likely I was to commute there, and the change in prices in every location weighted by how much I tended to buy from there. So this is that first level of where I shop and work and live aren't the same place, so I can be exposed to what's going on in other locations. There's then going to be a second round of these wages and prices themselves will be shifting because of general equilibrium adjustments as people change their commuting and trade behavior. So the vision is eventually we're going to have a set of kind of more general theoretical results and then a calibration specific to Pakistan so that we can have Pakistan-specific welfare numbers. For now, I'm going to show you a super simple simulation of the model where everywhere is identical before the flood. And we're going to do that just to focus on kind of the key things of what's going on here. The calibration is intended to be uncontroversial, but I'm sure you'll let me know if it's controversial. Okay. So here is my economy. My economy is 400 locations on a grid. Can you see the little outlines? Maybe not. Should have made them darker. And my flood is this very realistic circle in the middle of the grid. And so what we can do with the model is we can feed this in and we can work out how everybody's welfare is changing in every location. The first thing I want to show you is that the model is going to behave or have predictions very similar to what we saw in our empirical results, which shouldn't surprise you because we chose the model. But what we find is that if you run the same regressions on the output of the model that we ran in our data, that direct exposure entirely accounts for housing damage and indirect exposure doesn't lead to housing damage. then everything that's coming through cost of living, so prices and your access to jobs is mostly driven by indirect exposure. And then the welfare sits somewhere in between. It partly depends on direct exposure, partly on indirect. What we can do with the model is that we can compute the change in welfare in every location that results from a given flood. So on the right, this is showing you the welfare loss in each location from the flood on the left. You see that the welfare loss is highest right in the middle of the flood, where people are both directly and indirectly exposed, and then it sort of fades as you move outwards. So now the question is, with a planner who sees these welfare losses, how would they want to target assistance? We're going to think about a planner who is trying to minimize the welfare costs of the flood. So they see every single person's individual losses, and they're allowed to choose transfers to each location in order to offset these losses, subject to a budget constraint. If we make some very strong assumptions, like, or maybe not that strong, with this, everybody was the same before the flood and that this U is concave, then you can think about it as the planner is going to just want to minimize the consumption variance across locations, which I think is a nice way to think about it. We're going to then compare in our simple simulation 2 policies. One is targeting on physical exposure, where all the planner can do is split their budget equally across flooded locations. And then optimal targeting, where they know these losses and they can vary the transfers freely across location. And so effectively what they're going to do is they're going to set a transfer which is increasing the loss. And using this, we want to explore how the welfare gains from optimal targeting really vary with the characteristics of the economy and the flood. Because I guess I should say it's kind of obvious that if you allow the planner to have more information and target on more, that it'll be weakly better. So we really want to understand when are these welfare gains particularly important. Let me show you a quick from our little simulation. So on the left-hand side, every single black dot is a flooded location. And here, this is our physical exposure targeting. The planner has just spread their budget equally across every location. If we compare that to the optimal for a given budget, we find that they're going to prioritize sending money to the very middle of the flood. And for this given budget, they're going to get 7% more welfare per dollar from this allocation than from the pure physical exposure targeting. Now, I've shown you an example where all they're really doing is prioritizing the middle of the flood. As we increase the budget, it's going to change slightly. So they're still going to prioritize the middle, but as the budget increases, they're going to spread the budget further out. Great. Oh, okay. So the last thing I want to say is just to give you a sense of where we're going in terms of thinking about how these welfare gains depend on the characteristics of the flood itself. And in particular, we want to tell you that the welfare gains are going to increase with how big the flood is, in particular, how many locations the flood covers. To think about that intuitively, the gains from targeting based on incidents are going to really come from there being variation in how much losses people experience within a particular flood category. So if you are the planner with physical exposure can send money to people who are flooded and not send it to people who are not flooded. If there is variation amongst the flooded and variation amongst the unflooded, then allowing them to target on that is going to is going to lead to welfare gains. So the welfare gains are going to be bigger when there is more variance of losses. And we can, yes. When there is a bigger flood, so a larger share of locations are affected, this is going to increase the variance. Intuitively, amongst people who are flooded, if the flood is bigger, there is more scope for you to be very far from dry land. So it's going to be very different if you're someone right at the edge versus you're someone right in the middle of the flood. And amongst the unflooded, you're generally more likely to be near an area of flooding. So there's going to be more variation amongst the unflooded in whether you're very far from the flooding or very close to the flooding. So when the flood gets bigger, at least up to about, in our simulations, like half of the economy being flooded, which we hope we don't experience floods like that, then the gains from incidence targeting are going to be increasing in the size of the flood. Great. Perfect. So just to really quickly conclude, the incidence of a flood is not the same as its physical footprint, is what we wanted to argue in this paper. We wanted to argue that if you ignore this, you'll overlook some of the important impacts of floods and misallocate aid. And as climate change makes floods bigger, this is likely to only matter more. Thank you very much.
Thank you. Discussing is Dev Patel, now transitioning to Brown.
Great. Well, thank you so much for giving me the chance to discuss this amazing paper. I won't rehash that fantastic talk, but just to say, I think this paper was really wonderful, lots of rich economics in it, really careful data work, and it was a really pleasure to read. I encourage you all to read a draft as soon as it's posted. Okay, so today I'm going to talk to you about three things. First, I'll talk to you about rain. Then I'll try to dive into this indirect exposure idea. And then finally, talk a few words about what optimal policy is going to be here. Okay, so just from a pure climate science perspective, rain is really hard to understand. Our models of precipitation are just far behind what climate scientists would like them to be. One way of visualizing that is these two graphs. These show projections of what precipitation will be like under climate change. The map on the left shows the 10th percentile model, and the map on the right shows the 90th percentile model. And basically, the takeaway is that the climate models about precipitation are so uncertain, we don't know if rain is going to go way up or way down in the future. And so this is just to illustrate that understanding rain is hard. This might be particularly true in a place like Pakistan. So as the authors point out in their paper, there's not a lot of ground truth weather stations in Pakistan. So here I tried to map every single weather station I could find that would cover the kind of 2022 floods in Sindh, which is the region that they study. And there's only 12 that I could find. And often many of these are not even in the kind of 6 districts that they talked about. And so this is a problem, not just in Pakistan, but also all around the world. I kind of scattered a bunch of points around the world, calculated on the y-axis how far they are from a weather station, on the x-axis the income of the country where that point lays. And you see that there's a very strong negative relationship. Basically, in rich countries, we have a lot more density of weather stations than in poor countries. And that's going to be problematic if we're trying to extrapolate models from far away from the equator towards close to the equator. And so the authors, what they do to try to get around this is use this kind of NASA NBER precipitation product. So what that is basically the map on the left shows for Sindh the different grid cells that this product estimates precipitation on. And then the author's unit of analysis are all these tiny little hexagons, that so about 150 hexagons per pixel. And what that data is actually made up of is it's using a bunch of products, satellites, atmospheric models, and then in particular, it's also using rain gauge data to try to calibrate that model to figure out what the actual amount of rain is in a place. But as we just saw, in a place like Pakistan, we don't have that much of that ground truth data. And so it becomes kind of harder to do that rainfall calibration. And so the question I want to ask today is how reliable are those gridded rainfall estimates? Of course, we just said we don't have the ground truth. So the idea that I had was basically let's take not just that NBER gridded data set, but let's take a bunch of other gridded data sets for precipitation. So here are 6 other additional data sets that one could use. Take a bunch of hexagons of the same size that they use in the paper in Sindh, and then calculate rain using each of these 7 different data sets. And so that allows me to ask the question, so in their kind of study sample on a given place on a given day in the 2022 flood season, did it rain? And it turns out that there's can be quite a bit of variance across different products in the answer to that question. And so about a third of the time, depending on which product you use, you might get either yes or no to that question. If you kind of adjust for the base rate here, you can get a statistic of about 0.66. So this is certainly not, these things are not completely uncorrelated. It's not 0, but it's also not 1. They're not kind of perfectly in agreement. Okay, so rain is hard. What is we saw in the binary case, it's hard. What about in terms of volume? So this is now a graph where I've just picked a polygon that has the median spread across these different 7 products. So the author's choice of precipitation data set for that polygon estimates about 17 millimeters of rain on that day. If you use a different data set, you might get 3 times as much rain or a third as much. And so there's kind of quite a bit of variance across products in the volume. Okay, so rain is hard. Everyone, the climate scientists are well aware of this. What does that mean for this paper? So the kind of key identification approach of this paper is to say, let's take the historical rainfall distribution, simulate that DGP, and now look at deviations from that DGP to estimate flooding. And so the problem is that if we don't really know that DGP because the climate science is still lagging behind, we might be slightly misspecified in that exercise. There's another problem, which is that in that NBER data set, we only have going back about 25 years prior to the flood. And so if you were to do kind of a randomization inference exercise, of course, you have to use each year as an independent sample because within year, things are not independent. And so then you also just get a fundamental power problem in like a 2-sided test. You're only going to be able to detect about kind of a 0.08 p-value for an extreme year. And that's going to get even worse, of course, if you allow for serial correlation over time for things like El Nino. And so one idea is to, instead of trying to simulate the DGP from a kind of very small amount of data, is to use an approach that I really like from this paper by Francis Anand and co-authors, which is to leverage forecasts. And the idea is that forecasts, first of all, there's lots of n, so you can get a kind of bigger sample, but also it gives you an expectation about kind of what the best expectation of risk might be. And so that might be another approach to trying to get around some of these issues. Okay, so now in my last 5 minutes, I'll talk about indirect exposure and optimal policy. So indirect exposure, I want to start with this beautiful graph from the appendix of the paper that I've chopped up and drawn on, so it's more pretty in the paper. The x-axis here is the distance from the household. The authors are choosing a boundary of 1.1 kilometers, and then everything to the left of that is what they're calling a direct effect. And then to the right of that is this indirect effect, and so they're kind of have a weight where if you're closer to that direct boundary, the weights are going to be higher, and they're going to put more emphasis on those data points. And so what the authors do is say, okay, we have a direct effect and indirect effect, and they're going to interpret treatment effects of the indirect effect as reflecting trade. And so to quote from their paper, they say that under autarky, we should expect all the effects to be about this kind of direct effect on the dirty place. And so the question I want to pose is, are there other things other than trade that we think operate outside of this kind of 1.1 kilometer boundary that could be important here? So to put a little bit of data on that, I just took this Pakistan Rural Household Panel Survey that has a bunch of households, including in this kind of Sindh district. And I look at 3 variables. The first is how far is your plot from your home? The second is how far is the place where you sell from your home? And the third is how far is the farm that you work at if you're an agricultural laborer from your home. So I'm just going to show you now, I've made the x-axis here try to match their beautiful appendix graph, drawn a line here about their indirect and indirect boundary, and I'm just going to show you some CDFs. So first, this is the kind of CDF of non-homestead plots, distance from the home. And what you see is that about 40% of these plots are in the kind of indirect region here. And what's more is that these plots are not just kind of random. If I change the y-axis now to be how big that plot is in acres, you see that they're also kind of systematically larger. These are kind of the bigger plots, which makes sense. Like in a village, close to the houses, they're all clumped together. Plots are small, and then you want to go, if you're a bigger plot, you have to go farther away. And so to me, this raises the question of, is this indirect effect driven by essentially flooding on kind of households' most important land, the land that's most important for their balance sheet? The second thing I looked at was this kind of where do you sell? And so here, what was kind of surprising to me was that lots of sales are pretty far away. And so if you kind of remember their weight function, it seems like actually a lot of these kind of indirect effects about trade might be happening even farther away. And so I'm wondering if even they're kind of doing a lower bound from their current estimates because their kind of kernel is so emphasized close to this boundary. And then the third thing, this is a really small sample, so I don't want to put too much weight here, but most of the hiring in this kind of Pakistan Rural Household Survey was really, really local. And so I thought this was just very surprising to me. I didn't quite believe this number when I saw it, but I think kind of any more that the authors can do to shed light on this labor market stuff would be super, super interesting. Okay, and so my last minutes, I'll talk to you about this optimal policy question that the authors end on. So they're asking essentially, where should we put aid? What's the best allocation of aid? And on some level, this is kind of a prediction problem. And so what they're showing is that if you have a function that includes your neighbor's floods, that's going to do better at targeting losses than kind of your own. And I think what I would love to see is a little bit more on just what the different conditions are under which we should think of this as optimal. So for example, you could think about lots of other data, other predictors that you might include to make that prediction function go even better. But also imagine that policymakers, like they did in Pakistan with the housing survey, just go and measure damages directly. So they could maybe even sidestep a bunch of this, and how costly would that data collection have to be for this to be optimal? Okay, overall, this is a really amazing paper, and yeah, thanks so much for a great talk.
Thank you. We're going to do it like yesterday. For those of you who have comments, please start lining up, and I'll give Paul some time to respond to this.
Okay. Firstly, thank you so much for such a fantastic discussion. There is too much to respond to, but I'm going to say a couple of things. One is on the rain, is it's like totally a no-brainer. We should definitely do that, and we will definitely do that. On the indirect exposure, I think I agree with you that I think we're probably underestimating this in some sense, because our price effects, if we drag out that kernel further, just keep getting bigger, but then we run out of power. So I think I always would think about what we have as an underestimate of, and there's going to be a bunch more GE effects that we're unable to capture. We also have a lot more data in our data set about networks and where people work and commuting behavior. So I think there's a lot more we can do to shed light on what the patterns you showed look like in our data. And one thing that I do think it makes me think of, if there's like a really important channel that we've missed, we would probably want to try and put that in the model. And then finally, on the should we use machine learning instead? I think it's super cool to think about how machine learning approaches versus model-based approaches would have really different, or how well they would perform in terms of external validity. Because I think something we're really interested in is not just whether we can do a good job at predicting losses for this flood or targeting aid for this flood, but how we could do this for other floods. And I think that one thing is really hard in what you said about collecting data on losses, and I think is a whole reason why so much aid is targeted towards physical damage, is that when someone's home is destroyed, it's quite easy to figure out what the counterfactual was, that it probably wasn't going to be damaged if there was a flood. Whereas if you look at unemployment, it's kind of harder to figure out, did they lose their job because of the floods? And it's presumably not like incentive compatible for someone to return. And they might not even know that the prices are high because of the floods. But yeah, thank you so much. Really appreciate it.
I was very interested in the policy implications for aid allocation, and I was thinking in particular about the political economy of this aid allocation. I suppose as a politician, in some sense, I'm a little nervous to give money to people who weren't directly hit. One, because there's this political salience issue, like I'm giving money to someone who wasn't hit potentially at the expense of someone who really was hit. There's also a certainty issue that you just raised, which is that if you get hit directly, I know for sure that you were impacted. And so I'm curious how you think about that. Of course, at the same time, this qualitative point that the indirect effects are important, that you want to take this holistic view of assessing flood damages, those are important points.
I think what you say is extremely important. And I would just say two things in response. One is that a lot of, I think, what our predictions would be is that you should send more aid to the people who were flooded, but who are like really in areas of widespread inundation. So that might alleviate some of these constraints, in that you're already targeting people who are directly flooded. The second thing is that lots of policies around the world already are accidentally, perhaps, sending money to people who were indirectly affected. So in Pakistan, they had a cash transfer. They listed a bunch of districts, decided who was eligible, and every poor person in that district got a cash transfer, which means there was huge heterogeneity in the share of them who were actually flooded. So part of what I'm thinking is that like these things are already happening through the way that we come up with these kind of arbitrary county level, district level lists of who is affected. And maybe we could just use this to inform how those lists are drawn up, rather than necessarily coming up with all of these programs that target the indirectly affected. Yeah. We're also already doing lots of this with social insurance. So like outside of Pakistan, when we have like responsive social insurance programs that respond, we're already implicitly doing this. So you wouldn't necessarily need to add this in a high income context with social protection. Do I go this side?
Just a quick suggestion to your first part of the paper. I think the binary definition of direct and indirect is very clean and clear, so that's great. But also you can do continuous measure of distance. So like distance to the flat, and you can run OLS, and also you can use the same instrument to get an IB version of it, and just plot the damage over continuous measure of distance. So then, you can discuss more about, where damage is big and getting smaller. So maybe you have done this already, but in addition to what you have, this can be helpful.
Yeah, thank you so much. That's really great. I guess, as you'll have inferred, it's really easy to aggregate our stuff into any kind of treatment measure that you want. And so we have run a bunch of kind of like buffer ones where you drag out the buffer. And so it's always a question of which to show, but that's a great suggestion. Thank you.
Very interesting paper. Two questions. One related to the cash transfer programs you already mentioned. So Greg Lane's work on, how providing credit before these events happen might have an offsetting effect. And so since you have these direct and predictable places, so there might be a role for those types of interventions. The second is related to technology. So there's some evidence in Mozambique, for example, that mobile money, when people have access to this technology, they migrate more out of the places that are frequently flooded. And not only that benefiting the people who are mostly likely to be affected, they start remitting money back to the people who stayed, and that offsets some of these losses as well. So I think in terms of thinking about optimal policy, it might be interesting to try to bring these two elements. So I'm just curious if you have thought about that and how could you implement in your setting? Thank you.
I think that's super interesting. I think on the first, we do kind of imagine that with this sort of thing, it would be a logical extension to try and think about like parametric triggers for payout. So you wouldn't need to wait until the flood happens. We do a lot of stuff where the flood happens and then we try and go out and collect data and then we try and think about who we need to send money to. Whereas when we're doing those early rapid responses, maybe we could use this to try and figure out who do we most need to prioritize. And I think that's a really interesting use of it. And also you could do that with any program that you have in mind, including loans. On the mobile money migration stuff, I think it's really interesting to think about how aid changes these kind of risk-sharing networks. It's not really something that we've covered. One just thing to say about our context is that the flooding was worse in places where it never floods and are extremely low risk. So it's not really a direct response to your question, but migration is what we thought this paper was going to be about, and then nobody migrated, which is probably because if you wanted to go somewhere lower flood risk in Pakistan, you probably have to leave Pakistan. Yeah. Hi.
Great, super neat paper. I've got two questions. The first one's about the mechanism of those indirect losses. It seemed like you had a super important result about self-employment versus employment by others. And I'm wondering if the story there is that many people are working on large farms, and that those large farms nearby get hit. And so maybe a way you could get at that is if you have any data on parcel sizes or landholding sizes, you could use some heterogeneity to test whether the places with large farms nearby are getting hit more. And second question is sort of tied to Edson's question, but are there factors that might improve people's resilience to these floods and their ability to bounce back? I don't know if you have long-term data, but things like household savings or household education or the diversification of their household livelihood strategies. Is any of that helping resilience or helping folks to bounce back? And could that play into the optimal targeting projects?
Really interesting. Okay. On the parcel size heterogeneity, I think that's such a nice point. We should definitely do that. I can say that basically our labor results are really driven by people who were working in agriculture before. So we really think this is something that's going on with agriculture. I really like the plot size point. On the factors that improve resilience to floods, it's hard because we can't randomize them, but we could do we've been playing around with some of these like heterogeneity of treatment effect stuff. And so we could try and look a bit more at characteristics of the household that seems to predict what their losses were. It would be descriptive, but I think it would be cool to do. We're also, as a side note, they're rebuilding all of these homes, and we're working with the government to evaluate that reconstruction program. So I think that would also be really interesting to survey those guys over a few years and see how that affects resilience to future climate shocks. Thank you.
Hi, thanks. Very interesting. My first comment is actually related as well. Like I was wondering for the indirect effect, whether you could interact that with the type of land that's around. So is it like, cropland? Are there roads? Are there manufacturing? Is there manufacturing or whatnot? And then the second question I had was whether you could also think about impacts on the trade cost in the model. And one thing that actually can be interested here is that, if trade costs go up, that actually makes it harder to help people because there is a bigger cost of aid as well.
Yeah. On the type of land, we should just definitely do that. On the trade cost, I think it's super interesting because we've done some playing around with, if you're just an economy with very high trade costs, then of course physical exposure is a great proxy for damage because there's no trade and so it stays very local. But then what's different is if the trade costs change because of the flood. And then I think you get this interesting heterogeneity. I think my intuition is that the indirect exposure effect would be very different depending on whether you're in the flood, because you can't get out of the flood, versus where you're outside of the flood and you still have access to all these other dry areas. We're not powered to estimate these interaction effects, but I think we could definitely in the model think about playing around with that. I think it'd be really cool. Thanks.
You analyze a planner who's minimizing the welfare loss remaining after aid is provided after a flood. I was curious why that objective function. A common assumption would be that the planner is maximizing social welfare and designing a social insurance system. if they're the same, you could just reframe it. And if not, you can calculate both and see why they're different and argue why the objective function is more appropriate in one case or another.
So we started with thinking about losses because it seemed to me that that was what was different about flood responses, that we're not always seeming to just try to support the poorest and that this isn't just like a poverty alleviation program. But you're right that in exactly the way, with all the simplifications we've made, it's exactly the same here as just, they're just inequality versus they're just trying to reduce inequality. I think it would be, the main thing I think it would pick up is that if you are, it is what you're going to do about people who have different incomes and the weights that you're going to put on those. I think we could think more about that. We hadn't prioritized that for now because our study population are all kind of very similar income, but I think we could look more into that. Thank you. And do both is a good idea.
Hi, great paper. I was wondering if this is kind of related to Alan's question, if you could say any more about what are the key constraints to like real life aid policy and whether there is anything you can model, any policy that's kind of between the policy you see and like what gets you to the first best that still respects those constraints. I think that could be really interesting to explore.
I think that's a really great idea. I think we've started with these two very simple policies, but I think what would be great would be to take a few different examples of policies that are done. Like okay, if it's going to be done where we're going to split it up by district and we're going to decide which districts are eligible, how should we do that? Or if we can do, I think the other thing we played around with is thinking about, going back to David's point, the cost of aid and whether it's harder to reach certain locations. But yeah, thank you so much.
I guess I wanted to ask a little bit about how you set up the direct damage in the model. As I understand it, it's basically like a shock to the service flow from a house. But we might think that the damage is also a shock to the household balance sheet and like a big wealth shock. And so when accounting for the direct effects, I might imagine that that's actually a very large component.
Mm-hmm.
And I think that would be very important for thinking about this targeting exercise.
Yeah. So I think I interpret your question as basically the model is completely static at the moment. So like there isn't really a notion of them consuming out of wealth. They just consume out of labor income. They have this housing. So anything that's coming through is they have this housing endowment, but they can't do anything about it if it's destroyed. We have played around with dynamic versions of the model. And I think it would be interesting to do more with that, to think about, you're going to get, there's going to be extra stuff that's coming through if you're destroying people's wealth at the same time. I think it's an interesting thing that we find when we do a dynamic version of the model, that these locations that are directly and indirectly affected take longer to recover because it's harder to rebuild those capital stocks. So they're both more affected in the first instance and they take longer to recover. But yeah, thank you so much.
Super cool paper. I cited it just yesterday, so it was great. Quick question on the reduced form. I imagine there are a bunch of places that were hit by direct and indirect exposure.
Mm-hmm.
Have you thought about including interaction term in your reduced form to see what that looks like?
Yeah, we try to. We don't really have enough power, I think, to do it, but we can play around more. I would love to, and I will play around more with it, but we seem to run out of power, but it might be that there's a different way to do it. Thank you. Okay.
Can I ask you a question too? So there's been some discussion about whether to build dams to protect against floods. Can you actually, in your model, simulate where the best location for the dams would be? And because you could minimize both the direct and indirect effect in your hydrological model.
Yeah, hadn't thought about it, but we definitely could. I hadn't thought about it in this context because it's not really large scale flood infrastructure. This is flooding that, like, there was a load of rain on flat land that never floods. You probably wouldn't have ever built large scale dam infrastructure there because it doesn't flood there very often. But to the extent that we're also interested in other contexts, we definitely could play around with that. It would be quite fun.
Let's thank Paul again.
Thank you for your time.
And we are moving from Pakistan to the US and housing damages from hurricanes.
All right, good morning. Thank you for having me. I'm Ben Collier from UW-Madison. This is joint work with Judd Boomauer, Patty Bourne at Florida State, and Toby Cooper at Georgia. So this paper is motivated by two trends. Natural disaster losses have been growing for decades, continue to grow, and home insurance premiums have also been growing, especially over the last 10 or so years. Interested parties, including in the insurance sector, have made a causal connection between these, noting that growing climate risk is increasing property risks, and that's driving up these premiums. And we've also seen growing interest in this space sort of from academics, noting that homeowners insurance premiums may be the most quantitatively significant channel through which households are experiencing climate change on their budgets. That's recent work from Chris and Catherine here. So this setting, these trends are motivate understanding better how risks are being capitalized into insurance prices, and how the role of climate versus other factors like exposure growth and litigation are affecting premiums. And that's the motivation for us here, and we're going to the state of Florida to study this. This is one of the largest states in the country by population and by property, and the most exposed hurricane state in the US. So we're going to ask specifically, how has growing hurricane risk been priced into home insurance? And to do so, make progress on this question, we built this new data set, which is a panel data set combining information on risk and insurance prices covering a period of 2008 to 2025, granular zip code level data. Insurers use proprietary third-party catastrophe models to understand hurricane risk. There are 7 of these models out there. Insurers almost exclusively use 2 of those models. They're called AIR, RMS. They'll show up later again in the talk. We collect information on those models, and we pair it with information on insurance prices. Our insurance price information comes from the state regulatory filings that these insurers make when they want to change the premiums that they charge their consumers. So they provide these very detailed, long documents that describe how they rate policies, how they price policies, and we have scraped those for the 15 largest insurers in the state, represent about 70% of the total market. Rate filings have some additional information on insurers' costs, distinct from these rating examples, and that shows the breakdown of hurricane costs for insurers. Again, a separate piece of information, and sort of to whet your appetite for the main results, I want to show you how insurers think about the costs they're taking on when they insure households. So there's a quick framework for thinking about this. Premiums need to cover the anticipated expenses that an insurer has for the insurer to remain sustainable. These include expected loss, of course, the risk that's transferred to the insurance policy. Also, there's this cost of capital component. This is the jargony term in this industry, which describes that insurers have to prepare for very large loss events. So in Florida, a multi-billion-dollar hurricane hitting Miami or Tampa, for example, to organize this cost of capital, insurers either need to hold large amounts of equity themselves as a buffer for this, or they need to purchase insurance themselves. Insurance for insurance companies is called reinsurance. And through these contracts, local insurers transfer risk to global insurance firms that are better able to diversify risks like hurricanes than the local insurers. So the core way that many Florida insurers are covering this cost of capital is through reinsurance. The third piece is operating costs, things like paying agents commissions and keeping the lights on, and any sort of net profit margin they have for their shareholders. This is describing insurers' costs based on their own filings for the 15 largest private insurers in the state. You can see their names here. You'll know a few of them, like State Farm and USAA. And then the vertical axis is showing average hurricane premium or average hurricane costs per policy. So the blue here is the expected loss, the anticipated loss that insurers have by taking on this hurricane risk. The reddish color is loss adjustment expenses. If a hurricane occurs, the insurer has this claims settlement process, and that's their estimate of the cost of handling claims. One of the largest components here that you'll see are these net reinsurance costs. This is the cost of reinsurance after we subtract out the expected loss that's transferred from the insurer to the reinsurance company. These costs are quite large. They're striking. It's been documented in work from even 20 years ago in terms of some limited evidence indicating that reinsurance costs can be quite high. The gray part at the top is the additional costs of paying commissions, keeping the lights on, insurers paying their own equity holders for taking risk. The key thing that I want to show you this now for is to note how small expected losses are relative to the full cost that insurers take on when they're insuring people against hurricanes. And a key theme of the paper later will be that tail risks are a big part of the challenge for insurers of taking on these risks. There are a lot of compositional differences here, where insurers locate, the kinds of target markets they they cover. This is a state level summary for these insurers. And so we're going to dig into the data to provide more precise estimates through our analysis. And so a quick preview of our results. In our regressions that we use this sort of territory level insurance information, we're estimating that a $1 increase in expected loss, a $1 increase in risk, increases premiums by about $4. Our preferred specification leverages discrete changes in these models. So CAT models are software and they update like many other sources of software in our lives. And so we look around just before versus after one of the big updates to these models to get this 1 to 4 estimate. If instead we use sort of the full variation that we have in the data, the full time series and the cross-sectional variation, we get a similar estimate. What's driving these large costs? Again, we think that this is due to the challenges of managing tail risks, that insurers have to prepare for a $90 billion hurricane event. And we can see that hurricane insurance premiums co-move with the global reinsurance cycle. These insurers are relying on reinsurance, and reinsurance is an expensive commodity. We've benefited from substantial work in this space, including from folks in the room. Thank you for that. A little bit about the home insurance market in Florida. So homeowners insurance in Florida looks like your insurance if you own a home somewhere else in the country. But it has this dedicated line in it related to covering hurricane winds. You have a dedicated premium that shows up on your policy. And if an insurer wants to change the rate they're charging you to cover hurricane premiums, they file a distinct rate filing for that. So we can see specific line item information on how much insurers are charging to cover hurricane risk. There are roughly 3 types of insurance companies in the state. There's Citizens, which is the state-run insurer. It's intended to be the insurer of last resort, but it's typically been the largest insurer in the state over the last couple of decades. There are national names that you know if you watch television and you see commercials like State Farm and Allstate. And there's a bunch of small insurers in the state that you probably haven't heard of, Universal, Slide, others. And these are helping fill the gap where the national players don't want to participate in the highest risk areas. And we've had really great work on those insurers, including by Pari, who was presenting here yesterday. Our insurance price data come from these regulatory filings, and the regulator requires that insurers provide examples of these standardized properties, these sort of representative homes in the state. So one example is a 1990 built home that's made out of masonry and that has a replacement cost value of $150,000. And then there's a standard deductible, assumed credit score, and so on. A nice feature of this is we can compare the pricing across insurers and then within an insurer over time, because these standardized examples have been set for a long period of time by the regulator. This is insurance supply information. This is insurers saying how much we would charge for specific types of property. What they actually charge, transacted data reflects demand as well. And so we compare our insurance supply data with transacted data. Ben Keys and Phil Mulder scrape data from escrow accounts showing the premiums that individuals actually pay and made that data public. And you can see here that our rate filing data have a very similar trend. This 45-degree line and our trend line are almost the same here. So this sort of unbiased estimate of what people are paying. And then there's noise around that relationship, which we think can be due to the non-standardization, that individuals have credit scores, they choose certain deductibles at different coverages and so on. Okay, here are the insurers in our data. Again, Citizens, State Farm, a number of firms you may not know, and their market shares. There are around 90 or so insurers in the state operating. The third column is showing the catastrophe model that that insurer reports to the regulator that they use. And you can see that almost every insurer relies on one of 2 models, AIR or RMS. Reinsurers report relying on those same 2 models. Industry writing around this is that there's effectively a duopoly. These 2 models dominate the market. My mental model is that insurers, brokers, reinsurers are all using these models so they can coordinate and talk to each other better. The final column is showing territories. And so you can see here that some insurers are pricing at the zip code level for a given house. It's charged the same rate wherever it is in that zip code. Others are using territories that citizens, the state-run insurers, organized, which tend to be about 8 or 9 zip codes. And then some have their own secret sauce territories, but they're very similar to citizens, and we're able to find the precise boundaries of those that allow us to make comparisons between the CAT model data, which is going to be at the zip code level, with those insurer territories. I can tell you a lot about CAT models. Grab me in the hallway later if you want to have a long discussion about them. The short version is they mix some hurricane physics, some engineering on structure vulnerability, and insurance claims data to calibrate these models of what happens to properties when a hurricane occurs. Then they simulate a bunch of hurricanes, and they use Monte Carlo simulation then to draw out probability distributions, loss distributions for individual properties or for insurers' portfolios. So they can tell you the expected loss and then loss under higher and higher quantiles of losses. There's a commission in Florida that oversees the use of these models there. And this commission meets every 2 years, and the model vendors report to the commission every 2 years on their most recent models. And just like the rate filings, this commission has these standardized examples that are very similar to the ones in the rate filing, where the model vendors report on specific homes. A key home here is a 1989 masonry home, and they take this home and they locate it at the center of every zip code in the state. So they give you this nice cross-section of how risk varies over the state, where you can compare between insurers, between CAT modelers, and you can compare over time within a CAT model how its estimates of the risk have changed. And then they also describe for a set of portfolios, including all insured properties in the state, a loss distribution. Okay, so into the data and what it shows. This is AIR. This is the most commonly used model. And this is showing hurricane risk across the state. The coloring is from AAL. This is an industry term that means expected loss, average annual loss. And this is showing expected losses per $100,000 of a home's replacement cost. The coloring probably reflects your priors in terms of where the riskiest parts of the state are, the coasts in the southern part of the state. The bright red, riskiest part of the state is in the far south, Miami, and the Keys. The table at the bottom is showing you the distribution across zip codes. So, for example, in the median zip code, if we had a house with a $200,000 replacement cost for that structure, the expected loss would be about $600. This figure is showing evolution of these models over time, and I've bolded the 2 main models, AIR and RMS. And you can see from 2006 to around 2017, they're pretty flat in terms of the average expected loss in the state. And then there's a big jump. Hurricanes Harvey, Irma, and Maria all occurred in 2017. This provided a lot of new information to these model vendors. Based on that new information, they revised their models, and you can see the shift upward following that period. We're going to leverage that change in regressions later on. We're also showing the other models in the background here that are in our data, but we don't emphasize because insurers don't tend to use them. The final thing from the CAT model data that I'm going to raise here are these exceedance curves. So this is a loss distribution. It's like a CDF, but the complement of a CDF. So it's showing losses at different quantiles. The vertical lines are expected loss. All the dollars here are real. They're in 2023 dollars. And so first, expected losses for this portfolio, which is the all insured homes in the state of Florida, has shifted from about 3.7 billion to 5.9 billion. And then insurers have to plan for these tail events. The regulator requires them to organize enough capital, typically for a 1 in 100 year type scenario. And you can see here that 1 in 100 year scenario has moved from a $58 billion hurricane to a $90 billion hurricane. So the first order effect of what's happening here is, as expected losses are shifting the entire distribution. It's been sort of shifting to the left, requiring insurers to prepare for larger and larger events over time. So we take that CAT model data and we combine it with this pricing data. And so we have 17 years, it's insurer territory year panel of premiums. And there's a lot of details here. I'm going to give you the very quick elevator version, which is that insurer territories tend to be larger than zip codes. We aggregate the risk data to match the insurer territory data. And then properties have been mitigated to some degree related to risk, and we adjust for local mitigation in terms of the premiums, so the average premiums charged in those territories for this 1989 masonry built home. And then we're going to weight these regressions based on the implied customers in those locations. Summary stats here, I won't belabor them except to note that there was a major building code reform in 2001. And one encouraging thing to see from the summary stats is if newer houses are charged much lower premiums, we don't observe the risk of those properties, but you can see it's less than half there, which I think is a very positive note for building codes and home mitigation in terms of how they can reduce, they can improve insurance affordability by reducing prices. Okay, this also from the raw data. So on the left-hand side, we're showing for each zip code, expected losses on the horizontal axis, hurricane premiums on the vertical axis. Our measure of expected loss is the average of these two main models, AIR and RMS. We find in our regressions, that's the best predictor of how insurers are using these models to price. You can see 3 lines here showing sort of this increasing gradient. In the early part of our data, 2008 to 2013, there's this relationship between risk and premiums of about $2.40. A dollar increase in premium is about $2.40 increases in premiums. And then that moves to over 4 in the last 5 years, shown here in the yellow line. The right-hand side is a sanity check. This is the non-hurricane premiums, the other stuff like covering theft and other items that are covered through homeowners insurance that are not hurricanes. And it's flat. I'd like it to be flatter than it is, but it's still pretty flat. I think there's a little slope here because people tend to locate in coastal areas, places like Miami and Tampa. But we thought this is doing a pretty reassuring that the hurricane risk is loading primarily on this hurricane premium, which you can see in raw data. Okay, the regressions that we're going to run. So the first one leverages this discrete model update following those major hurricanes I mentioned earlier. It takes a while for those models to incorporate that information that it needs to go through this commission in the state, and it becomes available for insurers to use around 2022. So what we do in this first regression is we have these insured by year fixed effects and these insured by territory fixed effects. So we're going to look at changes in expected loss. Again, the industry calls this AAL within a territory. We're going to look at how that affects premiums, looking at premiums just before versus just after this model update occurs. We have a second set of regressions where we use the full data set, and this has insurer by year fixed effects. And so this is going to leverage variation in AAL's expected losses in the cross section and look at how that relationship, take an average over time. So using the full data set to understand the relationship between expected losses and risks. Here's the regression using our discrete change in the model within territory. And here's where we're showing that $1 increase in expected losses increases premiums by about $3.90. Using the full data set, we're estimating that on average, $1 increase in expected loss increases premiums by about $3.40. And then in column 3, you can see that over time, that relationship has the steepness of that relationship has grown from around $2.40 to $4.17 over the last 5 years. We also think it's fascinating how insurers have 7 models at their disposal, how they use that information and differences across those models. We've done a number of tests here. And again, as I said earlier, they seem to take the average of AIR and RMS. That's the best predictor that we can find in terms of looking at different combinations of these models. You might think they take all of the models and average them or do something with the variance in those models. The strongest estimate that we can find is this average between just 2 of them that insurers are used for pricing. Okay, so what gives? What's going on here? Because this is a large load on top of expected losses that consumers are paying. One theory that we had that could, maybe explain such large loads is profits. So insurers leveraging, very large market power here to generate profits. We don't think that's the case. I'll say a little more about that in a moment. Instead, we think these costs of managing these tail risks, preparing for these mega hurricanes, is the core thing that's driving costs in this setting and that consumers are paying for who live in these locations. So on the profitability piece, These rate filings also include information on insurers' profitability. Their pre-tax profits are around 10% of premiums in any given year. So there are these local insurance companies, which we call Florida domestic insurers, and then these diversified companies, that's where Allstate and State Farm and USAA fit. In both cases, they're earning 10 to 12% profits as a percent of premiums. So I'll leave that to you on whether that's a large number or not, but it's not sufficient to explain the loads that we're finding in the data. This figure is illustrating the relationship between insurers' premiums and reinsurance prices over time. So back to the bar graph I was showing you earlier per insurer. If we aggregate insurer and we do that over a full time series, you can see how premiums per policyholder in Florida have fluctuated, and that movement follows this global reinsurance cycle. As global reinsurance prices moves, it affects what homeowners in Florida pay for hurricane insurance. We have regression results to complement that figure. One other piece here is that this is an unusual market. It's dominated by a number of small insurance companies, as I noted earlier. Ari has written nicely about this. So the national insurers like Allstate and State Farm, they tend to dominate the lowest risk segments of this state. You can see on the left-hand side of this figure, 75% market share. They ration insurance in higher risk areas, and you can see Citizens, the state-run insurer, becomes increasingly important as the risks grow. And then there's these small local firms in the middle that help fill out insurance availability there. These local firms have more limited capacity to diversify risk and so end up relying more on reinsurance. And when we look at these local firms, we see a pass-through that's more like 1 to 5 instead of 1 to 4. Okay, so to conclude, how has growing hurricane risk affected home insurance premiums? We estimate that a $1 increase in risk increases premiums by about $4. Insurers are charging large growing loads above expected loss. We think these are due to the costs of managing tail risks, which are quite high. Frictional costs around managing these tail risks, we think of as this large effective tax on hurricane exposed homes. We focused on Florida, which is one of the hot spots for disaster risk in the world. Reinsurers have a more limited capacity to diversify that risk. So we think these tail risk costs are especially high where we're studying. Earthquake reinsurance costs are also high. They seem to be lower for wildfires, severe convective storms, hailstorms, and so on, but growing as those tail risks also grow. As we have record-breaking wildfires, hailstorms that are now competing with small hurricanes in terms of losses. We think the future may have more tail risk challenges for varieties of perils and across more parts of the US and the world. All right, thank you.
Thank you, Ben. While we load up the slides, the discussant is Laura Buckinson from University of Oregon.
Wonderful. Thank you so much. Tremendously enjoyed this paper. I think the biggest contribution is really this new data insight. There are some existing insurance data sets. All of them have some various limitations, but none of them really look at these in detail supply side costs among insurers. So really interesting to kind of, open the hood and see what's going on the insurance side. And then Florida provides a very useful an important case to put some real concrete numbers to what's going on. So really enjoyed that. I love their use of the regulatory filings. There's some connections, I think, with Judd's other work in wildfire, understanding how insurers price wildfire risk in California. While they don't observe the match, who's actually buying these insurance products, I think they're reasonably able to approximate kind of aggregate equilibrium moments across the market. As far as I can tell, carefully done with how they've done the regulatory filing reviews and also their connections with the CAT models. Overall, I would say it's more of a descriptive exercise. I mean that in a very positive note. This is a really interesting case. They generalize some stylized facts and can kind of evaluate some of the potential reasons why prices are so high in this area. So my comments will be kind of twofold. One is just wanting a bit more context and information. So I'll kind of highlight some of those. I think they already have it, but putting some of those pieces in the paper. But then I was really struck in reading it is what other questions could this really rich data set start to unpack perhaps? So a lot of my comments are in the latter. Hopefully that's satisfying for people. It's a bit of blue sky thinking, but I think there's really a lot more kind of in the next step. So future work too. So I think the first comment is they, punch opening sentence in their abstract. To what extent do rising homeowners insurance premiums reflect growing climate risk? And also the punchline that expected losses from hurricanes are per hurricane are expected to increase by 50% per property. This, as Ben showed, was kind of a minority of the rate increases, only about 25%. But I think this is still an important piece to unpack and explain a little bit more. We know hurricane losses are co-determined by the physical forces of the hurricanes and also rich human factors, exposure, vulnerabilities, etc. So I would love to see a bit more detail. I know they're kind of faithfully taking the cat models as given. That's what the insurers do. But it would be useful to have a little bit more context about what might be going in and changing in the cat models over this period. Put in context, here's some of Carrie Emanuel work, climate scientist at MIT, looking at the potential intensity of hurricanes in the North Atlantic over the last 120 years. And we see two striking periods, at least for modern history, one in the 1970s and 80s. So this is potential intensity. This is kind of the maximum that hurricane intensity they could potentially reach in the North Atlantic. And we see some trends. So a relative lull in the 1970s and 80s. This ended basically with Hurricane Katrina in 1992 when we entered this period of very intense increases in potential intensity. So we've certainly seen some changes in hurricane characteristics in the North Atlantic. Of interest, though, the kind of relatively flat dash line is Emanuel's contribution from global dynamics and global climatology. We see this as relatively limited. There's been a lot more regional variation here. So I'm very interested in part how these cat models are actually using both regional and global variation, and absolutely not recommending a climate attribution paper. I think there's a lot of challenges with those, but a little bit more context and nuance about how much of this is growing climate change. Obviously, there's some influence from that, but also just how these regional dynamics, but other pieces inside the cat model, how exposure and vulnerability modules within the cat models versus kind of changes in inputs or assumptions on the hurricane side, I think would be really useful to help the reader kind of wrestle with this significant 50%, even though it's dwarfed by the reinsurance costs, this important portion. I think I tend to, and they're very clear to not say this, but I worry that the lay reader might interpret this as a climate impact of 50%, which I think there's a lot more nuance going on. Counteract this, kind of the end of this figure with what we already saw. Ben did a great job of describing kind of the history of average annual losses across these climate models, especially the top two, AIR and RMS. Those are the two main players, of course. Relatively flat AALs until we get to that model revision. So I think there's a lot to unpack in there about what's going on, that it would be informative. And just, again, this is not a paper about climate change, but I feel like that's kind of a natural implication as well. Where might this be going? There's a lot of nuance here. It's not climatology related to hurricanes is not just as straightforward as increase in temperatures will immediately lead to stronger hurricanes. There's a lot of countervailing factors with wind shear, with middle and lower ocean temperatures that can moderate these features. So here's kind of a bit of a meta-analysis by climate scientists looking at tropical cyclone projections, assuming, in the near term, about a 2°C global warming. And we see for the North Atlantic, both in terms of intensity and also in terms of frequency of the most intense storms, which I realize I should have just zoomed in on the North Atlantic in retrospect now, but relatively limited, negative for overall frequency, slightly positive for frequency of category 4 and 5 storms, moderate intensity impact facts, the biggest signal is really in precipitation. Dev's point taken about we might be really wrong about precipitation, but that seems to be the strongest signal in kind of near-term direct climate impacts from hurricanes. So this would probably be future work, but it could be a useful kind of bound or bookend, like in the next 10, 20, 30 years, what might the climate signal within pricing? What might we expect? I think that could be an interesting question coming directly from the data that you have. I thought Ben did a fabulous job talking about really tail risk is a tremendous piece of this. They provide some really nice concrete numbers. I think the main and evaluate different channels. I think a lot of the theory and channels have been noted by previous literature. That's great. They're building on that as they mentioned. And again, the contribution here is really having concrete numbers in this Florida context, which I thought was really interesting. But, previous work by Dave Kelly and Mark Conti showing that the distribution, the hurricane damages have fat tails, right? Tail risk is a big story here, but it's really driven by the distribution of properties across space. The distributions of hurricane strength and in property losses at the individual level are thin-tailed. So this really is an aggregation struggle. I think that came really clearly in the talk. This really then drives a wedge between what the expected losses from a homeowner's perspective and then the cost to cover these losses. So reinsurance costs have been high in historical periods. So directly following Hurricane Andrew, Fruit has some findings. So they're 2 to 7 times expected damages. I think the current paper does a really good job of carefully motivating it with modern numbers. But also other work thinking about what goes into reinsurance costs and parsing out what's just natural to the tail risk versus what the market may be adding in extra premiums for risk premiums or correlation or ambiguity. So I'm really interested, is there anything more we can understand about insurer costs and how to more efficiently manage this tail risk, right? So I think we have some really nice comparative facts now, but kind of what's that next question thinking about managing. So thinking about, maybe some counterfactuals. What if Florida had a policy like California instituted in 2024 requiring more diversified national firms to have bigger presence in these high risk areas? It could go either way, I think. It could, they could bring in their kind of broader portfolio to manage that tail risk, but it could further strain it. As you're mentioning, there's a lot that they're trying to balance there. Or another counterfactual, which they kind of talk a little bit about in the paper, what if about their public reinsurance? So either, I know Ben has some great work about potential federal reinsurance programs, or what if the Florida Hurricane Catastrophe Fund, this kind of mid-level reinsurance, were expanded? What might cost implications and also market dynamics might we see from that in Florida? Litigation, their introduction mentioned they don't think litigation is a big piece of it. That I think the justification may have been missing in the draft that I got. So I know that they have more to say about this, but I'm really interested. I think they were saying they didn't think litigation was a big piece, but litigation is a big deal in Florida in particular. 10% of national homeowners claims, but more than 70% of homeowners suits filed. And about $5 billion paid in indemnity payouts for litigated claims just due to hurricanes in 2023. Compare that with a little more than 22 billion in premiums that were collected that year. But with that said, there's also been massive litigation, insurance law reform. And these litigations have been dropping tremendously. There's been some anecdotal evidence that premiums may be coming down. Again, they alluded to in their introduction that they have evidence. I'm tremendously interested if they don't find that litigation is really impacting insurance costs. I think that's a great story too, and interesting to kind of justify where these costs may be going. My point being, there may be more hurricane-related costs than are just in the regulatory rate filings that the insurers may have to kind of smooth in other types of numbers that they have. I'm curious what their thoughts are about that. Assessments also. This, I don't think, has been a major part of the historical model, historical pricing, but I'm curious to hear their thoughts and how the data may inform that. So as Ben mentioned, Pari has some great work looking at kind of possibly how the market got to this state, why nationally diversified firms have exited these high-risk areas and then more fragile insurers have entered. This then leads to insolvency in a subset of those firms. Who pays for this? Obviously, there may be some policy claims on top of whatever the insolvent firm's assets are, a variety of funds, but a lot of it is through assessments on remaining insurers. In Florida, I don't think this has been tremendously large in the time period that they're looking at, but one could potentially do some simulation or stress testing to think about if particularly bad years occurred, what assessments might look like and on already stressed balance sheets of existing insurers. You could also look at policies like California's Earthquake Authority. They're not an insurance authority themselves, but insuring firms can participate in the authority to help back undercovered high-risk areas to kind of an additional risk transfer mechanism. I'll also note this kind of stress testing is particularly relevant as Citizens has been actively trying to depopulate. Their high in 2023 was about 1.42 million policies. It was never meant to be a major insurer, kind of insurer of last resort. They've since depopulated to less than 400,000. So this has been a major risk transfer back to the private pool. So curious about how that may be, who's taking that up in their fragility. I will leave it at one more point. I thought Ben's point about how mitigation is actually being priced in Florida. There's a lot of pessimism surrounding the potential for insurers to price in mitigation. I've seen papers say it's non-contractable. Reasonably, there's things stacked against it. There's limited financial incentive given the one-year policies, costly for insurers potentially to verify and insure monitor. I think this is a fascinating counterexample of significant price reductions for really mitigated homes, and possibly a positive note for the future as more and more of the building stock, either through new building or retrofitting of damaged historic older building, kind of shifts into this more resilient stock. So I'll leave it at that. Like, really fascinating paper. Thank you.
Laura, Ben, you want to respond? And then please, if you have questions, line up.
Okay, thank you, Laura, for that really nice and thorough reading of the paper and those comments. You've given us a lot to think about. I'll just follow up on a couple of points that folks might be interested in here. So one is, I should have probably noted this a little clearer in the outset. These models are changing their estimates of the risk for reasons related to climate change potentially, but also for other reasons too. A new hurricane occurs. It updates the vision that like these types of properties we thought were more resilient than they were, maybe not, or the other way around. So I think, the point well taken that the changes in the model, could reflect a number of factors. And this litigation piece is one where we have some information, but we definitely need to include it in the paper. Thanks.
I think you did your analysis at the zip code level, and am I right that risk varies a lot within zip code? If so, is your analysis missing something, or is it really that the models might be missing something within zip code?
So the model vendors report to this commission in the state where they take the specific types of homes, there are a few types, and they locate them at the center of the zip code. So we can speak specifically to the model's estimates of risk at the centroid of those zip codes. And then the insurers are pricing risk for all properties that have the same characteristics. They offer the same price within the territory. So the models do allow for variation within the zip code. If you're a proprietary user of these models, we don't have the models, but we have this report that does give us variation across the state. So you can think about there is some variation within the zip code that could be priced, but insurers are using their territories. They're not pricing differences within their territory. Yeah, thank you.
Yeah, so I have a question that boils down to how much heterogeneity spatially is there in reinsurance costs? Like, it feels like there should be, to the extent, like take the Miami example, for instance, like insuring a property in Miami is really expensive because that loss is going to be correlated with other properties in Miami. And there's a lot of them worth a lot of money. And that's sort of a thing that's really hard to reinsure. Whereas if I think about a property somewhere in the middle of the coast, St. Augustine or someplace like that, where like bad for St. Augustine, but that's going to be like single-digit billions of dollars, which seems like something a decent-sized insurer should be able to handle. Does that logic make sense? And then and if yes, do you see variance in the reinsurance costs that follows that pattern?
Yeah, great question. And in the paper, we do show on maps, variation in insurance costs. And I think the intuition that you're communicating is if we think about a place like Miami, it's high in hurricane risk and a bunch of people live there. And that should add to the tail risk more than a less populated part of the state. And that aligns with our tuition. I think that's a great direction where we could do a little more with that in the paper. Yeah, thanks. Meredith?
Really cool paper. Two quick questions. One, building on Laura's comments and your response in terms of what we're learning from these model updates. We're learning something about how the climate's changing. We're also learning that our models have been pretty crappy and we keep updating them. And I'm just curious, ambiguity aversion to Ryan's point, when you see in some areas, the model updates keep telling you it's higher and higher and higher, can you do more to unpack what we might be learning, not only about climate change, but our ability to model it and the extent to which there's real ambiguity in some areas? And then secondly, building on Hunt's question, it won't surprise Judd to know, I'm just curious about how you're thinking about territories for the state farms of the world. So you've got this really cool distinction between the diversified nationals and the Florida-based. Are the diversified nationals, is their secret sauce more granular? And if so, can you capture that in those models? When you say you're using the territories used by firms, are they sub-zip code level? If not, if they're selecting the lower risk in that territory, what does that imply for estimates?
Thanks, Meredith. I'll try to remember all of that. I'll start with the second, which was that State Farm is doing something similar to what they do in California with this really granular. They are in the minority here. The other insurers tend to be using territories that are bigger than the zip codes. And so we don't see a clear distinction that the national players are doing something really different than the local guys, with the exception of State Farm, maybe one other insurer. I totally forgot the first question. I'm sorry. Oh, yeah. Yeah, one thing we could do more, I think, in the paper, and always do more, of course, but is sort of push on this idea of how they are changing in specific locations where we think it may be especially hard. So one way to think about ambiguity is differences between the models might point toward this is a spot where it's really hard to estimate the risk. And one thing we haven't done that I think is kind of interesting now that you're raising it is look at even within a model, have their estimates of that spot changed more than in other areas. I think that's great. Yeah.
Hey. My understanding of reinsurance markets, which I got from ChatGPT half an hour ago, is that it's all about the tail risk, right? The insurers will hold on to the first X million dollar, $100 million of damages and then insure against the rest. So how much you showed us this really nice graph of how the components of the cost change over time, including the reinsurance costs.
Yeah.
So how much of that and you told us you had a regression in mind, but didn't show that to us, which I also appreciate. Thanks for that. Can you tell us how much of that 4-to-1 markup comes from the tail risk and how much of the 4-to-1 markup comes from the regular stuff that they don't need to pass on and isn't tail risk?
That's a great question. I don't know if we can differentiate the individual markups. So, we have this geographically granular information on expected losses and on premiums. We don't have geographically granular information on reinsurance. Reinsurance is done on the book because we're insuring the book of business instead of locations. So I think maybe there's more we can do across time, but I think within location, I'm not sure how far we can get down that road. One thing to add on to ChatGPT in terms of the setting with reinsurance is that we think about these global firms as ones that are in better positions than anyone else to diversify this risk, but there are still these hotspots on the map. And again, they're Florida hurricane, they're Bay Area earthquake, there's Japan earthquake. There's a few risks that these reinsurers would say we're just at capacity. Any more of this risk, we just have to manage through larger and larger capital reserves. And so that's part of what makes it so expensive to cover here. The pooling benefits of reinsurance is just limited in this space.
Really interesting paper. I just had two quick question points. The first was, I think on your first graph you showed of the components of the premium, I don't think I saw citizens in that graph. And it'd be really interesting to understand what goes into the citizen premium because they do have really different methods of dealing with risk and also cost of capital in the sense that, they are actively depopulating. They, make insurance holders also buy secondary insurance. They will not cover flood, and you have to buy flood insurance separately if you have a citizen's policy, even if you live in a 50th floor condo or something like that. And then also they require insurance holders to agree to a nebulous potentiality of paying 30% of your annual premium in any year if there is a catastrophic event anywhere in the state. So that's kind of getting at that cost of capital expenditures. And so it'd be interesting to see that breakdown and compare it against the private insurers. And then secondarily, I really echo Laura's point about the litigation. I think that's a really important part and could be really interesting. You seem to have an opportunity to really dig into that because the 2023 law change took away in large part the ability for these one-way attorneys fees, which were really driving up litigation costs to insurance companies, and they left the state because of that. That's what people say.
Yes.
So it'd be interesting. I can just tell you colloquially, as someone who has had a citizens policy for 4 years, I never had an outside option until this year, and now I have 4. So just like, I think there are some dynamics going on there, and I think customers are feeling them. Thank you.
Great, thank you. Great comments. So on Citizen, echo your interest in having it as part of the breakdown here. Citizens reporting is kind of strange. They ask, the regulator asks citizens to say, okay, if you bought out a full reinsurance tower up to a 99 percentile, what would it have cost? So there's this hypothetical exercise that Citizens goes through that's different than the private insurers, and that's like sort of prevented us from putting it side by side because it's not quite an apples comparison. Citizens' expected losses are larger at the portfolio level than the other insurers, which is consistent with it being the insurer of last resort and sitting in the farthest risk of the tail. Writing about this litigation suggests that it is a very big deal to reinsurers and insurers, and we don't mean to hand wave against that. And I think it's a great idea to look at 2023, and maybe we can do more there in this paper or another paper. We think that it's relevant. It's but we're kind of focused on this larger trend between risk and premiums, and so haven't delved into that as much as maybe we could. Yeah.
I was really struck by how few models are actually used, and I was wondering if we should think about that as like a market where these models are competing against one another, and they should be, trying to improve on how well they measure risk. Like one anecdote I've heard is that these models aren't very good at accounting for like nature-based mitigations. You had some community mangrove restoration that just wouldn't be accounted for. And like, what are the consequences of this if it's kind of a concentrated market?
Yeah, so we had a similar set of questions. Our priors were that insurers would be using more information from these models than they appear to. And these model vendors report to this commission. It's a really intensive process, hundreds of page documents. And so one question for us was, why are they even bothering if everyone's just using these 2 models? My best sense of this is that insurers and reinsurers want to use the same models because it facilitates sort of pass-through of reinsurance costs to align with the premiums that insurers are using. And so if they're using the same information, it helps them communicate with each other and agree on pricing in a way that may be more complicated if they're using different models. I think there's a lot of interesting questions that we don't know yet about the advantages of different models, if they're more valuable for certain market segments or certain types of properties, how they incorporate other information like nature-based solutions. So thank you. All right.
Really super cool paper, great discussion as well. So I have 2 questions. The first is, I was surprised that the pass-through of the domestics was higher than the nationals. And I understand your argument, and I'm sympathetic to it, that they have higher capital costs, and so they have to kind of have a higher pass-through. But I'm also a bit skeptical of that because these insurers are not necessarily the ones that care about being around in a tail risk event. They're perfectly happy to go insolvent, right, in Florida. And like 20% of them do. So I guess I was just kind of curious about how you guys thought about that high pass through, and kind of relatedly, they also have, in the combined ratios, they have higher expenses. And a lot of that is driven by their use of sort of third-party claims processors. So there may be some kind of other costs that are being reflected there. And my second comment, which I know you're 100% not going to do, but I'm going to say it anyway, is to kind of think about the markups question. You may want to look at the stock prices of the publicly traded companies and how that changes with the model update. Because if this is really about tail risks, the stock price should decline. And if it's really about markups, it should go up. So there's kind of an implication there that could be tested.
Okay, thanks, Pari. I'm a little intimidated to get into a discussion about the small insurers with Pari in a big room because she knows so much about these. We think about sort of two forces here. One, these smaller insurers, as Pari's other work notes, like are not necessarily as well capitalized as these national insurers. That makes them more fragile. And for the reinsurance they do buy, it's likely much more expensive because of the kind of clients they're taking on and their own footprint in terms of ability to diversify. And there's sort of two forces there that are pushing against each other that makes the empirics ambiguous, I guess, on how that would play out. Maybe we can figure out how to look at asset price data. I don't know. Yeah, that seems like a good idea. Yeah. Sir, I agree that they are not that upset about going bankrupt, but I'm on my.
These guys do buy a lot of reinsurance, and we interpret that as basically that they face some amount of regulatory pressure to have some degree of solvency. And so they're certainly spending a lot of money to protect the tail because they have to. And one of the things you see in the sort of time series of pass-throughs is that the pass-throughs are going up especially fast for the domestics. And one of many possible interpretations for that is that recently they are facing more pressure to at least look like they're trying to cover the tail. While I have totally stolen the mic from my co-author, I want to respond to Hunt and Meredith also. All the asymmetric risk classification stuff that we see happening in California, it's also happening here in Florida. The different territories, the sophistication of the rating very much aligns with the California story. It's sort of overwhelmed in the numbers by just the scale of the tail risk cost in Florida. So it gets a little bit drowned out by the amount of money that these guys are spending to cover the tail specifically. But intellectually, the story is consistent and there.
Sorry, Ben.
No problem. And thinking about kind of what could explain that increase in the reinsurance costs over time, in addition to tail risk, how much of that do you think is simply just like the rise of global interest rates and the cost of capital, which is a huge component of a reinsurer's balance sheet? And then second, how much of this should I think of it as this is an insurer trying to get things right or cat model year to year based on ENSO patterns or like multi-decadal or, these kind of oceanic processes that could affect the realization of hurricanes in a given year versus this is them trying to get right the kind of future horizon in terms of how they can pass through that risk of pricing.
Great. So on the reinsurance cycle, I think there are a number of factors here that are contributing to that, and including that and exposure growth in this state. More homes in Florida are going to add to these tail risks as well. So I think that there's a number of factors there that we don't get into in detail in terms of what's driving up reinsurance costs overall. In terms of the second point that you raised, will you tell me again? Right. I think these insurers are trying to provide relatively stable pricing. And so these model estimates don't look like they're jumping around during El Nino years. They're focused on a 1-year period largely. They have other versions where if you want to know something about the longer term, they can provide that. But this industry is really interested in, we're taking on this property risk this year. What's the property risk over the next 12 months in a context where they want sort of stable pricing? If prices are jumping around, you have new rate filings and things like that you have to go through. So there's not very dynamic beyond sort of longer term trends over the kind of 17-year period that we have. Yeah, thanks.
So great paper. I want to pick on one line on your conclusion slide where you describe this as a large effective tax. And I think of taxes as distortions, market failures. And it's a little unclear whether that's the case here. It seems like you're saying this isn't a big markup at the insurer level. Then that sort of pushes it up one stage. What's going on at why is reinsurance so expensive? If it's market power for insurers, okay, that's market failure. If it's just like insuring tail risk is just fun, like it's genuinely very costly to cover tail risk, even for the reinsurers, then this may be socially optimal to have the price be way above. The true cost of this, the cost of the risk is way more than the expected value. If that's the case, there's no distortion. And my impression from a lot of the discussion is we're at least closer to that second case where it's just genuinely really expensive risk. And so the point is not there's a big tax, it's the cost of a risky thing is a lot more than the expected value. I would encourage you to be a little cautious with the language, particularly because this matters a lot for policy. That if we want to, if it's a market failure, we want to intervene. If this is correctly pricing risk, maybe we don't. So thanks.
Thank you. And thanks for that comment, and very welcome for some pushback on this point. So how much time do we have? I think some of this could come sort of in the coffee break discussion. There's a literature about this, as Laura indicated, that information frictions, for example, limit reinsurers from raising equity in real time, and the frictional costs in this industry seem to be passed on through higher reinsurance rates to consumers. So if we could reduce those frictional costs, we could potentially make insurance cheaper. And this might help people live out their preferences of living in Miami. And that's a provocative thing to sort of say, that reducing these costs could lead more people to live there. So I'll leave it at that, and come grab me after in the coffee break. Yeah.
I was just curious as to what these companies are allowed to do with the capital reserves that they're holding. Are they allowed to invest that in the stock market and make lots of returns from it? And does that create an extra incentive beyond current profits to hold that money and drive up the premiums? And I guess we could get at that with the stock price question that you were asking earlier. And has that changed over time? So are they allowed to do things now that they weren't in the past with that money?
So when you give your premium dollars to an insurer, they take those and they invest them in typically a pretty safe account, like a diversified holding of bonds, because they know they may have to pay those, and they earn some return on that. And that allows them to offer premiums at a little lower rate than if they had to sit in a non-returning account. And then that's regulated just like sort of the liabilities of these firms are regulated here as well. And maybe this is something we can talk about more offline. Yeah.
All right, perfectly on time. Thanks again to the speakers and discussants. And we have a half-hour break. We'll come back at 11:20.
Sorry about that. Sorry, Dan. I talked to you. I just love Charles.
All right. We're gonna have one more talk before lunch, so related about agriculture. Wenbong, take it away, please.
Thank you so much for introducing me, and also thank you for having me here. So this is a joint work with my wonderful co-authors at Peking University and Jinan University, and it is a paper about environmental policy. So we usually judge environmental policy based on the problem that it was designed to solve: lower pollution, lower emission, less pollution, or cleaner air. But it is the right place to start, but not always to be the place to stop. So today I want to ask what happens next when environmental policy quietly reshape the ecosystems. What will happen? So let me start with a simple fact that motivated the paper. So every harvest creates a problem. It is that, after the grain is removed, the straw remains in the field. And the easiest way to dispose of it is to burn it. It's fast, cheap, and also highly polluting. So to improve air qualities, government banned straw burning. And, following that, we have the air conditions to be cleaner, but we also have the straw just remain in the field. So it is a policy not only act on the air, but it's actually act and change the ecology in the field. So the question here I want to ask is, when environmental policy removed one health hazard, whether the ecological changes it leaves behind can create another. So let's look at this simple graph here. And when we're thinking about straw burning ban policies, we usually think about the intended pathway it already here, which is the fire reduced, the air become cleaner, and we have fewer respiratory and cardiovascular disease. So it has already been revealed and established in many good articles, and also it is a real effect. But there is a second pathway here, is when the fires was reduced, there will be less straw being burned, and also there will be accumulation of those residues, which can some kind of alter the moisture, temperature, and shelter in the surface of the soil. And these are the conditions that favor the reproduction and survival of the insects, ticks. And these are not only minor ecological details, they are actually exactly the kind of environmental part through which those kind of disease vectors can survive, can reproduce, and then come into connected to people. And we observed some kind of another health pathway, which is through ecological changes. So the thing that I want to explore here is about, whether this kind of second health pathway, which is always mostly overlooked, really matter for how the policy is evaluated and automatically how the policy is designed. So the empirical setting that we use is the top-down, is a staggered rollout of the straw burning ban policy in China. And the left-hand graph shows where the ban was adopted. You can find that it started from Beijing and later expanded to the province capitals and then spanned across the countries. And the right graph shows that, how the counties adopted this policy over time and how it expand over time. So a quite important thing here to support the identification is that the timing of the adoption follows those kind of top-down administrative hierarchies instead of related to all those kind of health infrastructures or the pre-ban disease trend or ecological changes. And one important thing is that this ban was enforced with some kind of explicit assessment and punishment systems. And it was monitored by satellite monitors, and it's really changed the thing. And this kind of staggered rollout, it provided this spatial and temporal variations that support our difference in difference design. So before I show you all those kind of empirical details, I want to just provide enough biology information and backgrounds. So residues is it's not waste in the land. It's actually a kind of organic materials that is important for one kind of species called arthropods. They include insect, ticks, and mice, and they are quite important and necessary part in the ecosystem. And many of them support pollination, decomposition, and also nutrient cycling. And they live and produce in those kind of crop residues. And one thing that is important and I want to emphasize is that arthropods, it already existed there, and there are some good things, necessary things. The severe part is that a small subset of it can transmit those kind of pathogens and called vectors. And the kind of disease it causes vector-borne disease. It usually transmitted by bites or alternative forms of exposures. And the kind of disease including infections, poisoning, allergies, and so on. And in our data, it is identified using ICD-10 code. So this is actually a broad category. It is not a small one. About 17% of the infectious disease globally is vector-borne disease. And each year, it causes about 700,000 deaths worldwide. So it's non-trivial. And among these vector-borne disease, there is one severe subset called tick-borne disease. I think some of us may heard about it from media news or real-life cases. So it is actually clinically severe and can cause death. So this kind of vector-borne disease and tick-borne disease is not just the minor bites or skin irritations. It can be life-threatening and it can require hospitalization and inpatient care. So within the tick-borne disease, there are Lyme disease or SFTS, which still have a lot of the hospital and medical problems within it. So I think you have already know that this is a significant issue. It can significantly affect the public health. So we need to look through how these kind of things can affect our human health through these kind of ecological changes. And we need to observe each link before we really clarify that it is some kind of changes happened following the environmental policy. So these are the data that support us to observe each link and justify the causality here. So the health outcome come from the nationwide inpatient records from 2015 to 2022, and it includes ICD-10 code diagnosis, spending, and also patient characteristics. The fire measures come from MODIS, agricultural fire detections, and burned area products. We further overlay this fire product with the land cover product to identify agricultural fire. And the exposure measurement comes from Baidu search index for bias and defensive behaviors. And we also have these GBIF observation records about the arthropod populations and also all those kind of other species observations. So the mitigation measure we used here is nationwide straw recycling machine procurement records. And overall, we have a hospital sample which include about 2,788 Tier 2, Tier 3 hospitals and cover about 21% of the nation total. So we further aggregate into county quarter level. And now let's look at the empirical settings in this paper. So as what I mentioned, the policy is rolled out in a staggered pattern. So that's why in our estimation here, we also use a staggered DID design following the Bursiak and co-authors paper in 2024. And in this specification, we have the county fixed effect to observe those kind of geographic characteristics, and also have the year quarter fixed effect to capture those nationwide shocks, as well as province quarter fixed effect to really capture those kind of provincial seasonalities for agricultural production and ecological changes. So the outcomes we are really interested in, including the hospitalization and inpatient spendings for vector-borne disease, tick-borne disease, and some other related or unrelated categories, as well as all those intermediary mechanisms and outcomes we would like to clarify to show you the whole ecological pathways. And the standard errors are clustered in county level. And for this kind of staggered difference in difference design, it actually rests on several identification conditions listed here, including parallel pre-trend, and also no disease-driven policy timing, no differential healthcare reporting shift, as well as no concurrent policy rollout in the same pattern. So we examined all these kind of conditions using tests, examining the determinants of the policy, the time rollout, the rollouts of the policy, as well inventory studies and placebo test. So all these tests and the results are links here. So I will go directly to the heart of this paper and show you what happened to the health outcomes. So following the ban, we observed that the hospitalization of vector-borne disease increased by about 1.5 per 100,000 population. So if we relative it to the pre-ban mean, it is about almost 38% increase. So it has really significant amount. And if we look at the inpatient spendings, it's about a 37% increase. So the PBML estimates also shows that the increase is about 27% for both terms. For different functional forms, their magnitude can be varied a little bit, but the conclusion is quite stable, which is that following the ban, actually this kind of negative ecological health outcome is non-trivial, significant, as really matters. And when we're thinking about the tick-borne subset, as what I mentioned, it is a severe subset. So you can find that the increase is about 58% following the ban for hospitalization of the tick-borne disease, and about 80% increase for inpatient spending. So they are life-threatening categories, and it's really increased a lot. People died from it, and we should care about it. So following observing all this kind of average effect, I want to show you how the things involved following the ban and what the dynamics are. So these two graphs show you that pre the ban, there is no systematic differential in the trend, but following the ban, in the first 2 quarters, actually it's only modest effect. But after the first quarters, it will have a persistent and high increase in both vector-borne disease and tick-borne disease, for about 5 to 6 quarters. So it really shows us about the ecological changes because, after the fires fail, the ecological conditions changes, and then the vectors amplified, and then those kind of negative health outcomes shows up. And also, this kind of circle is reflect the life circle of those vectors and the active period of them. So it just tells us that following the ban, some kind of ecological changes emerged, and it gives us some kind of negative health outcomes there. So we observed these kind of health outcomes, but now let me show you some of the intermediary mechanisms here. And the very first stage is that following the ban, whether the burning behaviors really changed. So using satellite data, we observed that following the ban, the cropland detections decreased by about 66%, and the burned areas shrinked about 70%. So you can observe that from these 2 graphs, following the ban, immediately the burning behaviors reduced and the burning areas shrinked. So it actually tells us about two things. First, the policy worked, right? So the fire reduced by 2/3. And also, it is a quite large ecological changes following the ban because, without fire, then there will be accumulation of residues and there will be ecological changes in those fields. So the next stage is about whether there's truly this kind of increase in vector activities and people's responses to those kind of vector amplifications. So we try to use two kind of data sources to support this part of the evidence. The first one is a city-level search index about insect bites and treatment and pest control from Baidu Index. And we show that actually following the ban, the search for insect bites increased by 25%, and the search for the treatment and pest control increased by about 18%. And further, we look at what happened in those GBIF observation data about the anthropos population, insects population, and we find that anthropos observations increased about 3%, and insect observations increased by 2.6%. So we know that this kind of observation data is actually sparse, noisier, and also depends highly on those kind of observation efforts and where and when you observe it. Even though we controlled all those kind of observation effort, we still treat this part as a suggestive evidence. But overall, you can find that these two pieces of evidence, they point to the same direction, show us that more vectors are actively exist in the environment, and also there are increased exposures to those kind of actors, as well as awareness, behavioral responses, and reactions. So the next part, is we know that the whole mechanism is that it creates some kind of warmth, moisture, and shelter for them. So apparently, for those kind of conditions with higher temperature, more precipitation, it should have vectors survivals more. So we first look at this kind of heterogeneity analysis by looking at the two dimensions environmental condition. The first is temperature. So for those counties with the coldest months, freezing, you can find that there are quite limited hospitalization increase in vector-borne disease. But for those places with the coldest months temperature larger than 0, following the straw burning ban, the hospitalization increased by 2.2 per 100,000 population. So for the dimension of the precipitation, the same thing happened. So for those areas with precipitation larger than 800 millimeters, which is some benchmark we get from the scientific papers about what kind of condition favors the production of those vectors, it is actually showed a significant result about 1.6 increase in vector-borne disease. So overall, it is actually tell us that for those warm places, wet places, it is actually where the hospitalization of the vector-borne disease, this kind of negative ecological cost will concentrated at. So the next part is we know where they are. We need to know who bear the cost. So this is the piece of evidence about who will bear this kind of ecological cost here. And you can find that for those residents with rural insurance, they actually have the vector-borne disease increased about 1.8 times larger than those urban insurance employees. And this kind of hospitalization effect also concentrated in those places with high cropland, and all these kinds of heterogeneity patterns just to tell us one thing, the cost is actually disproportionately falls to those populations and areas closely connected to agricultural protection. In China, this population and those areas are mostly disadvantaged group and poor areas. So one thing that we observed is that increase in air quality, it is shared by all of us. But this kind of ecological burden, it was actually taken by this group closely connected to agriculture. So the next part, we want to show you what is the aggregate cost are. So by scaling the treatment and also taking account of the coverage, we find that this kind of negative ecological cost, it will add to about $108 million in patient spending per year. And to compare it with the benefit we can get from the air pollution reduction, we actually use the same data within the same design to look at the benefit from the respiratory and cardiovascular disease. And we found that this kind of negative ecological cost is actually offset about 6% of the inpatient spending savings we can get from respiratory and cardiovascular disease. And one thing that I want to emphasize here is that it is still a lower bound, because for both sides, we actually exclude mortality, exclude outpatient cost, and also exclude all those kind of defensive investment or productivity loss. And one thing I want to say that the conclusion here is not the ban is a mistake. We have already found that it benefits a lot. It has a lot of savings in inpatient gains for all those kinds of disease related to pollution. It is that some of these good gains will be offset if the policy design left the ecological cost on the table. So why? How to solve the problem? How to take account of all these kind of ecological cost? So it comes to the thing is that, because it started from those kind of residues accumulated in the land. So let's do this kind of residue management. But it is a really challenging problem for the farmers, because thinking about the whole condition here, the farmers are not allowed to burn anymore, and they have to think about how to deal with those kind of accumulation of residues. And if you want to recycle it or reuse it, you need some kind of machinery, transportation, additional labor cost, and also access to a buyer. So it is so easy for those kind of smallholder farmers that the private returns of straw recycling is much lower than its cost. So to close the gap, there is one policy further introduced here. It is in 2016, the central government targeted 10 provinces with more than 1 billion Chinese yuan in straw recycling support. And following this kind of support, we can find that for those areas, provinces with support, the procurement of those machineries for straw recycling is about 2.1 times larger than the other areas. So it's really increased the potential method we can use to recycle the straw and make it more affordable for the farmers to choose alternative options. And the next piece is whether this kind of recycling truly attenuated the ecological cost. So we conducted this heterogeneity analysis about those areas with the support or without the support. And we find that for those places without the support, the hospitalization is increased by 2.3 per 100,000 population, while for those with subsidies, it is only about 0.5. So it is about 77% reductions in those kind of ecological costs. And I have to admit that the placement of those kind of support is non-random. But when you're thinking about it, they are applied to those most cropland intensive areas. The cut here is that it's already work well in those places with the highest health cost. Then the residue management, if it is fully applied, it can reduce even more than that amount, right? So the conclusion is still informative, and we need to support the straw recycling. So now let me conclude the whole paper. First, we have already observed this kind of huge ecological cost is non-trivial. It is overlooked before, but it should not be overlooked. And the good thing, the fortunate thing is that it is not inevitable. So we need to pair the burning with residual management. So the broader takeaway I want to convey here is that when we try to think about environmental policies, it's actually not only change the thing that it intended to change, it's actually change a whole system. And following that kind of change, or following that kind of control, it's really the thing that replace it matters. And we need to think about how the whole system's changed to evaluate and design the policy. And for this specific case about ecological changes, we need to control pollution. We also need to benefit all by reverse those kinds of bad ecological changes. So let's design for both. So thank you so much for your listening. And that's pretty much about the project. And I'm really looking forward for Al's comments and discussion. Thank you.
Thank you. So A.L. Frank from University of Chicago is the discussant.
All right, thank you very much. I very much enjoyed reading the paper and I learned a lot. I think you did a great job describing and walking us through the paper, but there were multiple moving parts. So let me just offer a brief recap. There's a problem where farmers in China are burning their crop residue at the end of the growing season. That compounds air pollution concerns. In response, local governments are placing these bans on the burning of crop residue. The problem is, if you don't burn the crop residue and don't do anything else with it, you're providing these very suitable habitats for a bunch of different insects and ticks, and that leads to an increase in vector-borne and tick-borne diseases. These local increases in morbidity offset some of the local gains from the reductions in air pollutions, but it doesn't have to be that way. The government seems to be able to quite effectively subsidize these technologies of recycling the crop residue. This issue of burning crop residue is very prevalent across these agricultural landscapes in Southeast Asia. And there's nice theoretical work in this economics of crop burning in the annual reviews, where there's like the structural transformation, shifting the scarcity away from land to labor, creates these like larger incidents of crop residue burning. There's recent empirical evidence that also documents how these larger rural-urban migration patterns are contributing to larger patterns of crop burning. And there are some mixed results when governments try to ban these practices. Sometimes they work really well, sometimes there's a lot of non-compliance. We know from a different setting in India that you can potentially pay farmers to not burn their crop residue, but you also have to sometimes pay them upfront, at least in part, to build trust and to alleviate some liquidity constraints. In China right now, the policy discourse is about maybe backing away from a complete ban on residue burning, just because there's this realization that you might have to live with a little bit of allowing some level of crop burning. And there's like very active debates about what is the correct allowance for those like prescribed burns. When did a great job of like explaining that these changes to agricultural landscapes bring about these changes also to microhabitats. So we often pay a lot of attention to like large-scale habitats and biomes, but these smaller-scale ecosystems can be also tremendously important, similar to how we sometimes think about climate as a whole, which is not the same as maybe more local microclimates that we know can be affected by land use changes, either through deforestation or reforestation. What I absolutely love about this paper is that it's able to tackle and demonstrate these links between policy affecting landscape features, which then give rise to these microhabitats, and those microhabitats in turn have an impact on human well-being. I think this is also broadly important against the backdrop of what some of us might have heard about the insect apocalypse. Now, I know some people, including some of my colleagues, hear about the insect apocalypse and their eyes light up with excitement, considering that's a good thing. I won't name names, you know who you are. But I want just to clarify that it is not the case that these declines in the abundance of insects are experienced uniformly. It is just our luck that we're losing out on the beneficial species like bees, while more harmful species like mosquitoes are thriving and winning and undoing a lot of like the gains in the battles we've had with vector-borne diseases in recent years. The last point I want to make about insects is like it's sometimes hard to grasp just like how volatile their population levels can be. And that's because they have very high intrinsic growth rates. So that means that, for example, locusts will multiply by a factor of 20 during an outbreak every 2 months. During an outbreak in the US, spongy moths will experience outbreaks that are like 5 orders of magnitude greater than non-outbreak years. A very recent localized example comes from this medical center in Texas, where they decided they don't want birds in the trees because they were worried about avian flu. So they were like, let's just put up nets. But with those nets and without the birds, they weren't eating the caterpillars, and the caterpillar population skyrocketed by over 7,000%. All of this is to say that when environmental conditions change, we're measuring changes in insect populations by orders of magnitude, okay? Not by a 2-3% change. They're highly responsive. Insect populations are usually controlled either by biological pest control or by just suitability of their habitat. And what this paper talks about is that when we ban crop residue burning, we're massively changing the local suitability for some of these insects and ticks. My set of 3 comments are going to focus on maybe there's more to tell us about who is being exposed in the paper. So the paper does document that most of these effects are driven in rural areas with more agricultural cultivation, which makes sense. There's some suggestive evidence there that's being interpreted as maybe the channel of exposure is on-farm labor. There's some heterogeneity analysis in the appendix that looks at effects for below and above 60, finds very similar effects across those 2 groups of population. It is true that in China, it's not entirely uncommon for people to still be working on their farms even after 60, especially in kind of like small scale rural households. But I wonder if there's any other variation that can be used to maybe tease apart who is actually getting exposed here. Maybe something about the distance from the cropland areas to the residential areas, or maybe a county that's untreated but has a residential area adjacent to the border of a treated county. Maybe we can learn maybe about these effects being more pervasive than just the local on-farm exposure, or maybe the correct split isn't at 60, but maybe we want to look at children. Are they similarly affected if we think that they're not participating in farm labor? The next set of comments I have is a bit more about aligning the dynamics and clarifying them across the paper. So the paper defines treatment as the first full quarter that the ban is in effect. That doesn't necessarily have to be the first quarter in which the burning might be happening. It might not be the crop burning season. So maybe recentering around the first quarter where the policy is biting and there's potential residue burning that can occur might help with explaining why there's a delay of like 2-3 quarters happening there. And when pointed out, there's just like some population life cycles that are happening with mosquitoes or other insects, but that kind of like a curtailment at the end doesn't show up with the tick-borne diseases. So I wonder if there's also like potentially explanations about what's different about those 2 types of vectors that might be interesting. There's also the comparison between what's happening to morbidity and what's happening to the cropland fires themselves. So when the temporal resolution for the morbidity analysis is at the quarter level, but the cropland fire frequency is at the annual level. And then when in the first figure on the left, we're looking at about like 9 quarters of data. And then we're seeing that the biggest effects on the reductions of the burning actually happen after 2 years and more of the policy. So I'm incredibly interested to know what exactly is happening to morbidity 9 to 24 quarters after treatment when we're seeing a bigger effect of the policy. And also potentially, why not just do the analysis at the same temporal resolution? You can aggregate the MODIS fire data at the quarterly level. I think this is important as well because the analysis that uses the GBIF records on abundance of insects may be a little hard to see from where you are, but that too is at the annual level. And effects there are showing that the observations of all those different insects and ticks show up about 5 years after the treatment. Now, the paper doesn't rely too much on this, and I want to be entirely clear here. Every time that you have data on wildlife populations over time, that is not a small miracle. So it's really hard to squeeze a lot of information from that. But it just makes it hard to think about what am I learning about the mechanism underlying the increase in morbidity when the GBAF records are at an annual level, and I only see the morbidity for a 2-year span after the treatment, but the increases in the records come after about 5 years. So just again, aligning everything more, sort of like everything is measured and analyzed in the same time span in the same resolution, I think will help clarify a lot about what's happening in the paper. My last comment is closing with the policy of subsidizing the recycling of a crop residue. That really cool heterogeneity analysis, which makes a lot of sense. Warmer winters mean that more insects survive the winter. Moist conditions are really important in those microhabitats. Is it that the rollout of the policy, the targeting of the policy, also follows along these dimensions of heterogeneity? And is adoption also happening where it's most beneficial along these same dimensions? And I have a few more comments that I will definitely not go over, but I wanted them to not get lost. And thank you very much. I think this is a really thought-provoking paper. Thank you.
Uriel, you want to respond and then again line up if you have comments.
Okay, so I want to respond a little bit about Al's quite nice and valuable comments about the paper. So first about the, we can explore the, more heterogeneities about distance to the cropland areas and also explore more variations about different age groups, especially about the children and the elders, and also about, maybe people with different occupations, specifically farmers versus, those kind of urban employees instead of just using insurance. And also, thank you for your great suggestion about, and also comments about the whole streamline about the different dynamics. I think it's important here. One thing that I want to explain about the cropland fire part is that actually for the cropland fire measurement, we used is harvest seasons measurement. So that's why in the paper it is showed in yearly base. But definitely we can look at the quarterly level and also think about, whether they can be put into the same dynamics unit and also look at the changes in all those mechanisms. And we will further look at the long-term effect for those kind of 9 to 24 quarters, and also thinking about, I think for the cold moisture places and whether it is correlated with the policy rollout, I would like to answer that it is not, because actually the policies are top-down. So when it first, be implemented in Beijing, the capital, it can be expanded to the north and to the south. So those kind of cold or warm or moisture or drier places, they are actually mostly evenly distributed across time. Yeah, but thank you so much for all these kind of great suggestions. And also, I really appreciate that you raised the point about how those kind of insects and anthropods populations can be amplified. Yeah, so it's really, help make our whole framework more fruitful. Thank you. Yeah, I would like to take more questions. Yeah.
Yeah, very interesting paper. I wonder if you could tell us more about how you model the pollution impacts, especially considering that in India, most of the pollution is happening in rural areas, but that pollution is traveling really far and can affect some potential outcomes in urban areas. So perhaps you can tell us more about that. And also, it might be worth looking at Brazil. Brazil had a very successful program to ban fires from sugarcane, mainly because some of the capital adoption technology was really easy to implement among farmers. So you may be able to find some interesting similarities to this context.
Thank you so much, Diana. And I appreciate your point about the air pollution part. Actually, we have one piece of evidence about following the straw burning ban, how the air pollution was changed and how it was distributed. So I can, show you more after this talk. Yeah, and also for the Brazil, similar straw burning, project, I will further look at it and thinking about the capital investment. I think it's a kind of different support compared to the subsidy provided by the Chinese government, but it's worth to further explore the alternative options. Yeah, thank you. Yeah.
Sure. So I just had a question. The mechanism that you emphasize in the paper is that there's more crop residue on the ground and that's serving as habitat for pests, which I completely believe. But I can imagine other channels as well that might invite other policy interventions. For example, when you change the ability to burn, you change the cost structure of farming. So you might see different crops being planted or in different locations, which might provide different habitat for pests, or you might see different input use. For example, lower pesticide use if you're cutting costs in other areas, which also might influence the prevalence of pests. So I'm wondering if you're able to explore any of those channels, because again, they might have different policy interventions associated with them.
Thank you so much, Hannah. And I think, you raised a quite nice point about the pesticide and also, the changes of different kind of crops. For the pesticide side, I think there is already one paper investigating how the strawberry ban can increase the usage of pesticides and fertilizers in China. And they truly find that the increased use of it and it actually worsens the water quality. And one thing we included in this paper discussing about this point is actually there are those kind of, additional cost, out of the outpatient cost, there can also be some kind of agricultural cost too. So that will include the crop changes and as well as the pesticide or fertilizers thing. But unfortunately, I think that is not the major things. So I think I will add more details and discussions about it in the future. Thank you so much.
Yeah, great paper. Two questions. One related to the tick-borne disease. So I was wondering if you could talk a little bit more about the hosts that these ticks are, taking to people. Like, I don't know, in the US, we think about deers, moose, and, what is it in China? So if you could do some heterogeneity analysis by the suitability or habitat suitability for those hosts, if the incidence is higher in those locations. And then you mentioned something that I was also thinking about, because in Brazil, when they were trying to ban fires for sugarcane fields, one concern was that it would deteriorate the safety for the workers, because that also eliminates the reptiles, like particularly snakes. And so there was this concern. Of course, it was overblown, but I was wondering which types of crops are we talking about here, and if there is any potential for reptiles to be a concern, a hazard for the workers as well. If you could look at that, I don't know if it's.
I think it's a great point. I need to think about, I mentioned that actually those vectors are transmitted through those kind of vectors, but also I need to think about how these vectors can come into connect with human beings. And you just provided me one potential channel, which is host. Yeah, so let me think about the ticks and vectors, and also think about maybe mice or some other things can be the host. And also for your, story in Brazil, I think it also matters in China too, because the kind of crops we focus on here is mostly wheat and corns. I think at least mice and snakes can be one potential, but how it can affect the health part residents and whether it is quite significant, let me just further explore it. Thank you.
I was just talking to Edson about how we should have more papers on ticks and Lyme disease, and then I saw this, so this is great. I think both Hannah and Edson both got it, used more on the crop heterogeneity that you can observe, right? So whether wheat, rice, soybeans are going to have different carbon and nitrogen ratios, they're going to have different moisture levels, right? They'll all kind of provide different suitability for tick habitat. And then the second one's more kind of a question on, so if the main effect is better air, right? And if the way that you get exposed to tick-borne diseases is exposure and being outside and being in the fields, like, are we worried that people just might be outside more, right? And it's because it's more pleasant, and that could be driving the increased exposure and not the actual straw.
Yeah, thank you for your comments here. So for the crop-wise changes, so I think when I first explored the whole project and the mechanisms, I really look at whether the crop land changes or whether they choose to plant a different kind of crops. So the crops here is mainly wheat, and because China, there is some kind of food security red line, so the cropland size actually did not change. For those kind of main grains, they must plant the same kind of grain. Yeah. And for the thoughts about better airs, I'm sorry, could you repeat your question? I'm a little bit lost on my mind because of jet
It
lag.
was just if the ban cleaned up the air, are people outside more and therefore that's how they get exposed and not the actual.
Yeah, thank you. It's an important part about exposure. I think in L's discussion slides, you can find one table about heterogeneities among young residents versus old residents. And if you compare the vector-borne disease versus tick-borne disease, you can find that for vector-borne disease, actually the young residents increased more in hospitalization. So that is partially show that maybe the exposure for young residents is because they have more outside activities, so they have more vector-borne disease. But for the older populations, tick-borne disease is actually a severer kind of. So that's why once you infected it or being impacted by it, it will increase the inpatient spending extremely high. Yeah, so that's part is some kind of show you the exposure for different outside activities. Yeah. But we will first explore maybe visit to parks or other things can show in the whole mechanisms here. Yeah.
Yeah, so super cool. I love this paper. And the graphs at the end of the discussion showing the populations of insects got me thinking about the question of predators of those insects. So like the life, I mean, you can only follow something so far down the chain, right? But like the life cycles of these insects is relatively rapid, so we would expect a very fast response. The life cycles of predators of the insects are slower, so you would expect a slower adaptation of that. But theoretically, if there's a higher food population for the next step up in the chain, the next step up in the chain should start increasing its populations, potentially undoing some of the growth of that insect population. So like, how far down can we follow this in the data that we've got? And like, how should we think about that in terms of the full, both micro and macro biome effects of this kind of a thing?
Yeah, I think it's some, long chain here. Yeah, first, when I think about the predators here, I can think about frogs and also birds and all those kind of animals. I think for birds, the thing is that the clean air also creates some kind of amplification of the birds populations. But like what Elle has already illustrated, the amplification of those kind of insects is far more higher magnitude than those kind of birds populations. So I think I really agree that maybe follow the chain for those predators, including birds, animals, and also frogs, all those kind of small things. It also have their population increase a little bit because the natural can respond too. Yeah, but the aggregate result shows here is just that maybe the ticks and vectors increased more, and that shows an aggregate negative health impact. Yeah, but thank you for those kind of launching things. I think we need to explain more about that part too. Yeah. Yeah. Sorry.
Super great work. I had a question about future work. This seems like you have a really nice opportunity to provide some targeting advice to the government about where they might best have the ban in place versus roll it back. If you pull together everything on the air quality impacts and the insect population impacts and perhaps the water quality impacts, perhaps pollination impacts, it would just be a really neat piece of advice. And I'm wondering if you could speculate, if you had to speculate now, where might you think they should keep the ban in place and where maybe shouldn't they keep the ban in place?
Yeah, it's an ambitious plan. Yeah, and I really agree that it's an important part because as what I mentioned in the broader takeaways, it's not only this policy, it's actually for all the environmental regulations, it's changed the whole systems instead of just a targeted point. So when we try to conduct this kind of analysis, we need to take account of all the aspects too. I definitely agree that in the future, it is a thing that we need to explore. Currently, it's a little bit challenging because thinking about those kind of outpatient care and also about those kind of defensive investment, we have some data limitations there. But I think I can think about a potential measurement that can approximate it and thinking about whether it is good to take into the accounting and show you a more comprehensive cost-benefit analysis in the future. Hopefully, it can tell the government that they need to support the farmers and really solve the problems based on the whole system change. Yeah, thank you.
All right. Since people We have another hour break now for lunch. We're going to reconvene at 1:15, but before we all depart, I maybe want to take the chance to also thank Rob Shannon and Brett Maharshan, who always helps us put these conferences on, as well as all the staff here who's made this run very smoothly with the slides and everything. So let's give them an applause too. And then there's 3 more papers this afternoon. So 1:15, we reconvene here for those 3 more papers. And lunch is same place as yesterday.
Yes, we grew up together. We're kind, right?
Yes.
Yeah.
Yeah.
I famous last word.
Yeah.
Hello, everybody, please take your seats.
Yeah, for just join because we provide. Yeah, area now.
Okay, amazing. Welcome back from lunch. Excited to hear from Hannah on the consequences of land use regulation.
Awesome. Thanks, Anna, and thanks so much for including us on the program. This is joint work with Joe Shapiro and Charles Taylor, who are both here. And the core motivation behind our work is that land use regulations face substantial controversy over whether they properly trade off environmental benefits and economic costs. On one hand, these types of regulations are designed to protect valuable environmental services like air and water quality filtration and natural hazard protection that are often not priced in the marketplace and therefore require government intervention in order to reach socially optimal levels. But on the other, these types of regulations restrict the supply of developed land, which distorts what gets built and where. So we're going to study these regulations in the context of the Clean Water Act. The Clean Water Act was established in the 1970s to regulate the discharge of pollution into our nation's waters. But it also regulates land use because it requires a costly permit to do any sort of construction or land moving near a water body, stream, or wetland. So one feature of the Clean Water Act that's really important for today's presentation is that its scope is repeatedly reinterpreted by different Supreme Court decisions and presidential administrations. And these constant changes in the scope of regulation both provide us with a motivation for studying its environmental and economic consequences, and also provide us with a research design that lets us do so. These rule changes that change the scope of regulation are extremely controversial. And the reason is that they end up mattering a lot for where infrastructure gets sited. To illustrate this point, I'm showing you an image of southern Florida with all wetland areas overlaid in blue. And you can see that in this context, basically the only dimension on which you can expand urban areas is into wetlands. Now, this is particularly true in my cherry-picked example of southern Florida, but it's also true in many other cities across the US, like here in Boston, that were built on historically wet areas for navigation purposes. The role of environmental land use regulations in suppressing economic growth and contributing to the housing crisis has gained a lot of attention in recent years, especially after the publication of Abundance last year. And although Clean Water Act regulations are just one of many, they end up being a major one. So to illustrate this point, I'm showing a quote from a congressional hearing last year on the construction of data centers, where Microsoft President Brad Smith said the #1 challenge in the United States when it comes to permitting is not local, it's not state, it's the federal wetlands permit administered by the Army Corps of Engineers. So the goal of this paper is to be able to quantify the economic costs of those Clean Water Act land use regulations. And in order to do so, we're going to exploit a natural experiment that came about during the first Trump administration when they significantly rolled back Clean Water Act protections under the Navigable Waters Protection Rule, or NBER for short. We're going to start with two questions. First, how did this rollback affect regulatory stringency on the ground? And second, once we've established that there was widespread deregulation, we want to understand the impact of that deregulation on land markets. The intuition here is simple. If deregulation increases development potential, that higher development potential should capitalize into property values. And we can interpret that under a hedonic framework as a willingness to pay for deregulation, or equivalently, the cost of regulation in terms of foregone development potential. Once we've established those large impacts on land markets, we want to be able to interpret the scale of those impacts. And so we're going to compare them to one important dimension of environmental benefits that the Clean Water Act provides, which is flood protection. And in order to get there, we're going to need to show you how deregulation actually affects land use change on the ground. Okay, so where do we fit into a literature? Well, we see ourselves as the first ex post evaluation of the environmental and economic consequences of Clean Water Act land use regulations. This, of course, fits into a much larger literature on the costs of US environmental regulations more generally that many in this room has contributed to, but we think we're some of the first empirical evidence on the land use regulations under the Clean Water Act. So let me start with a bit of background about why the Clean Water Act's scope is open for interpretation. When the Act was established in the 1970s, Congress said that it protected the waters of the United States, or WOTUS for short. But they never actually defined what WOTUS means in practical terms. So it's up to the two federal agencies that administer this program, the EPA and the Army Corps of Engineers, to interpret what WOTUS means on the ground. Now, there's some categories of water resources that everyone agrees are regulated. These include navigable waterways, meaning a waterway wide enough to drive a boat down, lakes and ponds that flow into those waterways, and wetlands that directly abut them. There's also some categories of resources that nobody thinks should be regulated. Think about a roadside ditch that fills up with water after a rainy day. But there's several categories of water resources in the middle for which the regulatory status is ambiguous. The two big buckets here are ephemeral streams. These are streams that only flow after rainy days, but they actually make up about 70% of water volume in the Western US. And isolated wetlands, which are wetlands that don't have a surface water connection to a stream or a river, but they might have important underground conduits. And these are very common in the Midwest in the prairie potholes region. For the purposes of this paper, you can think of there as being two broad interpretations of the Clean Water Act. There's an inclusive scope that was established based on a Supreme Court decision in the early 2000s called Rapanos that said that any water body that had a significant nexus to a navigable waterway could be considered regulated. What does that mean? Any water resource that affected the chemical, physical, or biological integrity of a river that you could drive a boat down could be considered regulated. However, the first Trump administration issued a new rule in 2020 called NBER that said you needed to have a continuous surface water connection to a navigable waterway in order to be regulated. And this significantly narrowed the scope of regulation. Although this rule was vacated in 2021 by a federal court, it's actually now very close to the law of the land under a new Supreme Court decision from 2023 that also requires this type of continuous surface water connection. So how are these rules actually implemented on the ground? Well, say I'm a developer and I want to build something on a wet parcel. I need to first go to the Army Corps of Engineers and I need to ask them whether I'm regulated. This is called a jurisdictional determination. If they tell me, no, you're not regulated, then I can go ahead and build there just like I would on a dry parcel. However, if they say, yes, you are regulated, then I have two options. I can decide to build anyway, but now I need to obtain a permit that might result in costly project delays, redesigns, or the purchase of offsets. Or I can decide that it's no longer worth it to me. It's prohibitively expensive, and I can decide not to develop. So this is the process that we're trying to study in this paper. And we're going to start with the first part of the process, these jurisdictional determinations and their outcomes, in order to study how the rule change affected regulatory stringency. Okay, so our first piece of evidence just comes from looking at a graph of the number of the requests for these determinations by month over our sample period, which is 2017 to late 2023. On the graph, the color of the line corresponds to the rule in force at the time of the determination, with black corresponding to NBER. So you can immediately see that the number of these requests for determinations about whether your parcel is regulated jumps up under NBER, which we're interpreting as developers are aware of more lenient regulation and they're increasing permitting activity in response to it. We also see a corresponding response from the regulator. So now you're seeing the same thing, the count of jurisdictional determinations by month, But now the color of the line corresponds to the outcome of these determinations from the Army Corps, with black being a not regulated outcome. So again, during this period when NBER was enforced, we see the systematic change where there's lower levels of regulation. So clearly the regulator is implementing the rule on the ground. So that gives us temporal variation in regulatory stringency, but we also want spatial variation in order to implement our empirical analysis. So here we're going to construct two proxies for exposure to this NBER deregulation. The first proxy is very intuitive. We're just going to take a map of all water resources in the United States from the National Wetland Inventory, and we're going to measure what share of your parcel is covered by water resources. The idea is that if you have more water resources, you're more regulated by the Clean Water Act, and thus more affected by Clean Water Act deregulation. The nice thing about this measure is that it's directly observable to landowners, and so it should play a role in forming their expectations about whether parcels are regulated or not. And in fact, when we look in the graph on the right, which is showing you the share of jurisdictional determinations that have a yes regulated outcome by high water resource share parcels in blue and low water resource share parcels in red, we see this disproportionate jump down in the share that are regulated for those high water resource share parcels. We're also going to take a complementary approach to measuring exposure to deregulation that builds on several recent papers that show that you can use machine learning to predict whether an individual parcel is regulated under different Clean Water Act rules. So we're going to apply one such algorithm to the universe of non-residential parcels in the US. And you can see in the histogram on the right what these probabilities look like under the broad interpretation of the Clean Water Act, Rapanos, in green, versus the narrow interpretation, NBER, in gray. And we can see this shift towards zero, where we see the systematic deregulation. So for the average parcel in our sample, the probability of regulation declined from 33% to 20%, or a 40% decline from baseline. And again, if we repeat the same exercise with the blue parcels there being the ones that we estimate have a high probability of deregulation, they'd see this disproportionate decline in the share that are actually regulated based on jurisdictional determinations. So this measure is nice because we can directly interpret it as the probability of regulation, but it has the drawback of being less directly observable to landowners, and that's why we're going to use both. Okay, so now that we're able to measure exposure to deregulation over both time and space, we're going to combine that with information on property values to see how this deregulation affects land markets. Our main sample is going to be 4.5 million transactions of non-residential parcels that occurred between 2017 and 2023. And then we're also going to compare effects to residential parcels, which are shown here in brown. Okay, so using this wetland map model, we're going to model the price of a property P as a function of its exposure to deregulation, which we're measuring as the interaction between the property's water resource share W and an indicator for whether NBER was in force at the time of the property sale. We're going to separately control for the property's water resource share when NBER was not in force. And we're going to include a suite of property level characteristics, things like lot size, distance to central business district, and importantly, the predicted fair market value of the property in 2016 before our sample starts. This is going to allow us to control for selection of different quality parcels into sale during different regulatory regimes. In the spirit of BANZAF, we're going to interact those property level controls with an indicator for when the policy was in force. And then we're also going to include zip code by year month fixed effects, which are going to do a lot of work to absorb confounding trends in local housing prices that might arise, for example, because of the COVID housing boom or because of changes in local land use regulations. So our parameter of interest here is going to be beta, which is going to tell us whether the prices of non-residential parcels disproportionately increased for those parcels with water resources relative to parcels without them. We're going to implement a very similar estimation strategy for our other measure of exposure to deregulation, which comes from the machine learning model. Here, instead of W, water resource share, we're going to use the estimated deregulation between Rapanos and NBER, so the difference in those probabilities, to proxy for exposure to treatment. And we're going to separately control for the probability of regulation under the rule that was not in force at the time of the property sale. So here, our parameter of interest is going to be beta A, which is going to estimate the effect of deregulation on property values. So I'll jump right into the results. We find very large impacts on property values from deregulation. The first row is showing you the results from the wetland map model. We estimate that going from a 0 to a 100% water resource share means that your property value increases by about 13 log points or 13% under NBER. In the second row, we're showing you the results from the algorithmic model. And here we find that going from 100% probability of regulation to a 0% probability of regulation increases property values by about 34 log points or over 50%. So we're going to show you how those impacts scale up to the whole stock of non-residential parcels. But before we do, we want to convince both ourselves and you that what we're really detecting here is changes in land use regulations and not something else going on in the market at the same time. So the first thing we're going to look at is how effects compare on non-residential parcels and residential parcels. Why? Well, non-residential parcels are largely vacant. They have a lot of development potential. And so we think deregulation that makes it easier to build there should move their property values. On the other hand, residential parcels tend to be already built up. And so they're not really going to benefit from a deregulation that makes it easier to build there. And so we're viewing them as a quasi-placebo group in this setting. And in fact, that's actually what we find. If you look at the estimates in the second panel here, we see no corresponding price increase for residential parcels based on the same treatments. We also implement our regression and an event study framework, where we find that the effects of water resource share and the estimated probabilities of deregulation are concentrated during the period when NBER was in force, and among those non-residential parcels, we see no corresponding price jump during NBER for the residential parcels. And the last thing I'll show you is that it looks like the price effect is a function of exposure to deregulation. So here the coefficient plot is mapping our proxy for exposure to deregulation, water resource share along the x-axis, and the estimated price effect of NBER is shown by the dots. And we're finding an increase in prices that's corresponding to an increase in exposure to deregulation. Okay, so why are we seeing such large increases in property values? Well, we've already seen one piece of evidence that this deregulation is facilitating development activity from those jurisdictional determinations. But we want to look more closely at this, so we're going to measure this another way, which is using a remotely sensed land cover product, the National Land Cover Database, which lets us observe both increases in impervious surface area and decreases in wetland area across the United States. So specifically, what we're going to do is we're going to see how land use changes in the wake of a jurisdictional determination for regulated versus not regulated parcels. And what the graph here is showing you is wetland share. And how that changes in the year leading up to a jurisdictional determination. It's about equal on regulated versus not regulated parcels. However, once you get that determination in year 0, we start to see this wedge develop between regulated and not regulated parcels. And there's a systematic decline in wetland area on those not regulated parcels. So in terms of magnitude, we estimate that deregulation reduces your wetland share by about 0.6 percentage points relative to a base of about 6% to begin with. So a 10% decline in wetland share. Okay, now we're going to bring all of this machinery together to try and give you a sense of the scale of these land value benefits and environmental costs of NBER deregulation. So the first thing we do is we want to scale the estimates from our transaction sample to the universe of non-residential properties in the United States. We can observe in the property assessor records that there's about 30 million non-residential parcels. But the first thing we need to do is to translate the value of those parcels from assessed values into fair market values. Why do we need to do this? Well, assessed values are systematically lower than transaction prices for parcels, often by a factor of 2 or more. And so we first scale those assessed values into fair market values using a machine learning model, and then we're able to apply our estimated effects from the transaction sample to predict changes in prices for all properties in the United States. We find that on average, NBER increased the value of non-residential parcels by about 1%. And when you add that up across all of the properties in our sample, it totals to about $150 billion increase in land value. If we use the algorithmic model instead, the effects are slightly smaller. So we estimate a 0.6% increase for the average parcel, or about a $51 billion total impact. Of course, those averages are masking heterogeneity over space. So we see larger mean effects in places with higher exposure to deregulation, places like the northern Midwest, the Gulf Coast, southern Florida, and parts of the Atlantic coast. And then when we add up to the total effect, these are of course concentrated in areas with a lot of non-residential property values. So you see big effects near metropolitan areas that also had high incidence of deregulation. We want to be very careful about how we interpret these land value changes in a welfare context. So the way that we're thinking about this is that NBER is a shock to the quality of non-residential land. It's going to increase that quality by increasing its development potential. In a classic hedonic framework, you could view that increase in land values as willingness to pay for deregulation. And based on Banzaf's recent work, we could interpret that as a lower bound on willingness to pay once you account for general equilibrium and spillover effects. However, I want to be very clear that this is kind of a partial cost of regulation because our analysis does not include changes in local wages in the sense of rollback or the spatial response to land use regulations in the sense of Shea and Moretti. And finally, to provide you with a little bit of insight as to how big this $50 to $150 billion land value benefit is, we're going to compare it to one important environmental cost of deregulation, which is loss of wetland flood protection services. Now, we know that the Clean Water Act protects many environmental services beyond just this one, but we choose to focus on it both because there's credible estimates of wetland flood protection values in the literature, and also wetland flood protection is thought to make up about 1/3 to 1/2 of total wetland value based on meta-analyses of willingness to pay surveys. So panel A here is showing you that $50 billion to $150 billion benefit of NBER deregulation in terms of land values. We're going to take our estimates from how deregulation affects land use to estimate the change in wetland extent across the country, and then multiply those by per acre values per wetland in terms of flood protection. And we get flood protection costs in the range of about $6 to $9 billion. So these are an order of magnitude lower than the land value benefits, giving us cost benefit ratios in the range of 10 and over. So what do we show here? We show that NBER decreases Clean Water Act regulation significantly by about 40%. And in doing so, it increases the development potential of non-residential parcels, which leads to these large changes in their price. Land values across the country, we estimate increased by at least $50 billion and up to $150 billion, whereas the flood protection costs of the regulation are an order of magnitude lower. Of course, we don't measure all of the environmental services that the Clean Water Act is designed to protect, but given that wetland flood protection value makes up a significant share of its benefits, we see it as unlikely that this ratio would drop below 1 if you accounted for other services. However, we think there are a number of important questions that are still open in the literature. For example, it would be great for our team or other folks in this room to be able to account for those other environmental services so they could enter this type of cost-benefit analysis. We're also very curious about whether our findings about the impact of this deregulation on land values and development would hold for other environmental land use regulations in the United States, such as NBER. And we'd like to do more work on what components of the cost we're capturing here, whether it's a reduced cost of purchasing environmental offsets or project uncertainties or delays. That would be really nice to explore in future work. So thank you so much for your time. I am looking forward to Sheila's discussion and to questions afterwards.
Great, thank you. Now we have Sheila as discussant.
Okay, so this is just a really wonderful paper. I really enjoyed reading it, so I really appreciate the opportunity to discuss the paper because I really enjoyed reading it. There's a lot to like about it. So, Hannah's done a really nice, concise job of describing the paper, so I won't say too much about what they actually do, but things, right, I'll sort of summarize, they're looking at these recent changes in the boundaries of the jurisdiction of the Clean Water Act in the US, the sort of Section 404 or wetlands program, to understand this impact of federal regulation, or in this case, deregulation on land values. And this is really important because there are, as Hannah said, a lot of different rules and regulations, and a lot of these have been been highlighted recently as, barriers to constructing housing and these kinds of things like NEPA and the Endangered Species Act and others, where this is probably the big ticket item on the cost side. And yet when you look at the regulatory impact analyses that are done by the agencies that are kind of implementing rules that are changing these things around the margins, they're counting things like permitting costs, and things that are probably really small potatoes relative to these changes in land values. And this is really a wonderful paper in the sense of sort of contributing what I think of are, really nice, credible set of estimates of what, some of those costs might look like. So they're doing that through hedonic property analysis of mostly kind of focusing, as she said, on non-residential property values, but they do have some analysis in the paper that looks at residential parcels as well. And they're identifying the effects looking at land that's sort of relatively more exposed to these changes in jurisdictional determination than others, right? Because some share of the property is actually or potentially jurisdictional. Again, fills a really important gap here. It's very well executed. It's really well written and clear. They have a nice identification strategy, impressive data collection, effective use of these very large data sets that they're creating, managing, and analyzing. So great contribution. I'm going to talk about comments in three main categories or three main suggestions for how I think they might kind of take this work further. The first is going to kind of focus on not the use of the algorithm that she described to predict these jurisdictional determinations, but then taking that into the hedonic property model, I think is causing them some trouble. So I want to talk a little bit about that. I want to make the suggestion that they consider expanding their property price analysis to extend into this kind of generational change that's represented by the Sackett decision and kind of beyond May of 2023. So I'm curious to see what they'll think about that. And then I want to just talk about the possibility of kind of reframing the discussion at the end of the paper on the benefit cost analysis on a few specific points. So I'll start with the first. And the first thing to say about this algorithm that Hannah talked about is that it is really impressive, right? So they do a very, very nice job, and there are some very clear diagnostics in the paper showing that they can do a really nice job with this machine learning algorithm predicting the sort of change in deregulation, right? Whether a property is, kind of affected or not in this change in determination of jurisdiction. And the challenge then for me is, right, so that what's nice about that is it tells us they're doing a really nice job predicting kind of regulator behavior. And that's great in two ways. One, because the model is nice, it's doing what they want it to, but two, also because you like to know that regulators themselves, right, are sort of working on this very rich information, on the basis of very rich information to make these jurisdictional determinations. And they have a ton of this very rich information in the algorithm. So things like soil quality and, but multiple variables from the National Hydrography data set and right, lots of really interesting and useful land characteristics. The challenge for me as the reader is sort of going into the hedonic analysis, and Hannah alluded to this in the presentation, and they're also fairly clear about this in the paper in a couple of sentences, that in the hedonic model, what matters is the property buyers and sellers, right, view about the value of this land, and that's a very kind of long run view, and it's also probably likely, right, that it's not as well informed as the regulator's decisions, right, about whether these properties are jurisdictional versus not. And so I feel like the simpler model that they have in mind, and that they, so now they carry both of these all the way through the paper, right? You see the results with the National Wetlands Inventory, like with sort of observable maps that tell property owners, right, how much of the property is wet versus not. And you see the results with the algorithm. And that's a lot to kind of carry, through the paper in your mind as the reader. And I think that as good as the algorithm is that the first thing they use it for, I think it's probably not the best choice for that second thing that they use it for, despite how well it performs in the first function. So again, property buyers and sellers probably have less information than what they're using. I think we're seeing that in the empirical results, right? You sort of, the empirical results seem to suggest that as well. But there's also this technical question that I had, and it was a little hard for me to sort through in the paper, which is that this change in probability of regulation that they're kind of using, that's coming out of the algorithm that they develop, is itself a function of which regulatory regime is in place at the time that the determination is made. And so it felt to me like the sort of comparison of these betas you get out of the algorithm model in the hedonic property function with directly, with the NWI, right, betas, I think that's not quite right. Like, I think you almost want, in addition, the sort of partial derivative of, right, the kind of change in probability with respect to the, right, which regime is in place. Because I think you're kind of taking out a portion of, and probably a really important portion of that variation, right, from the regulatory shift that you're trying to identify. So again, for that reason also, maybe just think about, moving out that kind of algorithm piece from the hedonic part of the analysis. Second comment is, I think it would be really helpful to extend the analysis, the hedonic analysis beyond May 2023. Why? I have three reasons for that. One, the NBER shift between 2020 and 2021 is brief and it's temporary. Sackett argued October 2022 and decided May 2023 feels generationally permanent. And so it feels like a missed opportunity for kind of a stronger test of the hypothesis that a big shift in the way that we kind of regulate this kind of land is going to cause a shift in property values. Two, they have this kind of misfortune of timing of COVID, right? Where the kind of COVID housing boom window, hard to get exact boundaries on that, but looking at the Dallas Fed, they say it's 2020 Q2 to 2022 Q2. Maybe that's, wrong by a quarter on either end, but it almost perfectly overlaps with their NBER window. And the COVID price effects are likely stronger where wetlands are common. So the good news is they have some controls in here, right? They've got these zip code by year fixed effects, and then they have an additional robustness check in one of the appendices that she didn't mention, where they're kind of have this additional control for being in a zip code with a particularly strong COVID housing boom. And so those are both great things. But the bad news is that maybe the relevant COVID related variation is below the zip code, right? It's at the property level that people are looking for the kind of greener, away from it all kinds of parcels, right? And so we still have this potentially problematic variation, and it's consistent with the finding that prices don't go up and stay up when we have this regulatory shift, but they go up and then they come down again. And so I just worry, right, if you think about as an editor sending this out to referees saying, well, gee, that looks like, sort of a COVID boom and not bust, right, but, prices coming down after that. And so it feels like you could get a lot more mileage out of extending and just getting into this kind of clear space where after 2023, we're done with COVID, right? At least in the housing market, we're kind of in a more permanent era for changes in regulation. And I think that might be really strong. Even more complicated, there's this additional change in this window where you have Biden coming in and some uncertainty about whether he's going to have a change in policy and so on. So again, there's some additional gray area in the window that they're looking at that I think they could get away from if they extend, or at least kind of get clean of if they extend beyond that. The third comment has to do with just reframing the benefit cost analysis. I think, again, the benefit estimates here are terrific. The cost estimates are necessarily partial. There's all kinds of caveats in the paper. I do think they could maybe engage a little bit more of the science literature on wetland benefits that say, hey, these are among the most ecologically valuable biomes on Earth. It's a small share of the planet's surface. How confident are we that the flood damage costs are the big ticket costs here? Second, I think that the NBER-Sackett kind of change here is potentially a non-marginal shift in wetland losses and damages, and especially if you look at like a state like Florida, where it really opens, right, a lot of land to development. I'm wondering whether that marginal shift in flood risk is the right way of thinking about that change. And then I also had this itch in the back of my mind wondering why, if the change in regulation capitalizes, why does the flood risk change not capitalize? And so that goes the other way, right? Which says that you're even not, kind of underestimating the benefit to cost ratio of the deregulation because maybe that flood risk change is being captured in property prices. There's good literature they can cite on flood risk generally not capitalizing well in property prices. So I'm not, that's sort of not a real sticking point for me, but I could see, right, sort of somebody wondering that question. I was sort of surprised that the effective conversion and development did not have an effect on nearby properties. We know, from other hedonic papers in the literature that, being close to especially open water wetlands and so on can increase property values. A lot of that literature focuses on residential property. And that also sort of strikes me as being relevant to some of the other studies that y'all cite, looking at benefits of wetlands. And so I'm not sure kind of how directly comparable that is, when we're focused mostly on non-residential property. I wondered whether mitigation costs should fall, right? If we really have this big drop in demand for mitigation activities and permitting and so on, maybe the cost of that, the demand for that stuff should shift inward and prices should fall. And then finally, some of those mitigation expenditures might have private benefits, right? So if I'm doing on-site mitigation and I create a little constructed wetland, that provides the sort of drainage and other things that I need to develop the property from a pragmatic point of view, but it also, right, sort of checks the box, for regulators in terms of compensation for wetlands loss. And so I wondered whether we shouldn't, partially, kind of account for those as private benefits. And that's it. Again, love the paper. I highly recommend it. It's a great read, and everyone should take a look.
Thanks so much, Sheila. Those are really great comments, and we're looking forward to addressing them in the next several weeks and months. I'll just talk about a couple. So we have gone back and forth as a team about whether to carry the algorithm through. We like it because of its very interpretable magnitude in terms of the probability of deregulation. I fully take the point, though, that one of the drawbacks is that landowners might not be able to directly observe these probabilities. I think in reality, when people are making large investments in these parcels for development, they're probably hiring land use consultants that are going to tell them more information about the parcel and its probability of regulation than just looking at a map of wetlands. And so that's kind of one reason that we kept it in there. It does create econometric issues, which you were right to point out. We have this extension in the paper where we do a correction for some of the correlation between the machine learned treatment and the downstream inference. It doesn't move the parameter much, but I agree that there's kind of some thorny issues there to grapple with. It's a great suggestion to expand into Sackett. We have thought about that. We started the paper many years ago before Sackett. And so part of this is a legacy, part of it is access to data. But it's a good point that we would get away from the COVID issue. I didn't spend a ton of time on it today, but we do a ton in the paper to try and convince ourselves that this isn't COVID. So in addition to those zip code by year, month fixed effects, we also have property level controls for the factors that the Romani and Bloom paper identify as kind of driving the COVID housing boom. So distance to CBD and metro area, work from home share, local population density, including those doesn't really move the point estimates. And then, as Sheila mentioned, we do this check in the analysis where we test heterogeneity of the deregulation impacts in places that were very affected by COVID and overall housing indexes and places that were not affected. And we find kind of no difference in the impacts of deregulation there. And then the last thing I'll say on COVID is that if it was really COVID, I think we would expect a large price increase for those residential properties because that's what people were actually buying during COVID. They were moving out of the city into the urban periphery, which again is a place with wetlands and why you might be worried. But we would expect that to show up in the residential estimates. Yeah, and point totally taken that I think we could do more with the science literature to engage on the cost benefit analysis beyond just flood protection.
Amazing. Thank you. Questions? Everybody feel free to line up.
So maybe I missed this, and this is a stupid difference in differences question, but you're interpreting the NBER as reducing the value of properties that have more wetlands in them.
It's increasing.
Sorry, increasing. Deregulation increases the value. And so you interpret that as sort of a cost of the regulation. But why couldn't it also be an increase in the value of the properties that are nearby those wetlands? Or just a scarcity result?
Yeah, so I think that this is a very valid question. We do look at it in the paper, and I didn't include it for time's sake today. The effect of deregulation on a parcel on the prices of nearby parcels. And so we're not seeing kind of this effect that you might expect where there's substitution from non-wetland to wetland parcels under NBER, in which case it's what you were saying, where you could alternatively interpret it as a decrease in the value of the non-wetland parcels. Furthermore, I think based off the Banzaf and JPE paper from 2021, we think of those, we're kind of interpreting our estimates as movement along the ex post hedonic price function. So we're not really comparing wetland parcels to non-wetland parcels under different regulatory regimes. It's thinking about once we have more lax deregulation, how does this change in the development potential of the property show up in willingness to pay for it?
So I had this is great. I had three thoughts. One of which is, and this relates both to the COVID problem, which I think is just very hard to convincingly deal with. And I think what you did is fine. I think probably doing a little more on that is fine. But I think the heart of it is, to me, is about the economics of this. And the economics is which of these parcels, commercial or non-commercial, are you actually in some plausible way going to do something with? And to what extent are you not? And I think just doing more to identify that ex ante, and it's a question of, is there a lot of land there? Is there access to infrastructure, or just proxying for price? And thinking about that, I think going back historically and showing the areas that had tighter regulations saw less conversion of parcels like that. So if we take a window in 2010, which you can do, of course, in CoreLogic, and you just look at where there's an abundance of these properties, like look at ones which are dosed more. It's not identified in the same way that you do have. It still would be convincing to sort of show that you see a lot of these conversions in some areas other than and not others. I think just doing more with that is sort of good because you can differentiate between some type of property versus other. I think that's also going to be helpful if you look at the residential properties, and if the bulk of the residential properties are kind of low acreage, then it's kind of obvious why that's not going to be a highly appealing thing. The other point on this, which I think is important, is like every Massachusetts town has its own bloody wetlands requirement, one of which defines a wetlands as a wicked big puddle. Okay, the places that have a sufficiently rigid local or state code are presumably going to be less buffeted by this at all. And I think a little bit of work on this is probably sensible. Just to sort of like it provides you with an extra control on this stuff. But it's great that you're working on this, and more on quantities as well as on prices as well. So like the more we see the conversions both afterwards or not, the better off we are.
Thank you. Yeah, point taken that there's a lot more that we could do with heterogeneity. I like the idea of looking at parcels that are quote unquote developable for whatever reason. And one way that we could do that beyond looking in the CoreLogic data, which is a great idea, is that the jurisdictional determinations tell us a lot about the property. And so we can look at places where people are actually asking for these permits and see whether those places are systematically different than the average parcel in our sample. Also point taken on there might be effects on certain types of residential parcels that are getting washed out in the full sample. We have thought a lot about the local versus state versus federal. In many places, the federal regulation sets it always sets the floor on regulation, and in many places also the ceiling. But there are places with more stringent regulations. One thing we've done to try and look at that is look at heterogeneity across red and blue states, with the intuition that blue states might have more strict local land use regulations. And we do find kind of slightly larger effects there. In general, we've been a bit cautious about too many heterogeneity analyses because we don't have exogenous variation in any of these things. And so it's difficult to interpret what the heterogeneity really means. But it could at least descriptively add some richness to the paper. Right.
Thank you. Really cool paper. My question is related to the geography of the benefit and cost, so where the benefit incur, where the cost incur. I think it's part of related to Sheila's question about like the flood damage, flood loss kind of not capitalized into the property value. It's maybe like it should be capitalized, but it's capitalized in the downstream area instead of surrounding the wetland area, but the kind of development is happening around the wetland. So I think it's kind of like in your benefit cost analysis, is that kind of for different communities, and how do you think about the implication for the willingness to pay and result and distributional impact of that?
Yeah, this is a really great point. Most of the land value benefits are coming to the individual landowners, whereas the environmental services are either locally displaced in the case of flood protection to downstream properties, largely not the property that's been deregulated, or in the case of something like carbon sequestration, maybe even globally displaced. And so, yes, there's this clear spatial separation between costs and benefits, which is going to have distributional impacts. And right now that's all masked by aggregating things up to total impacts.
I really like this. It's super cool. I have two kind of half-baked thoughts or questions, I guess. One is, what can you talk a little bit about the resolution that you have on the actual like adjudications? Like, do you see, for example, a proposed development that was not allowed in 2018, and could you say something about what would have been built, or maybe something that has been repeatedly adjudicated, to say something more about that marginality question? Because I think that's really interesting. The other thought I had was about like kind of agglomeration stuff. So like if you have a wetland area and you build, convert many different pieces of land, that probably has a greater aggregate benefit if you're building a whole neighborhood or something like that. And so I don't know if that's something you can speak to as well.
Sure. Yeah, so that's a great question. Actually, the first research design we thought of for this project is, can we observe jurisdictional determinations under different rules and then see what happens to the value of those lands? And it's so rare that we can't really do anything empirically there, but we can observe these kind of larger scale patterns in requests for these determinations and where they're happening over space. The second question about
I'm
Wait,
sorry.
So could you do something to predict, like maybe if you don't have individual repeat, like that would be too much, but if you could do something to predict like which ones would have been in which group?
Yeah, so that's exactly what we're trying to do with the algorithm is we train a model based on those determinations, which are at the kind of sub parcel level. And then we predict under each rule whether an individual parcel is regulated or not. So it carries this kind of problem of being less interpretable, but it is nice in the sense that it gives us something that we can directly trace back to the jurisdictional determination data. And then, sorry, what was your second question?
About like agglomeration?
Oh, agglomeration. So we do see things like that happening. In the paper, we highlight this one case study where there's this community on the outskirts of Houston that filed for like hundreds of these jurisdictional determinations right when the rule changed and it became more lenient. And they built an entire planned community with like a research campus and all of these fake lakes. And so it really like highlighted the economic value that you can get from developing these wet, high flood risk areas. But at the same time, all of those properties have flood factors of like 7 or above. And so we've now placed all of this capital like directly at highest risk. Yeah.
Thanks.
It went by a little fast. I thought I might have seen a result that said in the residential parcels that the price went down after the regulation. And I was wondering, is that consistent across your different methods? Are you interpreting that as a cost that should be offset against the price appreciation? And just how are you thinking about that?
Yeah. Sorry, things were fast. We don't detect any decline in the value of residential parcels. They're pretty flat. There's like maybe a slight downward trend in the event study that you saw, but none of it is statistically detectable. So we're not finding a whole lot happening on residential parcels at all, but that might be because we're not looking at the right types.
Very similar question. It's not clear like ex ante what the direction should go from residential properties because you're signaling that you're going to maybe build something next to people's houses and they really don't like that. And so just thinking through in this cost benefit analysis, this is a great point that there are potential losers, at least in the short run as well, who are is not an environmental cost.
Yeah, no, that's a good point. I think we were viewing the residential properties as a quasi placebo because out of those jurisdictional determinations, we see very, very few on residential parcels. So we're not seeing a ton of developer interest in building on them. But the point that the effects from the non-residential parcels could spill over to the residential parcels is something that we could definitely explore more.
Similar question. The first event, I was a little confused by the 2020 deregulation, but that had been in place for like 3 years, right? It took them years to develop it and go through public comment and all that. So I was wondering how much should a property price really jump when the rule was actually finalized? And then thinking hypothetically, if the Supreme Court had never reversed the Biden administration's reversal, there's a cost to the interim year and a half or 2 years where the rule was in place before it got thrown out. That's kind of irreversible. And that's just kind of interesting from a big picture perspective that an incorrect rule applied for a little while can have long lasting benefits or effects.
Yeah, definitely the effects are durable because we're talking about building things here. And even once the regulation is repealed, any jurisdictional determination that you're not regulated lasts for 5 years since the determination. So people could continue developing after the rule was vacated. On the timing of the effects, we do look at in the paper, I didn't show it today, an event study that goes all the way back to 2010 and then to when SACIT was implemented in 2023, because there are some events before the rule was finalized that you might expect to move prices. For example, when Trump was elected, when they first announced the intention to revise the definition of WOTUS, and then when it was put out for public comment. We don't find that any of those events actually move prices. And what we're thinking here is that people are making extremely large investments in this land. And so they need certainty in order to capitalize that deregulation into property values. So that's why we think it's happening at the timing of when the rule was finalized.
So a really nice paper and a really great talk. I know one thing, but I'm not quite familiar with is mitigation banking credit in wetland. So I just curious about how that part can affect your story here and whether, the credit, because of the deregulations, it also affect it and can further spill over to affect the other part of the property values. Thank you.
Yeah, great question. So what we've looked at is a back of the envelope for how much of this kind of cost of regulation could be explained by the requirement to purchase these mitigation credits or offsets. And it looks like it could be anywhere between a third and the full cost of the regulation that we estimate in terms of property value impacts. So it's definitely like a large contributor to the cost of this regulation is the requirement to purchase these offsets. I guess in the spirit of heterogeneity, like others are suggesting, what we could do is look in different mitigation markets that have different prices and see how much that carries through to the property value impacts. Awesome. Thank you so much. This was great.
Thanks, Hannah. Now we have Lint on green AI in industry.
All right. Thanks so much. So this paper is joint with Philippe Agnon, who needs no introduction, Céline Antonin, who's at Sciences Po and the French Economic Observatory, and two wonderful pre-docs who are here today, Matthias Abitbol and Benjamin Langeron. So this paper is motivated by the big picture question of how the AI revolution is going to affect energy consumption and environmental outcomes. And both in the policy debate and the academic literature, a lot of the attention to date has focused upstream on the energy required to produce AI services. But of course, we know that that's only half of the equation, because we would also expect the availability of AI services to affect how we consume energy downstream in households and in industry. And so in this paper, we're fortunate to have data that allow us to evaluate the effect of a new AI tools rollout on industrial energy consumption, also taking into account the upstream energy that's required to produce those AI services. So a high-level overview of the paper is as follows. So again, we're fortunate we have data from a Fortune 500 company that's a leader in environmental services that implemented and rolled out an AI tool developed by an AI startup. And it's specifically an AI digital twin tool to optimize energy consumption in wastewater treatment plants that we see being rolled out across about 200 wastewater treatment plants in France so far. We have two sources of variation that we can use to identify the impacts of this tool. One is that across plants, the rollout was staggered. So some plants had the tool installed earlier than others. But also within a given plant, the AI is not always operational. So we observe the same plant on different days where either AI is or is not control of the most energy intensive part of wastewater treatment, which is aeration. The headline results are going to be as follows. We see that this AI tool induces a sustained reduction in electricity consumption of about 5%, of carbon emissions of about 6%, and electricity costs of about 8%. And these numbers differ in part because in addition to reducing overall energy consumption, the AI also shifts some of the consumption from peak to off-peak hours. Comparing these downstream energy savings to the upstream energy cost required to produce the AI services, the data we have right now, they're imperfect, but they're arguably conservative. We find that the energy cost of producing these AI services is less than 1% of the downstream savings benefits. So at least in this particular context, for this particular technology, it appears to be a net positive from an energy and environmental perspective. So the sector we focus on is wastewater treatment, which at first blush might seem a little bit narrow, but let me try to give you 3 reasons why you should care about wastewater treatment. So first, it's actually a very important sector, even from a climate and energy perspective. So it's responsible for about 1.3% of global greenhouse gas emissions, which of course in this room folks know aviation is about 2%, so it's less but similar order of magnitude. And one of the reasons, there's several, but one of the reasons it's important is because it's very energy intensive. So EIA estimates put global wastewater treatment plant energy consumption at about 1% of global electricity consumption. So it's arguably an important sector in its own right. Second, however, the specific process whose optimization by AI we study is exemplary of a broader class of industrial processes, endpoint control processes that meet the following criteria. So you have to use an energy intensive process, in our setting aeration, to meet a certain target, say getting water effluent to a certain quality level. But both how much you need to use that energy intensive process varies based on conditions that are fluctuating, depends on temperature, inflow, pollutant loads, etc. And some of the targets you're trying to hit aren't observable in real time. And again, this is something that comes up in other industrial applications, industrial drying, for example, steel galvanization, other settings where the AI startup whose tool we study has already developed other solutions. So I think it's a more broadly relevant example of a type of process that's currently managed with kind of backwards looking threshold based rules, but could be optimized with forward looking predictive AI like the digital twin that we study. Third, the company we work with, and also more broadly the water sector, has been somewhat pioneering in adopting these kinds of tools. So if we compare, for example, in Eurostat data, only about 5% of manufacturing firms report using AI to automate workflows and decision making. Whereas here we see a large-scale industrial rollout, as other water companies have done, of a tool that directly manages some of the energy-intensive processes in the downstream plant. All right, so we contribute to 3 literatures. Don't know why it's always 3, but it's 3. So first, we write directly to a rapidly growing literature that looks, using microdata, at the effects of new AI tools on industry. A lot of this work has focused on productivity gains, for example, in customer service, writing, coding, consulting. Here we focus on a different set of outcomes. We look at energy and environmental outcomes, and we also study a different type of AI, right? We're not looking at LLMs or Gen AI. We're looking at predictive AI and domain-specific AI, which includes some machine learning, but also neural networks. So it's a different type of AI that generally has a lower energy footprint in the upstream production, but can have disproportionate downstream benefits in improving energy efficiency. So we thereby also relate more directly to rapidly growing literature on AI and energy. It's funny how quickly your literature review can be out of date. A lot of these papers weren't even posted 3 months ago when we submitted the paper. But so there's growing literature, again, looking at the impacts of AI and data centers more broadly on energy prices, energy demand, power systems, air quality, et cetera. And somewhat surprisingly much thinner literature on the downstream effects of deployment of AI services. So most directly related is some work by Robert Metcalf and co-authors who do an RTC looking at the effects of getting households to let AI decide when their EVs are charging. That can shift some of the charging from peak to off-peak hours. In contrast, in our paper, we provide microevidence in an industrial setting and can also look at the net energy balance. So for the remainder of my time, I want to first give a little bit of background on the setting, on the data and empirical strategy we use, present our main results, and then also some additional results on how AI deals with shocks. So we're going to look at extreme rainfall events and whether we're sacrificing water quality for these energy savings, which, spoiler, based on the water quality measures we have, we're not. Even the water quality measures turn out to improve alongside with the energy and emissions dimension. Okay, so the specific part of wastewater treatment that the AI tool we use helps optimize is aeration management. So aeration is generally the most energy intensive part of activated sludge wastewater treatment plants. And again, this is critical for getting the water quality right, but very energy intensive. And so this is obviously greatly simplified, so apologies especially to the folks from the water literature, but I want to make 2 points. So again, how much and how intensely for how long we need to aerate the water depends on conditions. It depends on inflow, pollution load, temperature, et cetera. But it's also not as simple as more aeration just means cleaner water. Because on the one hand, we need enough aeration for the bacteria to do their job, to eat carbon, organic matter, but then, and for the first part of converting ammonia into nitrate to clean it up. But then the second part of getting rid of ammonium in drinking water is you need anoxic conditions. So you don't want to aerate too much. So it's really a stochastic dynamic optimization problem that you have to solve. The status quo, though, in a lot of wastewater treatment plants is generally, so maybe in the old days was rules of thumb, we just aerate for a certain number of hours and then see what's up. But now it's a lot of even the automated wastewater treatment sort of threshold-based decision-making. If dissolved oxygen hits this level, then we turn on the aeration. But it's generally reactive and backward-looking, whereas, of course, the theoretically optimal way to manage the process should be dynamically optimizing and looking ahead. So the digital twin solution we study uses a broader set of observable real-time data than the threshold-based control, right? So the digital twin basically creates a digital replica for each individual wastewater treatment plant, uses real-time data that we have on dissolved oxygen, redox, also weather forecasts, energy prices, brings in all this information to try to predict the variables that are key for deciding how long and how intensely to aerate, and then basically improve the process. The algorithm's objective is to minimize electricity costs subject to the water quality constraint that the effluent that we needed to have, basically. All right. So we take advantage of a staggered rollout of this tool to evaluate its effects. And so we specifically have data from October 2022 through July 2025, where the rollout so far covered about 200 plants. This rollout is divided into two phases. So the first phase, the technology was rolled out to about 50 plants that basically had to volunteer and meet certain technical requirements and have a certain geographic distribution requirements across France. In the second phase, based on the results of this initial pilot, the company decided to roll it out more broadly, and they set a schedule for rolling it out to basically all the 500 plants that are technically eligible and in the right size category. So we observe parts of the second phase rollout. So all the plants in our sample have been selected for getting the AI tool installed. It's just happened at different times. And if you're concerned about selection among the volunteers in the first and second phase, we'll show you results that differentiate treatment effects by phase. A plant we observe in 3 different control modes. So first is local control, where the aeration is locally managed by the plant. Then we observe it in an AI training phase, and then we observe them with basically the AI in charge of the aeration. Now, importantly, this is not an absorbing treatment. You can have the AI installed, but choose not to use it, or the AI service provider can shut it down, or it can shut down for exogenous reasons, like a connectivity outage or a sensor malfunction or something else. So that also means if you aggregate up from the very fine scale time level, it's a continuous treatment. We see for each plant in a given week or day what fraction of the time AI was in charge versus what fraction of the time it was locally managed, how long it's going to be aerated. To give a sense of what this looks like, this is data from one example plant. So you see the lines are different dates. Initially, we observed the plant in local mode where aeration was locally managed. Then we see the AI training phase where, again, the service provider is producing a digital replica of the plant. And then we see in green days where AI is in charge of aeration and in red days where it was offline for different potential reasons. Here we have the analog of that at the aggregate level. So the y-axis here now is the number of plants. The x-axis is time. You can see how there's initially this pilot phase with the first 50 plants that had the AI tool installed, and then it was being rolled out to more and more plants. You also see that at any given point in time, we have plants that had the technology installed, but it's not operational. So again, this is second margin of variation that we're going to be using in our estimates. Okay, so I think I already spoke enough about the data, so let me just move forward. So we're going to consider 3 different definitions of what it means to be treated by AI. The simplest is a binary indicator for have you had the thing installed. So this is going to be set to 1 after installation, regardless of whether it's operated or not. The other 2 use this variation within the plant of whether you're actually being controlled by AI or not. So our preferred measure is AI usage. This is the share of, say, the day or the week that AI was in control of aeration. And then we also have an indicator whether you had AI in charge in any given time interval. Initially, we were a little bit econometrically intimidated by the setting because it seemed really difficult to find an estimator that works. But we're fortunate that Duchesne, Martin, and Taudefoy have a dynamic staggered diff and diff estimator that's designed for settings with non-absorbing treatment and continuous treatment. So that's what we use for our preferred estimates. Okay, so here's the headline sort of main results. So this is the Duchesne, Martin, Taudefoy event study estimator on the effects of the AI tool on electricity consumption, carbon emissions, and electricity costs. And so after 10 weeks of treatment, the average total cumulative effect sizes are again about 5% reduction in electricity consumption, about a 6% reduction in CO2 emissions, and about an 8% reduction in electricity costs. Here's the table pendant to the graph. So the first column, again, is our preferred measure with the continuous measure of AI usage, where I just want to be clear, we've scaled those coefficients to assume AI was operational 100% of the time. Naturally, if instead we use a measure of AI that's just, have you ever had the thing installed? That's the last column. The treatment estimates are smaller because it's not operational all the time, but we still see significant reductions in, again, electricity consumption, electricity costs, and carbon emissions. If you're concerned about selection of plants into the first phase where they had to volunteer, we also look at outcomes in the first versus second wave of the program. And generally the pattern is the first wave. We have fewer plants, we have less precision. The treatment estimates are slightly bigger, but if you squint, the order of magnitude of the treatment effects is similar between the first and second wave. All right. Sorry. Okay, great. So one of the mechanisms that the AI tool works is it helps shift energy consumption from peak to off-peak hours. And I actually want to start with the raw data because I think it also illustrates the fact that the AI tool is more forward-looking than the threshold-based control. So this is the weighted average electricity consumption over hours of the day, normalized with and without AI. And we also have the lines that indicate whether we're in peak or off-peak electricity pricing. And so what you see in the blue line is that electricity consumption goes down disproportionately during peak pricing, but we also see this anticipatory effect of a kink right before the switch to peak pricing, and then a decrease in electricity consumption right before the peak switch to off-peak pricing, which is a forward-looking response that, again, you don't see in the conventionally managed wastewater treatment plants that have these reactive threshold-based systems. All right. So as a result, we see reductions in both. This is a different to Rob Metcalf's setting. We see reductions in both, but they're larger in peak hours. Okay, super. So then thinking about, again, sort of the net energy balance of AI we have in this setting, so far it's just 1 month actually of energy consumption from the AI services provider. We think it's still conservative because we observe the energy required to produce all of their AI services for all of their customers, not just the plants that we study downstream, but they've also told us they'll give us a longer time series. But if we take even just the peak power for all of those different plants and extrapolate the upstream energy consumption required to produce AI services is less than 1% of the downstream energy service savings in our setting. All right. So before concluding, there's two other parts of the analysis I want to share. So one question we had is, how does the AI respond to shocks, to unusual conditions? Because it's all well and good to have a system that works better on average, but is it maybe going to be worse at dealing with extreme events? And so we look at how both AI managed and conventionally managed wastewater treatment plants respond to extreme or heavy precipitation events. So here, this is residualized hourly energy consumption of plants under AI management or not. Leading up to and including a heavy rainfall event, which we define as 30 to 55 millimeters falling within an hour. So you see, before the heavy rain event, the AI tool, we have lower energy consumption. But then when heavy precipitation event occurs, the AI steps on the gas pedal more. It is more aggressive in responding to the extreme rainfall event than the conventionally managed plant. So you have a peak and increase in electricity consumption. However, this more aggressive initial response also allows the AI tool to then decrease energy consumption again faster, whereas in the conventionally managed tools, the sort of impulse response of the shock, you have elevated energy consumption for longer in dealing with the fallout of the shock. So when we look at this more formally, this is now a two-way fixed effects regression where we look at the effect of extreme rainfall and the differential effect of extreme rainfall in plants that are AI managed or not. We have the following set of results. So on the left panel, we're looking at the hourly level. And the x-axis is we consider different thresholds for what's a heavy rainfall event. Depending on where you are, you might want to use a different threshold. But so generally what we see in blue is that heavy precipitation leads to increases in energy consumption in wastewater treatment. And at the hourly level, initially, this effect is bigger for AI managed plants. So again, this is consistent with the pattern in the raw data that the AI responds more aggressively to a rainfall event. When we then zoom out and look over the course of a whole day, that's the panel on the right, we see that at the daily level, conventionally managed plants increase in energy consumption from extreme rainfall, but the AI can undo this. It can basically avoid it. So then the AI managed plants at the daily level, if you had an hour of heavy rainfall, have lower energy consumption than the conventionally managed plants. All right. And so last but certainly not least, this is all well and good, but are these reductions in energy and emissions coming at the cost of worse water quality? Right, is a question, risk you might be concerned about. And so just to be clear, we don't have data on all water quality measures you might care about. But for the ones that we do observe, we actually see an improvement in effluent water quality as a result of the plant falling under AI management. So in particular, what we see is that both nitrate and ammonium concentrations are lower at effluent as a result of the aeration being managed by AI. And do I have time? I think I do. Okay. And the reason why, we have some water experts in the room who can maybe add more to this, but the reason why I think it's especially interesting that we see reductions in both nitrate and ammonium is you could easily see how if the technology was being clumsy, you might get a reduction in one at the expense of the other, right? So for example, if we go back to the job of aeration, if AI just said, well, you know what, we're just going to aerate less, okay? Save some energy, we might expect a reduction in nitrate at the expense of having more ammonium. But we end up seeing a reduction in both, which really suggests that ultimately the AI tool just solves this dynamic optimization problem better than we did before. Right? It just does a better job at this optimization problem than we previously have been doing. All right. So to conclude, just to recap, using high-frequency data from a fleet of wastewater management treatment plants, we find that an AI-driven digital twinning solution leads to sustained reductions in energy consumption, energy costs, and carbon emissions, and even improvements in some dimensions of water quality, and the plants are better at dealing with extreme events. Okay. Initial suggestive data further suggests that these savings are much bigger than the upstream cost of producing the AI services. So as a final, admittedly somewhat heroic, but we think it's still interesting exercise, we wanted to go back to the question of so is this just how significant is this if we zoom out a little bit? So we do two exercises where we either extrapolate the empirical results magically to all wastewater treatment plants globally, okay, and just improve their energy efficiency and reduce their CO2 intensity accordingly. Or we extrapolate these findings to all of the processes for which the AI startup we work with has developed solutions, not even all, a subset of the ones where they've developed similar tools. So wastewater treatment, industrial drying, and steel galvanization. And so then putting both the reductions in CO2 intensity and the improvements in energy efficiency in the DICE model, we estimate present value global welfare gains of 180 billion to $1.8 trillion. Obviously, that's too big. We're ignoring lots of technical issues and compatibility issues. But I think it signals the fact to us, what we take away from it is that there's large potential welfare gains, maybe not that large, but likely large, of rolling out these kind of energy efficiency improving technologies to a broader set of the industrial sector. And with that, I look forward to Mert's comments. Thank you.
Great. Thank you, Lynn. Now we have a discussion from Mert.
Thanks for the opportunity to discuss this paper. I think this is a exceptionally clean and well executed paper that contributes to both the AI literature and also environmental economics literature. So it's hard to find these clean papers in the AI literature. So I really enjoyed reading it. But what I'm going to do in my discussion is I'm going to talk a little bit about how we should think about AI in this context, and I'm going to have a couple of comments on the paper. So here, what you see is the share of NBER papers that are on generative AI. So as you can see, after ChatGPT, there has been a huge explosion of on generative AI papers, and today 6% of the NBER papers are on generative AI. But we also have predictive AI, and this actually goes a lot further back than generative AI. And it's actually not insignificant, around 3% of the papers today on predictive AI. So even though there's a lot of emphasis on generative AI today, I think predictive AI is as important as generative AI in terms of its implications. What are the differences between the two? For generative AI, it generates the text, images, code. We all use it now. It's very new, at least the way we use it. And most of the focus in the literature is on the knowledge work. Whereas with predictive AI, it predicts some outcomes for a defined task. It's more established, many firms are already using in different forms. And there are many use cases, and in particular in manufacturing, it is particularly important. But this paper is about predictive AI, it's not generative AI. And I think this is a feature, not a bug, because if you look at the studies on generative AI, it's very hard to find very clean measurement, the productivity measure, and the setting. Whereas in predictive AI, if you think about different industries, like this industry, there's a very clean setting, clean measurement that is important for us to understand how AI is affecting different things. So in that sense, this is a really excellent study of predictive AI at work. But why does predictive AI create value? Just to put in some context, in many production settings, there is a decision maker deciding how much resources to allocate to the production setting. And the decision maker observes a signal and either ex post over provision or under provision. And if it is over provisioned, there will be wasted resources. If it is under provision, there will be some failures. And if the decision maker is a risk averse, the fear of failures will outweigh the potential waste, but there will be over provision, which will lead to waste and which will lead to potential externality. So this is the exact mechanism that is happening in the paper. That's why there is so much electricity consumption in this industry. And this is not specific to this setting. So you can think of any setting where a decision maker decides how much resources to allocate, you will likely observe these over provisions. So for example, in a recent paper, I studied data centers, and I have showed that there are so many over provision and idle servers that is on the order of several $100 billion. So this is a very general problem across different settings. But why is predictive AI useful in this setting? Because predictive AI can give you more precise signal using different forms of data sets. So suppose you are the decision maker and this is your prior belief. So if you are risk averse, how much resources you allocate will be on the right side of this distribution. So predictive AI comes in, it gives you a more precise signal, so it is less dispersed. Now you are going to allocate less resources and you are going to save resources. This is again how predictive AI works in this paper's setting. And again, this is not specific to this setting. Any production process where you obtain better signal, you are going to reduce waste and you are going to reduce externalities. So I think this paper is it's a unique combination of like many different nice features. There's a very clear productivity measure. They can like to measure in like the 15-minute level. It quantifies both cost and benefit. This is again like the very rare. It's a narrow, well-defined setting. So I'm an AI economist. I really like these like the narrow settings. It's a very clean quasi-experiment. So I think in that sense, like this is a very unique combination that you don't tend to see in AI setting. So in terms of my comments are going to be about how we can move, how the authors can move beyond the quantification exercise. So if you do research on AI today, you write a paper, you study an interesting like model or interesting setting, you find a really cool result, and then you present your results, and then so like this is going to change in a few months. So like what do we learn from this? So this is, I think, like everyone who studies AI like think about constantly. So how to get around that, you can find more like general conclusions about the impact of AI, for example, like potential barriers, like the diffusion, or like the mechanisms, or you can do some projections for the future. I think in this paper, the authors, they have like the data and the setting to really push these potential directions, because I think the setting they have, they can go beyond this, like the quantification of the productivity effect in this single setting. I'm going to give you like the three suggestions. The first one is, even though the paper is like extremely careful about the monetary cost and benefit of this technology, we know that oftentimes the real cost is actually organizational cost. Like we have several papers showing that new technologies require organizational risk structure, organizational complementary cost. So in that sense, implementing these technologies are not easy, and oftentimes the electricity that you use is not the actual cost. It is like the bigger like personal cost or the organizational disruption cost. And when you look at the paper, you already see the hints of this in many different places. The first one is that the failure rate. So AI gets deactivated around 30% of the time, sometimes for like technical reasons, sometimes for like the manually by the personnel. But actually, like I had a hard time like thinking about like why would lead to 30% failure rate given that you set up this technology. And even more interesting, if you look at the failure rate, it's pretty much constant. And even in a 2.5-year period. So there doesn't seem to be like learning by doing here. I would have expected the failure rate is going to go down like significantly over time. And moreover, when AI fails, meaning that AI gets deactivated, actually these plans do worse than plans they don't have AI. So this is some rebound effect. Or they save a lot of resources when AI is active. When AI is not active, then they lose. They are actually worse than plans without AI. I think like all of these are actually really interesting. It suggests that this is a technology where there is also many frictions, like many different costs. And I think thinking about these, like I don't know what data they have maybe on like the personnel or like the deactivation of AI or like different disruptions. I think it will be really interesting to understand what are the barriers against like the adoption, this high failure rate, to inform us more generally about like what challenges firms face when use AI. And my second comment is like trying to understand the mechanism a little bit better. Going back to the simple framework I showed you, there's actually three ways AI is helping. The first one is like how risk averse the decision maker is. Like the most risk averse the decision maker is, I think the more benefit of AI. How much more precise the AI signal relative to the before, because the more precise the AI is, the more benefit here. And finally, this like the peak allocation, it depends on state dependence. I think the paper talks about these mechanisms briefly, but they don't do any analysis of them. They don't quantify them. I think maybe like thinking about this in a more like the formal framework and thinking about these mechanisms and the role of them will be like very, very interesting. I think the third comment is, how much of the potential today's AI capture really in this setting? And I think one really interesting plot, this is, I think, in the appendix that I found. So here you see the optimal range and the too much resources, too much oxygen, and too little oxygen. So you see like the never AI plans and the post AI plans. As you can see, the distribution shifts towards like the optimal range, but only a little bit, right? There is still so much mess on the too much oxygen side. So this means that if an AI technology comes like a year later, which is much better than this technology, there's going to be a lot higher cost savings. I think the authors, they can maybe think about like what will happen if they double the precision of this AI tool, like how much resources will be saved, and it will speak to the future potential of AI as the technologies develop. Just to summarize, I really enjoy this paper. It's an excellent paper contributing to AI literature in a significant way. Thank you.
Great. Thank you, Lynn. While you respond, others can line up for questions.
All right. Well, thank you so much for this fabulous discussion. Let me take a couple of the points. So I think first interesting, I forget it was Jim yesterday who said, why don't we study the industrial policy that didn't work? Maybe it's more interesting to look at we focus sort of on the things that work because we're kind of, yeah, it seemed exciting, but the point is very well taken to think more about the things that didn't work. Briefly, Mert commented on, we have this, we check for, so it's not a rebound effect in the traditional energy economic sense, but we check whether the plants that have had AI installed, when the AI is not operational, as Mert's graph showed, they do worse on energy efficiency. And you could think this happens, for example, if the manager has less experience, they sort of get used to relying on the AI, they're less focused, right? Comes up in like medical AI reliance evaluations. I saw a scary paper once about respirators. Anyway, so we do have that finding. It does when we control for whether the AI failure was endogenous in the sense of being plant initiated, that becomes attenuated, that effect, but that doesn't answer the question as the why. So I think what we need to understand better is why are folks turning off the AI and what role does that play? So that point is very well taken. Then also in terms of, we don't have heterogeneity by sort of plant manager characteristics. So I was kind of briefly thinking, wouldn't it be fun if we went and played some games and elicited risk aversion? But what we did look at heterogeneity in effects by how efficient or not the plant was before the AI was installed. So were you a very energy efficient plant or not? Which, if we think that energy efficiency is a reverse proxy for risk aversion, and what we find is that for the most energy efficient plants, you fail to detect an effect of the AI technology. It's really only the ones that were not so efficient. So maybe that goes a little bit in this direction, but we should absolutely think about it more. So I think I'll leave it there, but thanks so much. Fabulous suggestions. Thank you.
All right.
I'm sorry if this is a question that it's obvious for water people, but I was wondering, you keep saying that it was not threshold-based, it was threshold-based optimization before, but in some way there is a natural threshold due to the regulation on the water quality that comes out of the plant. I was wondering, what are the costs associated of not meeting this threshold, for example, that might be way bigger than the electricity cost? And that's related to Matt's question. And if it is, in some ways, the performance, the overachieving it's not really useful for the firm, right? So how do you think about that?
Okay, this is 100% my communication failure. There's different thresholds involved. So there's the regulatory thresholds that the effluent needs to meet. Those are, we're not abandoning those at all. It's more that some of the automated control systems in the plants pre-AI would have thresholds in the decision-making for how long and how much aeration to use. So it's like, if dissolved oxygen moves over this threshold, then turn on this aeration for X amount of time. So the threshold approach we're moving away from is more in how much we aerate and not in regulatory thresholds that we're still trying to meet with the effluent.
What I meant was just like there is a threshold of quality that you have to meet. It doesn't lead to anything to go beyond that. Basically, this is not like a profit-making operation to try to get better water quality. And the risks are really high if you don't meet the quality. So how do you think about that element?
I see. But So so we have this stylized model, which gets a little bit at what Mert was saying over the incentives for the plant managers. And then sort of the asymmetry of the loss function becomes important in the prediction. In practice in France, our understanding of the regulatory environment is it's not actually, if you have a one-off violation, that there's necessarily going to be a steep penalty, right? It's sort of a graduated approach. So I think maybe the social planner would view differently than the manager incentives, but I think I'm rambling, so I'm just going to stop, say thanks. We're going to think about it. Edson.
Yeah, really interesting paper. And I think another version of that question, actually, because I was trying to understand how the predictive AI tool was developed. And I'm assuming there was some training, and how did they implement before they deployed in this plans? And what was the goal there in this training exercise? Because if it is to meet the regulatory standards, it's minimizing the costs under that particular regulatory. So I was wondering how that implies. So you were showing the effects on the water quality at the end, but I was just like, isn't that the goal for the tool that was developed to reach that particular quality? So isn't it like what we would expect, or we should expect, if the tool was trained to maintain the water quality? And so like just a little bit background on how that tool was developed would be interesting. And I think relatedly, so you showed us at the end the back of the envelope calculation, which I liked, but I want to just bring back, like you showed the first phase, the second phase, and it's like pretty similar, but it's slightly smaller. So I was wondering if you could just do 50 plants at a time, just to see if there is a trend there or not, because then it kind of like back up your calculations if it's kind of stable, or if it is like an issue of site selection. And so, and then like as you are deploying, it's going to be a reduced effect over time.
Yeah, thank you. So 50 plants at a time, that sounds great. We will do that. In terms of shouldn't we expect water quality improvements? I think not necessarily. So if we were meeting the regulatory requirement perfectly always before, and then it could be we're just reducing energy consumption while continuing to meet the threshold, we wouldn't necessarily see a change in the average effluent quality. We have a version of these regressions where we look at the probability of being within the regulatory threshold in the effluent, and that goes up, I think. But so I think how we think about that depends on how much we were meeting or not meeting the regulatory thresholds before the AI was installed. But for extrapolation, looking at these effects, yes, excellent suggestion. Thank you. Yes, Jim.
Great paper. Really enjoyed seeing it. I'm wrestling with what the bigger implications are, and I think you kind of hint at the idea of like, look, it's much more energy saved than used for this application, but I don't think that carries too much weight, because there's an application where the AI is supposed to be saving energy, and in other settings it's not. So I was looking for some of the more durable implications. And one thing I guess goes back to the threshold, also wondering, when we're doing optimal thresholds, they depend on costs and benefits. And so if the cost of meeting the threshold's gotten better because of the deployment of the AI, then I think the optimal threshold would tighten as well. And it's something you might think about, whether there's a sort of policy interaction that might be a more durable insight that applies elsewhere.
Super interesting point. Yes, thank you. Agreed.
Yeah.
Right.
Like Jim, I'm also interested in like how we think about this in terms of generalization. You hinted at it on the last slide with sort of external validity, and what's kind of like Mert. So it seems like trying to do things to unpack mechanisms is potentially helpful. Like, and I feel like the presentation and the paper point to at least like 3 things going on. Like there's clearly like one dimension where the AI is clearly grabbing more information than the human managers were. Like I found the result about sort of like time of day electricity pricing or hourly electricity pricing really interesting. Like somebody was missing something really obvious of like, you should run the plant more before electricity prices spike, which like had I sent the McKinsey consultant in there for a day, they probably would have figured that out. Like you don't necessarily need AI to do that. And we know there's low-hanging fruit in lots of settings. Like there's the whole Nick Bloom, John Van Reenen suite of papers. Like there's something there. And like, it seems like that's pretty common in manufacturing. This is maybe one way to overcome that. there's like another dimension, like there's a dynamic optimization going on. There's just a sense in which like doing these things properly is really hard and you need a fancy algorithm to do it that humans aren't really good at, just sort of manually with heuristics. That seems sensible. And then like on this risk aversion or agency problem part, like sort of like the person at the controls is being too risk averse or too cautious or something like that. That's something we've seen in other papers, other settings. I have an old paper on that. The degree to which AI solves that is, I think, only happens to the sense in which like somebody has to give the AI an objective function. Edson was kind of asking about this too. Like what, like we can tell the AI to like predict things properly and then make decisions in a risk averse way or do it in a risk neutral way or have some asymmetric loss function, whatever it is. Like it would be useful to know more about just what exactly the AI's objective function was. Like some human must have told it to do something. What was it?
Yes, so thanks, all excellent comments, and we'll look at the papers. The objective was to minimize electricity costs subject to operational and effluent quality constraints. But of course, one could point that tool theoretically in other directions as well, or put other bounds or other things, absolutely. Yeah.
I have a much more boring econometric suggestion. I think it's helpful. It would be helpful if you can maybe describe a bit more. By the way, I like the paper a lot. What is the exogenous variation you're using and what can be endogenous variation you're using? So I think you can ask correctly. The main variation you're using is the staggered rollout timing. So you can explain a bit more like why can we believe the timing was plausibly exogenous? Suppose that's true. And then I think the next variation you're using is a switch on and off. But that might be a little endogenous choice of the plant operator. And the next variation you're using is how much AI they use, the electricity usage. That's column 1 and 2 of your table. So if those two are a little endogenous, I think more appropriate way is IB, using the first one as an instrument to do the IB, if I understand correctly. So you could try that. Or you could argue the switch on and off is also plausibly exogenous and also usage of AI is plausibly exogenous, then your OLS is totally okay. But maybe it's helpful to try or explain this point more.
Absolutely. Thank you. So in terms of the, let me answer the easiest part first, which is the interruptions. We have some information on why the interruptions occur. So we can tell whether the local plant chose to deactivate the AI. We can tell whether the AI operator chose to not provide the AI service or whether it's something else, which in discussions with the company, they tell us it's a sensor malfunction, its outage is more likely to be exogenous. And when we change the sample to relying more on those more likely to be exogenous interruptions, the results are pretty similar, which gives us some confidence along with the staggered rollout timing without using the intensive margin variation at all. So that makes us feel better. Of course, the overall point is well taken, and we'll think about an IB. I do think though, so I worry more about the endogeneity of the timing of which plants were opted in the first phase, but right now they're just rolling it out to all of the plants in this size and technical eligibility category. So now it's just there's a schedule and all of them are going to be opted in so I'm less worried in the second part, but we'll test the 50 at a time to make sure. Rob. Sorry.
So great work, really interesting stuff. I had some thoughts about whether the training period seemed it was way shorter than a year, right? So I guess there was like some variation in terms of the seasonality when the AI was trained. So if you're trained during the summer or in the winter, do you do worse off during like conditions that you weren't trained on? And I wonder also in terms of the inputs that the AI model has, is it being fed with forecasts? And then it's like if like a big forecasting error means more like the AI becomes over reliant on that and over interprets what the forecast is versus like a human operator. And maybe that could explain that. And at the end, you showed us something about the water quality parameters, and that was like pooled all of the hours, all of the days together. I wonder if there are like during times of the day or like a day-to-day variation in terms of like how close to target or off target, and maybe like there's some optimal strategy of like a mixed model of like on days with word conditions that the model hasn't seen a lot, maybe there's like better to shift back to manual control until there's some learning by doing and the AI becomes more confident in its predictions on taking full control. And those are my thoughts. Really cool work.
Super. Thank you so much. So that's a great suggestion to look at how, when you were trained, how maybe we do in plants that were trained in summer versus winter. It is worth saying though, the AI training, that's just the local control mode. The algorithm keeps updating continuously. So it keeps refining its prediction for each plant as time goes on, using the data that it gets in all the time. But that being said, some conditions will be more out of sample, especially in the first year compared to later years. And then there was one, sorry, what was the second thing you said? Oh, yes. So I didn't have a chance to say those are weekly or a little more than weekly readings. So again, we don't observe in real time all of those water quality measures of the effluent. So we're a little bit limited in what we can do there.
So a thought on generalizing the results, or the ability to generalize the results, which I hope will also generalize a couple of the comments that have been made so far. The way I think about this at a high level is this is doing a better job of dynamic optimization, but it's doing a better job of dynamic optimization for a private objective function. And we're interested in whether it's going to be doing a better job of optimizing a social objective function. And the extent to which those are aligned depends on whether the incentives are aligned. This is a situation where you don't have perfect pricing, but you actually have a correlation between the thing that saves money for the company also reduces the externalities. And as a result, the social gain is bigger than the private gain from that improved optimization. If you were in a different situation where the correlation went the other way, you might have something that saves money for the company and worsens externalities or worsens some other market failure. But if things are priced properly, then you'll actually align these things. So whether better optimization is a good thing or not, it kind of depends. But that, I think, is an interesting result in and of itself. So thank you.
Super comment. Thank you. So obviously and this is something that's come up, the extent to which the incentive to reduce electricity costs aligns with it depends on how carbon was. And we're in France here, right? The electricity is pretty clean already. We're in the EU ETS. We've thought about, because we looked a little bit at how the AI changes the price sensitivity of the plant, and it increases it a lot. And so one could envision doing a back of the envelope if electricity prices reflect social costs or not. Or also in other, if this were used in Germany, where the off-peak versus peak carbon intensity is very different, one could, since we're already doing heroic back of the envelopes, we could add some about in a different system with different, where, again, prices are better or worse in aligning with social costs. Yes, thank you. Arik?
Maybe I'm just repeating or following up on prior questions, but I don't understand. If the AI is trained to save electricity costs subject to a water quality threshold, and the humans were meeting that water quality threshold before, then how can I would assume that the AI would save electricity by getting closer to the water quality threshold, which means that pollution would be going up. So I don't understand the result that you get at the end, which is improved water quality.
Yes, so I think, again, we don't have the data on biological and chemical oxygen demand, which is where I would suspect. So I think your argument, the assumption is implicit in that assumption is the fact that more of the energy intensive process leads to better water quality. And that's.
So instead of electricity, but there's more pollution.
They weren't necessarily over complying on all the effluent pollutants though. So again, if we think about nitrate and ammonia, if I was doing a worse job in the dynamic optimization, I may have over aerated because I was worried about BOD and COD, but then that would lead to potentially excess nitrate, right? If I don't have enough anoxic condition. And so because it's not the mapping between energy use and overcompliance is not the same for all of the pollutants, I think that argument holds for some, but not for all of them, is my sense. But excellent point. Yes.
Well-timed, shameless self-promotion. I have an old paper with Michael Ward that looks exactly at that jointness and pollution production and its implications for overcompliance. But that's not why I'm here. I also was interested in the broader significance issue, and I'm curious as to what we think the implications of the fact that almost all of these are municipally owned, or maybe all of them rather than privately owned. And in the US, this particular sector is famous for exceptional turnover in personnel and being very far away from operational efficiency on many dimensions. And I'm curious if in the US, the context would be where the human counterfactual is really, really crappy, pardon my language. And so the benefits would be enormous in that particular context. So I'm just curious as to whether that holds in your story as well. Thank you.
All right, so thanks for the paper. We'll definitely look at it. That's useful. They're privately operated, these wastewater treatment plants, under contract, I believe, from the municipalities, but it's a private for-profit company that's operating them. As far as personal we've been interested in many dimensions of getting data on personnel, also to see the staffing is some of the endogeneity due to you have fewer staff, but there's more sensitivity to those data, so we haven't gotten. I don't think we will. But we'll certainly, we might be able to get some answers about turnover or average tenure, maybe some aggregate statistics to think about that more. Thanks.
So very interesting stuff. Thanks for the paper. Probably this is just a rephrase of the discussion, but let me just ask it anyway. Can you just tell us a bit more about what AI does exactly? So let's think about this precision of the signal, right? Can humans improve this signal precision? Because if this is the case, then it becomes just a cost and kind of benefit analysis, right? So it just kind of moves the financial constraint. But maybe AI does something that we humans cannot do. Because if this is the case, then the production function changes itself. So is it possible to tell which is which?
I think I want to think about, I don't want to give a rambling speculative answer. I think I want to think about it. Is there room for improvement from the human operators? Again, we find some dispersion in the initial energy efficiency. Does that necessarily mean that it was inefficient before? It's not clear, right? If you're in a place with more variance where the loss function is steeper, maybe it was optimal. So I think how much of this could be done by humans or other systems, we have to think about it more carefully, but point well taken.
Great paper, Linda. I loved seeing it again. My main question, I think we've talked about this once before a little bit, but really dovetails on what Edson and Ryan brought up about the objective function. And I think one of the things that highlighted it for me this time as I was thinking about it was this difference in energy prices from the peak and off peak. So these firms, they're private firms, have a very clear incentive to want to save money by optimizing over that. And maybe they have a lot of turnover, maybe they're crappy in the way that they're done. I doubt that, but some of them must have some experience. So it's really surprising to me that this wasn't optimized at all in the past, or optimized very poorly in the past, maybe. And so it does get to this question about, is the objective function different, or is the AI doing something? It relates to the last question. Is the AI really doing something that's distinctly different that humans just can't do? And that actually, I wonder whether you can, and if you have talked to some people in some of these plants, or could talk to some people in these plants, to give a real sense and get some, even if it's anecdotal, to get some kind of on the ground understanding about what people are really thinking about when they're doing this process and what they feel AI has been doing differently.
Thank you. Yeah, and I think you put it in a way that's very, very clear. How much of this is the change in the objective function versus the change in the technology we use to achieve that objective, right? We've asked, but I think we'll ask again to get a clear sense, and maybe also talk to some actual planet managers. But I just the folks that are a partner, they've been wonderful. They're very committed to this. So I just want to say that, because there was some language used that, these are folks who are trying really hard to do a good job. So all right, thank you so much.
All right, we're going to break for 30 minutes and reconvene at 3:35 to hear about trading trash on tricycles.
Just four very short announcements that will not take your time. First, very quick, thank you to the organizers who did an outstanding job putting together the program, so thanks to you. Second, a reminder from the NBER, if you are an NBER affiliate and you're putting together a grant proposal to federal or to any grant proposal, and you're looking for good grant support, NBER is excellent. So I encourage you to keep that in mind as you're preparing your next projects. Third, great workshops coming up, both climate finance in October, and ag economic measurement in November, and energy markets and macro. Thanks again to Lint in December. So look out for those. And I think that's all the announcements I have. So thanks very much. Oh, finally, if you have comments, feedback on this meeting, please feel free to send them to Chris and I. These meetings run well because we've had good feedback from past participants. If you have ideas, don't hesitate to share them. So thank you.
Great. Thank you, Meredith. Ignacio, take it away.
Great, perfect. Thank you very much. I'm Ignacio Bañares Sanchez. I'm about to finish at LSE and I'll be joining Berkeley RE very soon. And this is joint work with Yoshiki Wiskamp at the LSE. He's on the market this year and he is fantastic. And our paper is called Trading Trash on Tricycles. So let me start unpacking the alliteration. This is the Akpo-Blosi Seekens dam site and it's located in the very center of Accra, the capital of Ghana. And currently more than half of the waste produced by households in the city ends up in uncontrolled illegal dam sites like Akpo-Blosi Seekens. Around the world, around 40% of waste still ends up at open dam sites as final disposal. And in sub-Saharan Africa in particular, the statistic is even more acute. 86% of waste remains uncontrolled, which means that it's either not collected from households or is collected, but then disposed of at illegal dam sites like Akpo-Blosi Seekens. And these dam sites generate large environmental and health damages, making waste disposal and controlled waste disposal a clear demon of density. These externalities are manifold: air pollution when waste is burnt, like in the picture that I just showed you, greenhouse gas emissions of various kinds, the degradation of groundwater and soil. Dam sites also favor the spread of infectious diseases, and trash that ends up choking the gutters of cities like Accra is behind the numerous episodes of chronic flooding that the city experiences every time there's heavy rains. So how is waste managed? Why is ending up disposed of at these sites? Well, the first fact that we need to realize is that in cities like Accra, in low and middle income countries, much of door-to-door collection is de facto run by informal workers in a market-based system. It's fully decentralized. The municipal government doesn't reach most households in their municipal waste management services. And these informal workers then rely as well for disposal on uncontrolled dam sites, which are also managed privately and informally. Currently in Accra, tricycle collectors collect from more than 70% of households in the city. And most of these tricycle collectors disposed of at places at open dam sites like Akpo-Blosi Seekens, which receive around 60% of total waste at the moment. This is a picture of the tricycles that these informal bola taxis, they're called in Accra, that they use to roam around the city and collect waste daily from customers. So why is waste managed in this way in cities like Accra? The way cities in low and middle income countries manage their trash is emblematic of a much broader regulatory challenge. We know that the key to unlocking the potential of cities is to tame the demons of density, these large congesting forces, but this is really hard to do under weak institutions and limited fiscal capacity. First of all, under weak institutions, it's really going to be hard to enforce any form of bans or Pigouvian policies. We cannot just decommission these uncontrolled dam sites. We cannot tax them to increase the price that collectors have to pay. We also cannot ban collectors from visiting these sites. We cannot tax households for burning their trash. At the same time, limited fiscal capacity makes it very hard to fund the necessary infrastructure and management for effective public service delivery. In the case of trash, this involves a fleet of compaction trucks and a network of engineered landfills. So as a result of these twin challenges, what happens is that in developing cities, informal decentralized solutions have emerged to tackle challenges like trash collection, transportation, sanitation more broadly, or the provision of clean water. And these markets, these informal solutions, provide private value. I told you that 70% of houses in the city are paying these tricycle collectors to remove waste from their house, from their backyards. But they leave externalities largely unaddressed. And the case of Accra is quite clear in this setting. Collectors are removing waste from households. They're getting a fee for that service, but they're displacing the externality, the damages, to the outskirts of the city, to these big illegal dump sites where waste pollution damages still take place. So what we're going to think of in this paper, very broadly, is whether in this second best policy scenario, when we don't have the full policy toolbox at our disposal to regulate these externalities or provide public service delivery, can we still leverage these informal markets, these decentralized solutions that have emerged, to provide public services at scale? So how close and at what cost can regulation, feasible regulation, gets us to a notion of social optimum that takes into account the social costs of uncontrolled trash disposal? We're going to do so through an application to Accra's informal waste market. So let me tell you a little bit about the structure of this market, such that ideas are clear. Households are the producers of trash, and in order to dispose of the trash they produce, they have several options available. They can pay a fee to the government municipal service. This service is quite limited at the moment. It reaches around 10 to 20% of houses in the city clustered around richer areas near the airport. They can always use this service and pay a fee. Alternatively, they can pay a fee to the informal workers, the Bola taxis. Bola means waste, and they really operate as a taxi. They're always roaming around. Whenever you need them, you raise your hand and they're going to be there to pick up your trash for a fee that you bargain. Alternatively, households can choose not to pay to discard, to dump, to dispose of their trash, but instead burn the trash or dump it in an uncontrolled manner in the streets or often in the open gutters near a household. And this is going to generate, of course, some local environmental damages. This is the collection side of the market and what happens on the disposal side. First, the government services, the government licenses to a private company, the management of waste transfer stations. These are engineered facilities which objective is to control pollution. These are fully paved, they compact waste, and they send it via compaction trucks to engineered landfills far away from the city center. This is the way that the government has to control pollution at disposal. Of course, the formal government trucks always disposed of trash at the transfer stations. And these informal workers, the Bola taxis, have two options. They can travel to the government waste facilities and pay a fee to dispose of the trash they collect, or they can go to the uncontrolled dump sites and pay a fee to dispose of the trash they collect. So you can see that these two prices, the price on the collection side of the market, on the disposal side of the market, are going to determine the amount of waste pollution in the city, both locally in the neighborhoods of Accra and at uncontrolled dump sites. So the specific counterfactual questions of interest that we're going to ask in this paper are the following. What level of environmental quality can we achieve with feasible environmental policies? Feasible environmental policies, recall that I told you that the twin challenge makes it very hard for governments to raise the price of uncontrolled dump sites, to increase the price of burning or dumping. And the government is going to be limited in what they can do there. But the government can always lower the price at the formal government transfer stations to try to get that price right and leverage the existing market for collection and disposal. And the government is also thinking of expanding the availability of waste transfer stations throughout the city. So this is why we're going to think of feasible policies in this setting. And this question is really going to boil down to understanding how the market, so how households, waste collectors, and dump sites respond to feasible policies. Great. So how are we going to answer these questions? The first challenge that we face is one of data availability. This is a market that is largely informal and relies on illegal activity at dump sites. So at the start of the project, there was some rough assessment of the number of waste collectors operating in the city and aggregate census statistics on the share of households paying for waste collection services, but that was about it. So the first thing that we're going to do is we're going to gather primary data that we collect throughout every single box in this diagram with households, with collectors, and at dump sites and transfer stations. And this new primary data that I describe in a minute allows us to describe quantitatively and for the first time the structure of this market. How do patterns of access look like throughout the city? How does pollution look like near households in Accra? What is the market structure on the collection side and on the disposal side? And based on the facts that we gather with this new primary data, we're going to build and estimate a structural model of waste collection, transport, and final disposal, which is going to allow us to test these counterfactual policies that are going to determine the amount of waste pollution in the city. Great, so let me show you first our data collection exercises. First, we turn to the demand for waste collection, and we're going to survey households in the main city of Accra, which is the triangle that you observe in red in the bottom of this figure. This figure represents the whole Greater Accra metropolitan area in white, and in gray you have the settled area according to the Global Human Settlements layer. This is the main city of Accra in red, and the polygons in red indicate the 150 census enumeration areas where we go and survey a total of 1,800 households. We're going to ask them about their waste disposal choices and the determinants of this choice, and we're going to embed 3 survey experiments: a BDM elicitation exercise, a take it or leave it, and a stated preferences survey to estimate the demand for waste disposal. I'll explain that later on. To get an idea of these local waste pollution damages, we also took a total of 6,000 of waste pollution pictures of the open gutters near houses in our sample, which we manually classify to get an objective measure of waste pollution. Then we correlate with outcomes that we gather in our survey to get an idea of these local health damages. Then we turn to the supply of waste disposal. The first thing that we had to do is discover or get an idea of which uncontrolled dump sites were operating in the city and which transfer stations. So we did a pilot with 60 of the Bola taxis. We searched government documents and we visited every possible disposal site in the city. And we counted in a given day the number of Bola taxis, of waste collectors arriving, to get an idea of the market share on the disposal side of the market. And that's how we observed that most of the waste was arriving to uncontrolled sites. The uncontrolled open dump sites are highlighted as the red bubbles, with the radius representing the flow of waste collectors that receive in a day. And the government waste facilities are the 3 blue bubbles, one in the center, very close to an illegal dump sites, and the 2 on the top right of the Greater Accra metropolitan area. At these sites, and based on these shares, we conducted surveys with a total of 400 of these informal waste collectors that disposed of at these waste facilities. And we asked them about the area in the city, the locality where they collect waste, their choice about a disposal site, and what were the key attributes. That's how we learned about the price charged by the illegal dump sites and other characteristics. What I'm showing you here in the image is the localities in Greater Accra where collectors report operating, going to pick up waste from customers. And you can see that with our survey, which amounts to around 20% of the total number of waste collectors in the city, we cover most of the settled area in the metropolitan area. We complement this data with new transaction data that we gather through a smartphone app that we develop. We incentivize collectors to use a very, very simple application. You can see it here. Collectors had to record just the price of the waste collection transaction when they were picking up waste from a customer. So every point that you see in this image is a waste collection transaction between a collector and a customer at the customer's home location. And you can see that the geolocated transactions line up very well spatially with the collection areas that collectors report in our survey. This data is going to be very useful to understand the collectors' routes and some patterns of the structure of the market on the disposal side. Great. So now, equipped with this data, we build a spatial model of informal waste markets. The first agent in the model are households who are making this discrete choice, as explained before, across the formal waste collection system, the informal boiler taxis, or burning or dumping their trash. They're going to choose among these waste disposal options based on attributes such as the price, the frequency of access, any other characteristics like wait time, or sorting requirements. And we assume a very simple logic formulation. So a household I in area of the city A derives utility from choosing option O, which has a fixed component, and then the rest is going to depend on the price, the frequency, and the waiting time, and we allow for idiosyncratic gamble shocks. The logit cells are going to allow us to compute the amount of trash that ends up dumped or burned in the streets of the city. So this is the share of households in area A that chooses to burn or dump their trash based on the distribution of population across the city, and a parameter that translates a ton of waste or a kilogram of waste into a social cost. We can get an idea of this social cost that uncontrolled trash represents in the neighborhoods of the city. I'll explain a little bit later at the end, if I have time, how we calibrate that parameter. We do that through the pictures that we took. Great. But let me now tell you how we estimate the key economic elasticities, which are kappa 1, 2, and 3 here. We do this through a series of survey experiments that we conduct with the 1,800 households in our sample. First, we do a very simple stated preferences survey. We're going to use choice cards like this one, where we always have the same options, all the waste disposal options, the boiler taxis, the truck collector, communal container. Some households have availability for communal containers, and the option of burning or dumping their trash, and all the possible attributes, and we randomly change the values of these attributes. Households have to make 8 disposal choices, and then we can estimate the semi-elasticities that I highlighted earlier. Now, this is perfect, thank you. This is not incentivized, and we particularly care about their price elasticity. So we complement this exercise with incentivized survey experiments, a Beckett-DeCruz-Marsac elicitation exercise, and a take it or leave it. We do this with 2 randomly selected samples of households. Let me first explain the BDM. It's very, very standard, except we are doing it not for a good, but for a service. So we provide our own waste collection service to households and elicit their willingness to pay. So it's quite standard. We ask them what is the maximum bid they're willing to pay for us to pick up trash from them today. They draw a price at random from an envelope. If the price is smaller or equal than their willingness to pay, then households pay us the drawn price, and we collect waste from them in that given day. Now, this is not a standard service because the amount of waste that they have in a given day is variable. So we weighted every bag of trash, as you can see in the picture, to compute willingness to pay per kilogram of trash in a standard manner. With a subset of households, we do a simpler take it or leave it, where households just draw a price at random and they tell us whether they want to pay that price or not. And again, if they choose to pay, we collect waste from them on that given day, and they have to pay us the price. We also weigh every bag of trash, and it's also a good measure of the amount of trash that each household generates that we'll use in the model. These are the estimates that we get, the demand curves that we get with our 3 demand elicitation exercises. In black, you can see the BDM. In red, the take it or leave it with 2 different samples of households. These are statistically indistinguishable. The stated preferences is also relatively similar. It's a little bit flatter, particularly for richer households, but overall looks like good validation. So we're going to use the price elasticities from the BDM and take it or leave it, and the other semi-elasticities from the validated discrete choice experiment, which even if not incentivized, seems to line up well with what they report when incentivized. Great. Now, the second agent in our model are the waste collectors, the boiler taxis. And they're just choosing a collection disposal route. So an area of the city where they go and collect trash from households, and then a disposal site where they're going to dispose of the trash they collect. So this is going to be a standard commuting problem where collectors are going to trade off profits against their commuting costs. Profits are going to be determined by the fees that they charge to households, net of fuel cost, and the disposal cost that they have to pay at transfer stations or dump sites. We're going to assume that on the collection side, they operate in perfect competition. This is just the formalization. The value that a collector C that lives in home location H gets from going to locality A and disposing of at disposal site J is determined by the route profits, the travel distance, the whole commuting cost, and any differences in waiting times that are reported in the data, again with Campbell-Socks. The logic says allows us to compute the total flow of waste that arrives to its dump site in the city, which gives us the second waste pollution, the second cost that we need to take into account, the kilograms of trash that arrive to illegal dump sites, times this parameter that turns this into a social cost. It's going to give us this answer of social cost associated with waste at dump sites. Great. Now, the third agent in our model are going to be the disposal sites, the transfer stations, and the so first, before I say that, let me just show you visually the object that we're modeling for the waste collectors. This is based in our survey. This is the first part of the route from a home location to a collection area in the city. These are all the 400 waste collectors in our survey. And the second part of this choice is from a collection area, a neighborhood where you pick up waste from customers, to a disposal site. In red, you have the flows of collectors that choose to go to illegal dump sites. And in blue, you have those that choose to go to transfer stations. So this is what I just explained in the previous slide. Now, the third agent in our model are disposal sites. This is going to be standard oligopolistic framework where they're going to set disposal prices to maximize profits based on some local market power. So let me quickly show you descriptively why we're making that assumption. Here I'm showing you based on the app, waste collection transactions that then ended up being disposed of at a transfer station there highlighted with the big dot in green. Okay, so you can see that collectors didn't travel that far from the transfer site where they disposed of the waste they collected. It's a clear catchment area around the disposal site. If you look at another of these transfer stations, you see the same pattern. The collection transactions occur relatively close to where the waste ends up disposed of at the end of the day, and the same patterns holds for all disposal sites. Interestingly, for illegal dump sites, because they charge a lower price, we can see that the catchment area is wider. Collectors can afford to travel further, but overall, this is the whole pattern of collection and disposal throughout the city, and you can see there's going to be spatial differentiation, some local market power that we're going to allow disposal sites to take advantage of. This is going to be what determines the price that collectors see. We're going to estimate the second part of the model, holding what we learn about households, what we just estimated with a survey experiment through simulated method of moments, maximizing the fit between the data and simulated outcomes. And here with data, I mean our survey data, the app data, and the count data, the number of collectors arriving to its disposal site in the city. We validate this exercise by estimating a standard gravity equation where we add origin and destination fixed effects and eliminate any problematic variation at dump sites and collectors' home location. We get a very similar commuting cost estimates. And we're in the process of incorporating an RCT that we conducted where we subsidize formal disposal to validate as well the responsiveness to prices. Just going to quickly show you that the model does a good job at fitting the flows that we observe in the data. The first are the home location collection area flows, and the second one, the panel C and D represent the flows towards disposal. We also fit well data on disposal prices, disposal shares, the app data on collection prices, and the number of customers. Then let me very quickly show you, equipped with the estimated model, the main counterfactual exercises that we conduct. First, welfare is the sum of household welfare, BOLA taxi welfare, so collector welfare, the environmental gains, both local in the neighborhoods of the city and at open dump sites, profits of transfer stations, and profits of dump sites. And here I'm showing you how each of these components changes with the feasible policy, the first feasible policy, which is a reduction on the price of formal disposal. The government trying to get that price right. You can see that most of the gains comes from the reduction in environmental cost in green, but BOLA taxis and customers are also gaining from lower disposal and collection prices, respectively. Dump sites are going to lose their profits, and the transfer sites, now that they're forced to charge a lower price, will also lose profits. This is going to represent the cost of the policy. If the government wants to implement this policy, they're going to have to compensate the operators of transfer stations for these foregone profits. The aggregate welfare So all the benefit net of the cost for dam sites and the policy implementation cost is represented on the figure on the right. And we can see that we achieve net benefits with this policy. Interestingly, the best thing that the government can do with this second or third best policy is to halve the price of transfer stations. And what's important here is that this is not too far from a social planning allocation. Here, let me be very specific. We can think of, given the set of disposal sites in the city, the social planning allocates disposal and collection shares. This can be decentralized by setting Piguvian prices at disposal sites in the city. And that welfare gain with respect to baseline is represented with the blue dotted line. We can see that this limited price-based regulation, trying to just get the price right on formal stations and then letting the market operate, gets us close to that first best. The cost of implementing the policy, the foregone profits to transfer stations, represents around 55% of the current budget for waste management that the government is spending. So it's within the budget, but a lot of money. With net benefits, but a lot of money. And it's leading to a 25 percentage point reduction on the market share of dam sites, or a 34% reduction on illegal disposal. Now let's compare this, perfect, and with this I finish, with what the government is trying to do. The government is trying to expand new transfer stations. We already got the engineering reports with where they want to build them and the cost of building these transfer sites. In blue, I show you the percent change with our proposed policy, the price reduction letting the market operate, and in orange you can see the effect of building one of these, the better of these transfer stations. And you can see that in reducing environmental damage associated with waste pollution, the proposed government policy is less effective. And not only so, building one of these transfer stations will cost the government around 70% of their current budget on waste management. So the overall, and the government would have to complement this with acting on final prices on formal disposal of nearly 40% to get similar gains to what we get with our proposed 50% reduction. So I think overall, we point to this path of co-delivery of public services via informal markets, and this, perhaps in a sloppy manner, second best environmental regulation can control pollution with net benefits, making the extreme harms from trash disposal definitely not inevitable. So thank you very, very much.
Great. Thank you, Ignacio. Now we have a discussion by Ed Glazer. And
I'll just speak faster.
I'll give you time warning.
Great. So this is a terrific paper. And it's sort of, one of the best papers I have seen on solid waste in many, many years. For those of us who are in the trash research business, the sewer side has gotten more attention than trash has. It's great. It combines a transportation problem, which is why you heard a lot about, route destination, with a disposal problem. And, typically the willingness to pay at the household level for eradication, for transportation, is much higher than the household caring anything about what you do with the trash once you get it away from where you're located, which is a fundamental part of this externality. This is a parallel to in the water sewerage business. Households are willing to pay for clean water long before they're willing to pay for getting their slop away from their own houses, which is why many water systems are structured so that the water cross-subsidizes the sewers. This externality appears to be significant, and in some sense, solid waste is a slightly easier problem than sewers because the infrastructure is slightly easier, right? So the disposal sites are relatively easy, and you just got to get it far enough away. This paper has cross-sectional facts. It is a cool experiment. It is an interesting survey, and it is a structural model. I think there are elements in the structural model that are incredibly important. I think we want to think about getting ourselves to a production function for reducing waste in the area, right? And things like the willingness to pay of households to accept stuff, that's crucial. I am not nearly as convinced that the actual routes that anybody follows are particularly critical in terms of this problem, right? And I think it is interesting to think about spatial heterogeneity, right? In the sense that you could imagine that a subsidy that is, targeted towards one area is going to be more effective than the other. But I'm not that interested in like the other parts of this. And I think it's sort of important here, like just to remember when we sort of think we really want complicated structural models in urban space, when you are actually giving advice on a transportation problem, like where to put the buses, you sure as heck need a fancy spatial model, right? There's nothing else you can do it. If what you're doing is you're basically trying to figure out how much of a Pigouvian subsidy do I want to go on using this thing, like the actual routes that they're taking are not first order. Now, of course, another primary point of any structural model written at your stage in your career is to get yourself a great job. And of course, you've done that. So you can move on from that next to doing something else. Okay, so a couple of observations. So one of the things that is like obvious to anyone who's done any work in developing world cities is that the trash problem is a huge problem, right? And I sort of had this seminal moment in my life where I wandered through the streets of Dharavi in Mumbai, and I was both blown away by the energy and the initiative of this crowded group of individual entrepreneurs who are doing amazing things, and you're just blown away by that. And then you walk out and you see a kid defecating in an unpaved road where there's slop everywhere. Right. And this is, in fact, the sort of essential downside of density. And it's, a big part of our history in the West is dealing with this stuff. And that's why this is, in some sense, really important. Right. And that's the sort of thing that behind this. And for me, I wanted to sort of start more with a picture of what trash looked like in Accra. Right. So the gutters are great. I love this. This is like one of my favorite things. You're doing visual stuff on gutters, which is great. And the gutters seem to be where they're dumping stuff, but I didn't know why we were just limiting stuff to gutters in terms of looking for trash. And I sort of wanted a picture of I wanted as much trash pictures as I could possibly get, and something that is less sparse than this graph. So this graph seemed great, but I kind of wanted a more complete census of ambient graph. The other thing that I kind of wanted was the other big externality before I get, so this is one, and this is sort of, you didn't make much of this, and it's a cross-sectional thing. There's no identification on anything, but the places where there's more trash on the street, guys are getting sick. Okay. And I don't know if you could actually whether there's some sense of some subsequent paper that you do something creative on this, but it is true. And obviously they're also poor and they're also whatever, but controlling for other stuff, it does this. And then the second externality, of course, is the burning. And there are a lot of people in this room who know more about particulates than I do. So I'm not going to talk about sort of what you could do to measure particulates from these things on some regular basis, but you could surely do that given modern senses. And that's the sort of second big externality that would be good to know something about, because this is the second point. And in some sense, what's particularly interesting about this is there are sort of three actors to think about, right? There's the household, right, who typically wants to pay for removal, but not for processing. There's the collector who kind of just wants to dump it somewhere quick and get on with their life and pick up more trash, right? And then there's the person who owns the infrastructure, who seem to be, when you do the formal transfer sites, those people seem to be relatively controlled and they seem to be relatively well behaved. And then, of course, you've got the guys who, I got a lot of sympathy for the guys who are running the open pit dumping sites, because these guys are like entrepreneurs in a developing world city, but they have an incentive to burn stuff because that's the way they can deal stuff. And so dealing with those types seem important. And I think with private operators, the key questions can be subsidy versus punishment. For dumping facility operators and even collectors, right, there's also a question of public, private, and nonprofit options as well. And I think that's really important when we think about sort of infrastructure and we move towards infrastructure in this stuff, right? You really want to sort of have in mind this matrix of you can do public integrated, public separate, for-profit and non-for-profit, all of which have advantages in different ways. And one of the key things to remember of the independent private providers of these things is these great stories in the West of what happened when we had privatized trash collection. So we have a long history of street cleaning in the West. Street cleaning was actually more important than it is now because of the horses, right? And so you had incredibly unsafe stuff on the streets. New York originally, you can see these sort of scruffy employees of Tammany Hall over there. These were outsourced private guys. And the deal is they would take their checks, they would remit 50% of them to their Tammany Hall boss, and then they wouldn't do any work, right? The way that this got better was that actually George Waring, under the administration, I think, of Mayor Strong, sort of created this core of people who did the stuff. And so this moving back and forth, you want to think about the tendency of anytime you have a private provider, they have a tendency to subvert the government and to do stuff. I tend to think about the subsidy externality framework as sort of this. And this is a graph from a paper that I did with Nava Ashraf and Giacomo Ponsetto in the AEA paper proceeding. Along here, you want to think about how good the government is at running a justice system. Along here, you want to think about how wasteful the government is in terms of running a subsidy system. And remember, he can give guys little subsidies to do his collection. But if I imagine that actually be done by a government, I think that would be like a flow of corruption that would disappear, right? So you can imagine a nonprofit doing this in a way that's easier. But when the government is actually good at operating stuff, when they're not corrupt, then you just use subsidies. When the government is good at running the judicial system, i.e. you punish people without a lot of waste, you just keep fine. right? And then there's a space in the middle where you sort of use small fines. It's sort of the opposite of the Beckerian logic, which said huge fines and low probability of arrest, because what you get when you get huge fines is extortion of the innocent. And that breaks down everything. You need to keep the fines low enough so you don't, and this is part of my general sort of small punishment agenda where like, I think there are people who think about changing culture for like people who are open street defecation for kids who are defecating in the street. I think the right answer is a punishment, right? But my punishment is make them do math problems at a community center, right? So that's my strategy. I don't think that's going to lead to a lot of extortion of the innocent. I'm going to skip over this, like long history of this stuff. The other thing that's floating around that's sort of a useful scheme on this is thinking about sort of a rich world technology and a poor world technology at the same time. And that's a ready thing. Like when is it you want those Borla taxis to be better? That's the poor world technology. And when is it you want big lumbering trucks to carry stuff around with different things? That's another big question on it. Okay. So my proposed roadmap for the paper is one, document the cross-sectional facts about the problem, not starting with the services. So with the trash, with the burning, with whatever things we think are going on, then pull in your numbers on like how big the externalities are. Like you're not responsible for estimating that, just pull in other numbers on that. And you're going to do that both for ambient trash and then disposal sites. Then document the three-part disposal process. And so that's what you're strong at now. This is what they're currently doing, right? Households dump locally, and you did a beautiful job of that in the presentation. And then the surveys, the experiment in economics, I think the disposals are large. Changing their behavior should either be done top-down via regulation or fines or not at all. The secondary question is public-private. I think that like it would be good for you as an economist to know more about those costs. I don't think that belongs in this paper. I don't think you can do that here. But like you as like the world's budding expert in solid waste, like this is something you need to know about. You have excellent data on the willing to accept subsidies for bringing the trash to better places. This essentially maps out the subsidy sanitariness production curve. Right. And that's what I think you want to get to is something that actually gives us a production function that says, this is how much subsidy I throw in. This is what I get out of it environmentally. Right. Don't worry about the time of the guys. Don't worry about all the other stuff that's involved in the structural model. Like just tell the government what you would get if you do X. Right. And make that really plausible. You also know what it would take to bribe consumers to do less local disposal from your surveys. So that's your second margin that you're going to talk about. Like that again gives you a disposal, a sanitariness cash subsidy. And then you're going to know whether or not maybe you do a little bit of spatial heterogeneity on like I get more in one place versus the other. The ideal thing for me to have those two production possibility curves and then maybe thinking about bringing those together. Other things that seem important, you can't do punishments yourself, but that should clearly be in the policy possibility set. Punishing guys for burning lots of waste, that's a reasonable thing to do. We do it in the West. Is the supply of Borla drivers going to stay fixed over time, or will that decline as Accra gets richer? So that seems like a little bit more on this longer term supply curve. And if the public sector is actually going to run a subsidy program, like how much of that would get stolen? I guess you imagine is just reducing the cost at the transfer stations, and maybe that's okay. But any cash that goes directly to the consumers, that's like a recipe for theft. And finally, are there good ways to design things that reduce the theft? So maybe subsidy requires the household to show safe disposal, and that requires a chit from the safe disposer that's given to the driver. So lots of ways in which you get people to check on one another. But let me just end, right, as this is me doing septic tank cleaning in Manila, or I'm with Matt Turner in a sewage treatment plant outside of Cape Town. It's great to have you part of this community, and this is a wonderful addition.
All right, amazing. Ignacio, why don't you take a couple minutes to respond and everybody can line up with questions.
Great. Well, first of all, thank you very, very, very much for the welcoming to this wonderful community as well. The next paper is on sewers, so watch out. And then, yeah, so a few comments. I have to think a lot on everything, but it's true that now this is a paper that is first about estimating willingness to pay for waste on the household side, and then it's a transport paper on the Borla taxes. And it's true that the only way in which the location of dams and the flows that change matter is quantitatively. For the case of Accra, in a different place, it will be a completely different story. Then I think it would be a great idea to get more of the trash pictures and try to do a better job with maybe some additional data on getting these local damages right. As of now, they're just associations, and that's what we use to compute the welfare cost of of local waste pollution. What else do I have? I don't understand my it's true that we can combine with PM 2.5 daytime burning. We looked a little bit at that, and I think now we were also trying to get images of dump sites, and with the image of dump sites, you can also see when when there's fires, and try to get an idea of the share of trash that is being burned, and then get directly some estimates on that. Dealing with the operators of the legal dams, that's a good idea. Now they're starting to do a little bit more recycling, which might be an extra margin to operate with more of a carrot than a stick. Then I know that I'm being very unorganized. I think that's it. Oh, yeah, that's it. The rest are my notes. Thank you so much.
Super interesting paper and impressive data collection effort. This is awesome. I was wondering why in the model households are not burning their own trash, because it seems like that happens in a lot of developing settings as well, and why they are incurring in that cost. Maybe it's because it's way less costly, but that could also inform some of the pollution benefits of who's taking the trash. And the other thing related to what you just were mentioning, there's NBER's data is at 3 kilometers by 3 kilometers resolution. You could probably get information on where the fires are being located, and there's some research that has been calibrated at the level of to examine trash burning. So you can probably obtain some emissions factors to calculate total concentrations as well.
Great. Perfect. Thank you so much on the suggestion. We'll definitely do that. Households in the model can burn their trash, but we are bundling together with dumping. We're not distinguishing between these two. Currently, according to the census, it's a small percentage of households that do it. We estimate which lines up with the census, that around 20% when you take into account secondary options as well. But yeah, we allow them to do that.
Hey, thank you for a super interesting paper. First question is, so you assume that these drivers are competing perfectly. Is that what's actually happening? Are they colluding on the prices that they charge households? Second, how do we think of your BDM and take it or leave it? Is this something that happens on the spot and takes the households by surprise? So if you were to speculate, is this something that if they had more time or more cash on hand, they would respond differently? And third, just to check, so for the externality, use the associations that are showed. Does that include some PM generator, or that is not in the cost?
So on the last one, for now, we're just accounting for flooding. And that's it, not even the health damages. We'll have to do a little bit more there, just flooding, because then we ask them questions about assets loss, days loss because of flooding, and it's easy to convert that into monetary damages. And for the externality on the open dam sites, we're borrowing that from some case studies that do life cycle assessments of different dam sites. We have to also work on that. On the collusion, we asked in our survey whether collectors were part of informal associations, formal associations, or even WhatsApp groups. There's very low membership. And I mean, at least visually, the routes don't seem to indicate, based on their home locations or the patterns that we examined, that there's some collusion. We haven't done any formal test. The prices that we also see in the app data throughout the day seem to indicate that there might be some reasonable competition going on. In terms of the BDM and take it or leave it, it's quite yes. So we also asked households questions around whether this was repeated interaction with collectors, whether they can pay at the beginning of the week no, it seems to be always they pay each time someone comes, and most of the cases is a different Bola taxi. So those are questions that we ask in the survey. Yeah. Thank you.
This was a really cool paper. Thank you. I had a couple questions about the disposal sites and trying to understand more about their incentives. First, with the proposed the intervention that you're proposing, it would significantly expand the amount of waste going to the transfer stations. Do they have the capacity to accept that? Are there concerns about, there's 3 stations in the city. Can they accommodate that additional waste? Your counterfactual suggests that the subsidy is more effective than building the new transfer station. Should we understand that as the government is building the transfer station in the wrong place? or just that the drivers really value the relative prices much more than the travel time being important? And then lastly, in terms of thinking about the informal disposal sites and their ability to respond to the transfer sites becoming more attractive, have the existing informal sites been in the same location for a long time? Are they moving around? Could you imagine sort of more smaller sites maintaining their local power over a smaller, maintaining their market power over a smaller catchment area?
Great. So thank you for the questions. First, the capacity constraints of transfer sites. As of now, we're abstracting from that. They seem to be underutilized. We went there several times. There was a line of Bola taxis, but mostly because of the technology involved. They have to wait a little bit more because they have to weigh the trash and then compact it, and only then they can leave. But in the next version of the model, we want to add the capacity constraints because it might be important, given what we see in the kind of factors. Because as you explained, the flows are going to increase significantly. Then, in terms of the location of these transfer sites, we are currently just estimating it for the location where the government wants to build them. It could be that the location could be improved. We're trying to test that. We haven't done it formally yet, but we've tried to put it really close to one of the open dump sites, which are all close together, and still quantitatively, our proposed policy makes greater returns, which seems to be, and the government rationale for building these transfer sites is precisely cutting on the commuting cost. So they divided the city in different areas and tried to reduce the commuting costs that collectors face. But it seems that what we are is what you anticipated, that the relative prices versus commuting, the response to that is higher than the government may have anticipated. And then the informal sites currently only change their prices. They cannot do anything else. We ask collectors whether they get any influence from dump site operators. They don't do so. And we are also assuming that they cannot emerge. We're thinking of eventually estimating the cost of entry of these dump sites throughout the city. We observe that they emerge in clear areas. So there's not many available in the city. And now what we're doing is just tracing when they appear and try to get better idea on this. So thank you for the question.
Yeah, picking up on some of these themes, I know you got advice to get rid of yours or to not use some of your beautiful spatial data, but I love all the spatial data. And is there a third policy that you could consider as feasible? Would be that the government just has sort of sub-transfer stations scattered around the city where they literally just pick up the trash and move it to their own large transfer stations. Your data would be ideal for helping to figure out where those could go and whether that might be a cheaper policy. That's great.
We at a certain point we thought of doing an experiment that looked like that. We couldn't. True. Yeah. And in some cities, that's kind of the model. The government has bigger containers that function well, and there's not with tricycles because they don't have to travel that much. But there's last mile collectors that go with a cart or a wheelbarrow, and then they pick up trash from houses. So the government closes a little bit the room of the last mile. So that's definitely very interesting. Another policy that we're thinking is recycling is still very limited in Accra. But still takes place at dump sites and takes place as well at transfer stations. And improving that margin might be a way of subsidizing the price that collectors see. I don't know if there will be a pass-through to collection prices, but that's something that we're also thinking about.
I wonder if you could also price discriminate if you have sub-locations and they're sort of a different kind of operations. You could just charge a price at those locations.
Yep. Great. Thank you.
All right, that's a wrap. Thank you to all of our speakers, to all of our discussants, and to everybody for the thoughtful questions.